We can now begin setting up our Fullstack blog. This blog will have three main parts: the SQL schema in the PostgreSQL Database, the client-side blog with CRUD operations, and the node server with express routes and SQL queries. So make sure to download the starter project, which I will link in the next section. If you want to know how to build that app, the starter code, just see my other free React Redux course. And also keep the same directory structure that we've been working with that has a separate client and separate server folder. Just replace all the code in the client directory with the starter code. And also add the proxy localhost 5000 to the package.json file in the starter code. And with that, we can now begin. Hello everyone, and welcome to the first section of this course. Since this is a full stack course, we'll begin right away and set up a very simple full stack app. We'll have a very basic React front end that will display hello world, and this hello world string is going to come from a very basic Express server. So let's start by going in an empty directory and then creating two new folders, a client folder and a server folder. The client folder will hold the contents of our create React app command, and the server will hold our Express server. So let's just open a git bash terminal in our client directory and then just run the npx create React app command. And just so our project is not too nested, we can cut and paste the contents in the app1 directory back into the root folder. Next, we can open another terminal in the server directory and then run the express command. And we're able to run this express command because we already installed the express generator CLI command line tool. If you don't have that command line tool installed, see the associated section in the intro module. And if we look now in the server directory, we can see that Express did give us a fully functioning setup Express app. And by fully functioning, I really mean that it's standalone. You can run this Express app just by itself without a React front end at all. For the sake of simplicity, let's delete some unnecessary folders in our server directory. So first we can delete the routes folder. We'll use the routes later in more complex setups, but for now we don't need any routes. We also don't need the public folder, which just holds static assets, such as CSS and images and things like that. And since we're going to be using React as our front end, we don't need anything in the views folder either. But to have some structure in our server directory, let's create a new folder called main, and we can put our app.js file inside this new folder. Now in our app.js file, we can go in and delete this function right before the module.export statement. And again, we're just going for simple, so we don't need this function, and we'll set up more complex error handling in later sections. And since we don't have a routes folder anymore either, we can delete these two functions right here that make use of index router and users router. Next, we can go in our www file in the bin folder, and here let's change the port from 3000 to 5000. And again, this is because our React frontend is going to run on port 3000. And again, remember, these are two fully functioning apps, the React frontend and the Express server. So they'll be both running at the same time. And of course, because of that, they can't both run on the same port in localhost. And then also remember to change the import statement to /main/app, since that's where our app.js file is now located. So we're now done with the www file. Let's go in our package.json and then add a script for nodemon. So we can just go right under start under scripts and just add dev start. And then we can do nodemon./bin/www. And nodemon is really just a development version of Node. So you can essentially save and do development while nodemon is running, and you can't do that with just Node. And remember to also install nodemon if you haven't done so. It was one of the prerequisites in the intro module, so if you need to learn how to install it, just see that section in the intro module. And of course, if you don't want to install and use nodemon, you can also just use Node. Either way is fine. And important to note that by adding dev start under scripts, we can run our server by using npm run dev start as as opposed to npm run start, which will use node. So we're using nodemon instead of node. And again, this is only for development. In our actual hosting server, we would actually use npm run start to use node instead. So in the last video, we set up a very simple Express server with the React frontend. In this section, we'll cover exactly what Node, Express, and NPM is. So first of all, Node.js is a runtime environment that lets you execute code outside the browser. And this is important for things like making HTTP requests and SQL queries. And next, NPM is just a package manager. It essentially allows us to update, remove, and install third-party libraries. And third-party libraries is just another way of saying pre-written code. And finally, we have Express. Express is just a server that's actually run by Node. So essentially, the Express code is executed in the Node environment. So hopefully that gives you a better understanding about the differences between Node, NPM, and Express. So in addition to the third-party libraries that were generated by the Express command, we'll also be making use of 3 additional libraries. So first, we have the cores library. In this library, we'll essentially be used to help us communicate with our React frontend from our Express server. And the communication will happen through a proxy that we'll set up in the React app. And without this library, if we try to just communicate with our React app on the front end, we would receive a cross-origin resource error. And next we have the helmet library. And this library essentially makes our HTTP requests more secure by updating the headers. And helmet updates our headers automatically in the background. We don't have to set anything up in our Express server. And finally, we have the PG library. And this is the main library we'll use to communicate with our PSQL database. And this PG library is similar to the other libraries that are for other databases like MySQL. And that library is called MySQL.js. And in the same way, this PG library is what provides us a way to communicate with our PSQL database from our Express server. So we can now go back to our app and test to see if it's working. So first, make sure your directories and files are structured as you see here. If not, just see the last section and I'll walk you through the steps there. Next, we can open a terminal and then on the command line, just write npm run devstart. And remember, devstart is a user-defined command we set up in our package.json in the last section. And essentially, devstart just runs nodemon. And if we hit enter, and yes, we should be seeing this, our server is working. In the last section, we saw that our basic Express app was working. In this section, we will hook up our working Express server with our React frontend through a proxy. And this may sound complicated, but it's actually very, very easy. So let's go in our client directory, which holds our create React app. And inside our React app, let's go to the package.json file. And here we actually just need one line of code. Proxy in quotes, and then colon, and then our localhost 5000. And remember, localhost 5000 is a port that we're running our Express server in. And that's it. That's literally all we have to do to connect our React frontend to our Express server. And to test to see if our React frontend is in fact connected to our Express server, we can send some data from our Express server back to the React frontend. And we'll do this in a file called routes.js. So essentially how it will work is when a user visits a certain route on a React frontend, it's going to call our Express server, which will send some data. And you might be asking, well, how would React know that it's a route for the Express server and not just a route for React Router? We'll go over how React would know the difference in a later section, but for now, let's just go ahead and just set up the route anyway. So in our routes.js file, and remember this file is in the server directory under the main folder. So in this file, let's first start with Express and then do equals require Express. Next, we can do var router equals express.router. And .router is a given function from Express. We didn't have to set it up. And this router function, or more specifically, the result of this router function, which is saved in var router, is what allows us to make HTTP requests, as we will see in a second. So let's set up our first HTTP request. So let's do router.get and /hello. And again, /hello is the first argument in this function. And as you can see, it is a relative path. We don't have to do the whole localhost 3000 /hello. And then our second argument is actually a function that takes rec and res as their arguments. And rec just means request, is just short for request, and res is just short for response from the server. And then inside of our code block, we can do res.json and then pass in a string of hello world. So this is essentially what this is saying is response.json. So convert the server response to JSON of the string hello world. And again, obviously this is simulated. We're not actually getting this string from a server. And also note that res is not a reserved keyword or anything. Res is just the second argument in our anonymous function. And at the bottom, we can just do module.exports and then router. And then back in our app.js file, and remember this is app.js in the server directory, we can now import this routes file that we just created. And we can save it in a var called index router. So just do var index router require and then /routes. And it's / because routes is in the same directory as app.js. And then to use this router, we do app.use and then / because that's the default path. And then the second argument, just pass in index router. And now that we're done setting up our app.js in our server directory of our Express app, we can go to the React app and then set up app.js there. So again, this is app.js in client/source, which is our React project. So we'll first start off by deleting all the boilerplate default code. And here we're going to try to get our hello world data from our Express server. So we need somewhere to save our hello world response. So let's create a property of state called hello and set it to null. And then in our render method, between our two divs, we can do a ternary expression and then the condition of this.state.hello. And if this.state.hello is true, we can do div and then display the actual this.state.hello, which if our server is working should be the string of hello world. And if false, we can just do null. And then we actually have to do an API request to actually get the data from our Express server. And we'll use the Axios library to actually make the request. So go ahead and install and import it here if you have not already done so. So inside of our component didmount method, we can do axios.get. And if you need a refresher on React, or if you're unfamiliar, component didmount is just a function that's a lifecycle method that automatically gets called when the component renders. So if you're familiar with Angular 2, it's the ng on init function. It's similar to that. And then for the path, let's do axios.get /hello. And remember, /hello will match the path, the route that we set up in our Express server. And then we do a then, and then we do res, which is just short for response, arrow function, this.setState, and then we pass in hello, and then res.data. So the entire res object that we'll get from Express will hold a lot of data that we don't need to use. So to access just the hello world string, we do res.data. And again, .data is set automatically by the Express server. We didn't set it up when we were setting up routes. And if you're unfamiliar with the .then call, all it's saying is wait for axios.get to finish, and if there is a value, then do this. And Axios is promise-based, so it opens a subscription and waits for data to come in from the Express server. And you have to understand that Axios is promise-based, which is why we can change the .then call to it. And if you're not sure, promises are just a data type used for making AJAX calls. So if the promise resolves, which means the server sends back data, then we do the .then call. If not, we do the .catch error call. And this is really it. This is all we have to do to set up our API call to our Express server. So we can now begin going ahead and testing our app. And I should say we're testing our apps because we'll run both the Express server and React frontend separately. So open two different terminal windows in each of the directories. So one terminal window in the client directory and one in the server directory. And in the terminal for the server directory, just run npm run dev start. And in the terminal for the client directory, just use npm start. So now we have both our server and React app running at the same time. So if we go in our browser, let's go to localhost 3000 where our React app is running. And we want to go to our React app since this is the view and contains what we will see in the UI. And yep, if we go to our server, we do see Hello World right there on the screen. And we can be 100% sure that this is coming from our Express server backend because, well, let's go back to our editor. If we look in our app.js file in our React app, we do not have the string hello world anywhere here. We have hello, but we don't have hello world anywhere here. So the only place it can be coming from is our Express server. So in the last section, we made an API request to our backend Express server to get some data. In this section, I'll show you another way we can use Axios to make a request to a simulated server to get some data. And to help us with this, we'll be using JSON placeholder. This is a very well-known website for making simulated API requests, and this is what we'll be working with. And if you look through the JSON placeholder webpage, you can see there are many different types of data that you can request from this simulated server. And under routes, you can also see there are different HTTP methods that you can use, such as get, post, put, and delete. For now, we'll only be working with the get method and we'll get posts from the simulated backend. So let's now go back to our editor and begin setting this up in code. We'll begin by replacing our /hello relative path with the HTTP JSON placeholder URL. And remember to add the /post. That's how JSON placeholder knows that we're requesting posts. And for now, we can just console.log the response. And we need to access it with data, so it will be rest.data, the same way that we used for our Express server. And if we save and see, we are seeing our post console.log to the browser. So it is working as expected. I'll also show you another way we can use Axios to make requests that you might find useful. And this is using Axios as an instance. So outside of our class, let's create a const called Axios instance and set it equal to axios.create and then parentheses, and then let's create a property called base URL. And the value of base URL is going to be the entire JSON placeholder URL without the /post. So we're basically saying whenever we make an Axios request, we automatically pass in this base URL. So we can use this base URL to do /post, /comments, whatever. We don't have to write the entire URL over again if we want to make a request to different relative paths of the entire JSON placeholder URL. And then in our component didMount method, we do Axios instance.get. And remember, it's /post because that's the relative path we want. And the rest of the code we can leave as is. And if we save and see the browser, we see it's still working. We're still getting all our posts that we did before. So this is just another way of using Axios. You can just you can just create an Axios instance and then pass in a entire base URL. And once you do that, you can just use the relative path in your Axios request. So in the last section, we made an API request to the JSON placeholder endpoint with Axios. In this section, we'll do the same thing, but with fetch and the async and await keywords. So first, what is fetch? Fetch is vanilla JavaScript. It's not a third-party library like Axios. And because it's vanilla JavaScript, it can be read directly by browsers, whereas Axios has to be compiled. One downside of fetch is that you have to manually transform data. And unlike Axios, which does it for you automatically, fetch is also more verbose and, in my opinion, harder to work with, which is why I use Axios instead. So let's go back to our code and set up another request to the JSON placeholder endpoint, but instead this time with fetch. And we'll do the same exact thing. We'll just fetch post and then console.log them with fetch. So let's begin by creating another function, and let's call this function async function and set it up as an arrow function. And next, add the async keyword before the parentheses. And this keyword, along with await, is what allows us to make our API request smoother. So these two keywords work behind the scenes to make our HTTP requests more reliable and our code less error prone. And you don't have to do anything else. You just have to include these keywords. So just add async to any function if you want to make an API request before the parentheses, and then the await keyword before your request. And And the request has to be a promise. So await is basically saying wait for this promise to resolve. Then inside the fetch parentheses, add the entire JSON placeholder URL with the /post. Then after the fetch statement, we need a .then function which will do res and then res.json. And this will essentially transform our response to a JSON format, which was one of the points we went over in the slides. After transforming the data, the response, we'll need another .then statement to actually console.log the posts. And just to fix a typo, remember to add the arrow function. And let's also delete our first Axios instance request from the component didMount method. We don't want any confusion. We'll just have this async function call inside this lifecycle method. And this is it. This is all we need. We can now begin testing this request. If we look at the console, we see the posts are already there. But just to really make sure, let's reload the browser. And yes, we are getting our posts again. And since we don't have the Axios request, we are getting it from fetch. So this is essentially how you'd make requests with the fetch and await and async keywords. I personally think working with Axios is easier. In this course, we will be using Axios instead of fetch, but if you do want to use fetch, just refer back to this video and you'll be able to easily convert the Axios examples to fetch. So far in this tutorial, we've went over Axios and ExpressRouter. We have yet to see React Router, but in this section, I'll just briefly summarize these three libraries and how they work together. So let's first start with Axios. So Axios is what we'll use to communicate with our server through API calls. And we actually saw this in the very first section, if you remember. And again, remember how we did this. In Axios, we did /hello, which matched the path in our Express server. So our API returned a simulated server response, which was, remember, just a string of hello world. And Axios can communicate with any other endpoint as well. And remember, we saw this with the JSON placeholder. We made requests from Axios to the JSON placeholder endpoint, which gave us a simulated server response. And finally, Axios is promise-based. And remember, a promise is just a data type for working with asynchronous requests. So because Axios is promise-based, we don't really have to transform our data. Once it's retrieved from the server, Axios automatically resolves the promise. This also allows us to chain .then statements, which allows to run certain functions after the promise resolves. Next, we have ExpressRouter. ExpressRouter is mainly used to communicate with our database. And ExpressRouter can communicate with our database because it uses Node as the runtime environment. And remember, Node can execute code outside of the browser. And this is essentially what allows SQL queries to be possible. And again, we can't do this with Axios. We can't pass in SQL queries directly from Axios in our React client-side app. And Express is also a more secure way to make HTTP requests. It has certain libraries like Helmet, which update the headers and just make the overall HTTP requests more secure. And the promise resolving just means the server successfully returned some data. But of course, the obvious downside is that Express is server-side only, but we're allowed to communicate with Express through React, through cores. And we will discuss cores in more detail in the next section. And finally, we have React Router. React Router is essentially used to navigate within our app. We can't make any API calls with React Router. It is only for navigating our React app. And at this point, you might be wondering how our app knows that whether a route is React Router or an Express API call. And the answer is that it handles all of this behind the scenes. When we make a route, the first thing that's checked is if the route is for React Router. If not, if none of the paths match for React Router, then it's moved on to the Express server where it's checked if any of the routes match. And this is how routing is handled and how our app knows the difference between React Router and Express. So in the last section, we saw how Express, routing, and React Router work. In this section, we'll go over CORS, which stands for Cross-Origin Resource Sharing. To give you a basic summary of what CORS is, it's essentially a React frontend that's running on localhost 3000, pretending like and making requests as if it's located at localhost 5000. And it's doing this through the proxy. And again, the proxy is something we set up in the previous section. So it's a little bit where cross origin comes from. So our original origin is localhost 3000, but then we're crossing origins, and then we're making it appear as if the origin is from localhost 5000. So let's look at a sample Axios request on the right hand side. So we have axios.get/api/getPost, and this is similar to the /hello we saw in the first section. And notice it's a relative path. We're not specifying an origin or a host for this path. And because it's a relative path and it's located on our React front end, which is running at localhost, when we do axios.get/api/getPost, we're really doing axios.get localhost 3000/api/getPost. But because we're running a proxy, we're doing it as if it's located at localhost 5000. And remember, our Express server is also running, so this means localhost 5000/api/getPost matches the route that we set up in our Express server. And because the routes match, the code inside the code block is executed. So basically, our localhost 3000, which is our React, is pretending to be localhost 5000, which is what allows it to make API requests to our Express server. So this is basically what CORS is and how our React frontend communicates with our Express server. So before going further, I'd like to address an issue you might have. In other tutorials, you might see them using an ORM library such as SQL to make SQL queries to the database. I won't use any ORM in this course, and in this section I'll try to explain my rationale as to why. So first, let's discuss what an ORM is. An ORM stands for Object Relational Mapping, and it's essentially a library that sits in between your app and your database, and it allows you to make SQL queries a little bit easier. And an ORM has its own syntax and its own way of making SQL queries. And there's nothing wrong with using an ORM. I personally just prefer working directly with the SQL. When I first started web development, I worked directly with the SQL, and it's what I've grown used to. I honestly just find it easier than working with an ORM. And even though an ORM's job is to make SQL queries easier, I just find it easier just to work directly with the SQL. So the second reason I don't use an ORM library is because SQL gives you a more fine-grained control over the code. Because as mentioned, an ORM sits between your app and the database. So it's just an extra layer or middleman between you and your database. And because of this, you can't really do everything you can with SQL in an ORM, and which gives you less fine-grained control over your database. Now to the third reason. The third reason I don't use an ORM is there's a lot more resources on SQL. So if you have an error or a question in your code, it's much easier to find a solution for SQL than it is for an ORM library. SQL has been around for decades, so it's had a huge time to get refined and perfected and have a lot of documentation and resources for SQL. And this isn't the case for ORM libraries. So basically, the amount of documentation and resources for learning SQL gives it a huge advantage over ORM libraries. And the last reason I directly use the SQL is because the ORM library takes time to learn, and the knowledge isn't transferable to anything else. And SQL is the most used database language by a very wide margin. Last time I checked, it's around 90% of commercial databases used SQL. And learning one SQL system such as PSQL will allow you to directly transfer those skills and knowledge to another SQL system such as MySQL. And again, the ORM library, you can't transfer any of those skills or knowledge. When you learn that ORM library, you just learn that one. And so those are my reasons for not using an ORM library, and I highly recommend you do the same. And an ORM is just another layer of complexity you're adding to your app. For example, if there might be some breaking changes with updates to the ORM, you have to go back in your code and make your syntax work with the updated version of the ORM. And this is not true for SQL. SQL has been the same for a very long time, and the breaking changes are very rare. So with an ORM, you're just adding another layer of potentially unnecessary complexity to your app, which will make your app less reliable. So in the last section, I covered why I don't use an ORM in this course. Keeping with the theme, in this section, we'll go over why I didn't use Redux form. Redux form is a popular library commonly used in React Redux apps, so why not use it here? Well, I tried Redux form and I simply could not find a use case for it. We have to always keep in mind that the final case usage of what we're trying to do, and I couldn't come up with a scenario in this app where we would need to save the form data in the global Redux state. In this app, we simply take the data from a regular form and pass it to Axios, which then passes it to the Express server, which then finally saves it to our database. So there's no need for Redux in that flow. The other possible use case is for our edit post component, where we might need Redux form, but I simply handled that by passing in data through a property of the link element. And so because of that, I really could not find any use case for it at all. And you can try Redux form and see if you can come up with a clever use for it, but we'll not need it in this app. And another thing to keep in mind is that any functionality offered by Redux form can be accomplished relatively easier without it. You can simply set up forms much easier with just using regular React and Redux. So if you follow the directions from the last section, you should have a directory that looks like this. And we will begin creating our Fullstack blog by first setting up the database, specifically the SQL schema. And this schema is essentially what will hold the shape and structure of our database. So go ahead and set up a SQL schema file in the main folder of the server directory. And important to note, even though we're creating a schema.sql file, this file itself does nothing. Even though we're creating and setting up the tables here, to actually use it as a database, we have to paste these in as commands to the PSQL shell. This is all something we'll see in the next section. And again, just to reiterate, this schema.sql file right here that we're going to create does absolutely nothing. It's just here so other people can understand what our SQL database looks like, and they can just copy and paste these commands into their own database if they want to set it up. So this file is basically just like a reference. So here in our schema.sql file, I'll first start by writing all the code, and then I'll explain each line afterwards. So the first table we'll need is the users table, which will contain all the user profile data. The next table we'll need is the post table, which will hold all the submitted posts. And finally, we have the comments table, which will hold all the comments for all the posts. So let's break down each field and what it means. So let's start at first at the top with the users table. So our first column is UID serial primary key. And how you read SQL is everything in lowercase is user-defined names, and everything uppercase is SQL code. So the first way to read this is UID is the column name that we defined, and then serial primary key is the structure of that column. And serial primary key means this is basically the unique ID associated with each user, and it's auto-generated by PSQL. We don't have to do any randomization function to generate a unique number. To just make sure our user ID is unique, we just need to include the serial keyword. So serial and primary key are two different SQL commands. Next, we have username varchar 255 and then unique. And this just means a username column with varchar, which means the number of characters that are possible for the username, which we want to limit to 255. And finally, we want each username to be unique. So we just pass in the unique identifier. And varchar and unique are two different SQL commands, as we see in the next column, email. Email, we just have varchar 255 and we don't use a unique keyword here. And then email verified after our email, and this is just a boolean, so it can be either true or false. And after that, we just have date created with a type of date, and the date will actually come from PSQL itself. We'll just use a PSQL function to set the date, and the date will actually not come from our React or Express server. We can just set the date with PSQL itself. And after that, we just have a last login column, which is also a date. And after that, we have our post table. And the very first thing we need to do is have a primary key, which again just assigns a unique identifier to each post in the post table. And then we have the title of the post, which we'll limit to 255 characters. And after the title, we have the body. In this one, we'll just leave varchar. We won't set a limit for the body because certain posts can be very long, and we just want to have our users the ability to just submit very long posts. So for that reason, we'll just leave varchar without a limit. And after that, we have our user ID. So user underscore ID is a user-defined column name that we set, and then it's an integer, and it's referencing the user's table and user ID column. So altogether, how you would read this is user underscore ID is a column in the post table that's referencing the UID column in the users table. And this is the main function of SQL, is to have references in relations like this, so that when a user submits a post, their user ID is automatically associated with it in our database, which we can then use to look up their post using their user ID. And after that, we have the author field, which just holds the username of the user that submitted the post. And this one is a varchar type. And I don't know if I mentioned this, but varchar means variable character. And again, this is the same data type we set in the username field in the users table. And finally, we just have the date created, which is a timestamp type. And timestamp includes the time in addition to the date. And lastly, we have the comments table. And the very first row is, of course, the primary key ID, and this is the same as the other two tables. And then we have a comment field, which will hold the user submitted comment. And after that, we have the author, which is the same as we saw in the post table. And after that, the user ID, which references the users table and the user ID. And also the post ID, because remember, all of the comments for every post is going to be contained here. So to only get back the comments that are associated with a certain post, we need to reference the post ID. And we do so like this, just post and then PID. And finally, we have the date created, which is just the timestamp and when the comment was created. And this is it. In the next section, we'll actually copy and paste these commands into our PostgreSQL database and actually set up the database itself. So in the last section, we created a schema.sql file and wrote some SQL commands. But as we know, that doesn't really do anything. We actually have to paste these commands into our actual database command line tool. So let's do that now. Let's first open the PSQL shell. So just go in the PSQL folder and click on the PSQL shell. It's downloaded and installed for you automatically when you install PSQL. So if you haven't logged into the shell at all, your screen might look different from this. Just follow the instructions and set up the default username, password, and host you have, and leave everything default. But if you've already signed in and set up your account, your PSQL shell will look like this. So go ahead and just log in as normal to the PSQL shell. So the very first thing we have to do is actually create the database. And this is very simple, just to create database and then mydb and semicolon. If done correctly, you should see create database displayed to the screen. And now we have to connect to this database, so just do /c and then mydb. And just to note, whenever you see commands such as / and then lowercase letters, that means it is a PSQL specific command. Whenever you see capital letters like create database, that is an SQL query. So / means PSQL command and capital letters means SQL query. So now we're connected to the MyDB database. And the very first thing we can do is /dt. And this will, if we had any, this would give us all our lists of tables. And because we don't, and this is a new database, we see did not find any relations. So let's add some tables to this database. So let's go back to our schema.sql file and literally just copy the create table commands and just paste them into the PSQL shell, like so. And also make sure that you're seeing create table after each query. If not, you may have made some error. And the most likely error is that you didn't include the semicolon. And if we run the /dt command now, we do see, yes, all three of our tables are here. So it was successful. Awesome. In this section, we'll set up the actions that we'll need for our front-end React app. And the first action we'll need is set DB profile. This will save the profile data we get from our PSQL database to the Redux store. We'll use this action in the auth check component, which we will set up after our reducer. And we also need the opposite action, which removes the DB profile from our Redux store. Our next action will be fetch DB posts. This will save the post that we get from our PSQL database to the Redux store. And we also need, of course, one to remove the DB posts. And finally, we have fetch post comments. This will save all the comments associated with a certain post to the Redux store, and not all the comments for all the posts. And now let's set up action creators to use with these action types we just created. And to save a little bit of time, we can just copy and paste some code instead of starting from scratch. So our first action creator can be setDBProfile, which dispatches the setDBProfile action type. And we also need one to remove the DB profile as well. And we can set up the other action creators in the same exact way as well. And remember to pass in profile as an argument to the setDBProfile action creator, posts as an argument to the fetchDBPost action creators, and comments to the fetchPostComments action creator. And we can add another property type to set DB profile and then called payload and then set it to the value of profile. And in the similar way, we can do this with the post and comments action creators as well. And we're done setting up the actions. In the next section, we'll set up the reducer to work with these actions. In the last section, we set up our actions. In this section, we'll set up the reducer to work with those actions. So let's start with our first action, which is setDBProfile. And we don't need to create another reducer for this one. We can just add it to our auth reducer since it is user profile data. So let's go in our auth reducer file, and under the profile property in the initial state, let's add a third property called DBProfile, which will of course hold the user profile data from our database. And let's add a couple of case statements, and we can just copy and paste the code. We don't need to start from scratch. And we can just change the add profile action type to setDBProfile. And also remember to change the profile property to DBProfile. And we can do the same thing with the remove DBProfile action type. For our posts and comments action types, we will need another reducer. So let's just copy the code from auth reducer and then paste it in a new file called postreducer.js. So after pasting the code, we can make the required changes. So let's delete everything from the initial state and add two empty arrays called posts and comments. Next, let's change the action types from login success to fetchDBPost. And also change the property from is authenticated to posts. And we need to set post to action.payload since that's where all the posts are contained. And we can do the same for removing the DB post. Now we need to set up our action for getting the post comments. So we can just change the action types to fetch post comments and set it up in the same way we did for the posts. Then we can just add remove post comments. And we can delete the last two case statements since we only have 4 actions for posts and comments. And also remember to change the profile property to comments. And finally, we can just change the name of the reducer from auth reducer to post reducer. And let's actually change comments from null to an empty array. And we can't forget to add this reducer to the combine reducers function. So let's just open up index.js and import the post reducer here. Then we can just set a property of post reducer to the actual post reducer. And we're done setting up our reducers and actions. In the last sections, we set up our reducers and actions. In this section, we'll set up our auth check component, which will save our user profile data to the database. And the database is also something we set up in the previous section as well. In this auth check component is something I actually set up in another beginner React Redux course. If you want the full details on how to set it up and how it works, just see that course. It's a free course. You don't have to pay anything to use it. And I go into great detail in that course about how this auth check component works. But just a brief summary, it's basically a component that renders every time a user logs in and logs out. And it's an empty div, so the user doesn't see anything on the screen. It's almost like it runs in the background. And currently it's set up to update the authentication state of the user to the global Redux state. So whether a user is authenticated or not is determined and changed here. In this component, we're also saving the profile that we get back from auth0, which we're using as our authentication API. Auth0 sends us the user profile data in JSON, and here with the add profile property of dispatch to props, we save it to the Redux store. But this profile data that we get from auth0, we also want to save in our own database so we can run queries on it. So we have to create another Redux action to save this profile data in our own database. So we will do everything here. We will actually get the profile from auth0, we will save it to the database and then immediately retrieve it from the database that we just saved it in. And by retrieving it from our database, we now have access and can associate this user profile data with whatever the user does, such as making comments and making user posts. So this helps the user from, for example, having to write their username and user ID every time they make a post and comment. It's done automatically for them. So let's begin setting this up. So first let's add a property to the map dispatch to props function called setDBProfile. And this is what will save our profile data from auth0 to our PSQL database that we have set up already. So we can set it up as a normal arrow function, and we need to pass in profile as the parameter and then dispatch actions.setDBProfile. And remember, setDBProfile is the action creator we have already set up in the previous sections. And we also have the opposite action, which just removes the DB profile from our Redux store. And remember to pass in profile as an argument to the setDBProfile action. We can now begin to set up our sendProfile2DB function, which is the function that will send the user profile data to our database and also retrieve it immediately afterwards, so we have it to use in our Redux store. So our function will take a parameter of profile, and we can save this in a variable called data. After that, we can make an axios.post request to /API/post/userprofile2DB. And we'll set this up on our Express server in the next section. And after the route, also declare a second argument and just pass in data. And this is the same data that we just declared on the previous line. So after saving the user profile data to the database, we also want to immediately retrieve it, because when a user first signs up for our app, they should also be logged in. And this should be done automatically. And this is how to implement it here. And if a user is already signed up and in our database, we will do nothing. And this will be handled with SQL, not over here in the React side. And of course, we'll see this when we're setting up the Express routes. So after the Axios post request, we can chain a .then statement onto it. And inside of the .then statement, we can do an arrow function with an Axios get request. And this will be another API call to our Express server, and it will be API/get/user profile from DB. But of course, we need some way to know who we're looking up in our database, and we will do that with email. So how we do this is we create an object with the params property. Then as the value, we create another object inside, and it will itself have a property called email, and then the value will be profile.profile.email. And remember, profile is the parameter we passed into the send profile to DB, and that's where we're getting our email. So we're looking up our user that we want to get from our database with their email. Then after this, we do yet another .then statement. And pay very close attention, this .then statement is calling or is chained to our axios.get request, not our first axios.post request. It's chained onto the second axios request. And it's actually inside of our first .then statement. And we'll use the second .then statement to save the user profile we get from our database to our Redux store. So we already have our user profile that we're getting from auth0 saved, but we're also saving the database version of that profile as well. And this is because the database version has its own user ID property, and we can't access that property from auth0. So if we want to make user ID from the database relational to our user posts and comments, we have to use the user profile data from the database. So in our second .then statement, we can just do an arrow function with the res, which is response, and then this.props.setDB profile, which is again just the name of the property we set in map dispatch to props. And then as a argument, we can just pass in rest.data. And again, remember, rest.data contains the actual JSON usable object that we need instead of the whole response object. And finally, we can just redirect the user to the home page with history.replace. And finally, we just need to call this function, which we can do in the component didMount method. And we can add it after the this.props.add profile action creator. And remember to also pass in this.props.auth.user profile as an argument, because this is what contains the actual user profile data from auth0. And of course, if you want a detailed explanation on how this entire auth check object works, just see the free React Redux course on my profile page. And again, it's free. It will go over exactly how to set this auth check component up from scratch and how it works. And in the else statement, also remember to add the remove DB profile action creator. And finally, just import Axios if you have not already done so. So as you previously saw in the last sections, we already set up our database, but now we need to connect our database with our app. And we do this through the PG library in the Express server. And this PG library is what will essentially allow us to communicate with the database we already set up in localhost. So let's first begin by creating a db.js file in the main directory. Next, we can import pool from the PG library, and this pool object will be what will essentially hold the credentials, the login credentials for our database. So after that, we can create another const called pool with the lowercase p, and then set it to a new pool object. Then inside the parentheses, we initialize curly brackets, and in these curly brackets, we will store the credentials in a key value pair. So the first key will be user, and it will be a string of Postgres or whatever the name of the user you set when you were setting up PSQL. Next, we have host, which will just be localhost. And when we set up the database in AWS, we will see how to do different endpoints that are not localhost as well. And after that, we have database, and this is referring to the name of the database. And remember, it was MyDB that we set as a name. And again, just substitute whatever name you set for your database. And then we have the password, which I will leave blank for obvious reasons, but just go ahead and substitute in whatever password you set. And finally, we have port. And this will be 5432. This is the default port of PSQL. And notice it's not a string, unlike all the other properties. So just make sure that you're not setting the port as a string. Just leave it as an integer. And finally, we can just export module at the bottom. And this is really it. This is all we have to do to initialize our database and begin using it. So now we can begin to set up our routes. And just so you know, we're setting up our Express routes before building out the client-side blog. So for all of these routes, we haven't yet set up the client-side version of these CRUD operations that we're going to see in a second. So yeah, just again, we're setting up the Express first, and then we'll set up the client-side blog. So let's first start by going in our routes file, routes.js file, and importing the pool object that we just initialized in the last section. So to import it, we just do var pool equals require./db. And then as a comment, we can write post route section. So this will let other engineers know that this section will hold the routes for the posts. So we can now begin setting up our routes. So our first one will be to get all the posts. So we start off with the router.get. And remember, get is an HTTP method that basically says we're getting some information from the server. So you would not use .get for any other routes besides getting data from the server. And we'll see like there's different words for whatever type of request you're making, like .put and .post, which is posting data to the server, and then .delete, which obviously is deleting data from the server. So there's each CRUD operation has its own word that you have to use when making a request. And then the actual route will be /API/get/all posts. And this naming scheme is important because /API tells us this is an API request. /get tells us this is a GET request, and /all posts is saying what we're getting from the server. So our first argument will be a string of the relative path, and our second argument is actually going to be an arrow function. So let's declare 3 arguments in the parentheses: rec, res, and next. And rec means the request, res is the response, and next is a middleware that will help us with error handling. So we'll now declare curly brackets for our arrow function, and we'll do pool.query. And remember, pool is the same pool that we set up in the db.js file, and .query is a given function that we can use to make SQL queries. So we'll need to make a SQL query to get all the posts from our database. So this is a very basic query, and it's going to be select star from post order by date created. So select is the keyword that we use when we're trying to select certain rows from a column. Star means all. So select all from post. Post is a table, and then order them by date created, descending. Descending meaning the newest post first. So for the second argument of pool.query, we will need yet another arrow function, and this is going to be nested inside the first one. So this arrow function will take 2 parameters, QErr and QRes. QErr means query error, and QRes means query response. And inside the code block, we'll do res.json and then pass in QRes.rows. So res.json means the response will be turned into JSON format, and what will be turned into JSON format would be the query rows. So remember, when we make SQL queries, we get back rows from a column or a table, and in this case we're getting all of our posts from the post table. Next, we'll set up a post request to save a post to our database, and this will be /API/post/post2db, and in the same way it will require a arrow function as the second argument, and this will be set up the same way as we saw in our previous route. However, unlike our previous route, we actually need some data from our front end for this route. We're not just arbitrarily getting all the posts from the back end. We need to save some data from our front end client. So how we do this is we first create a const called values, and then we create an array, and then each data from our front end is contained in rec.body.title. So the entire rec object is pretty large if you console.log it. All we need is the data from our front end. So we do rec.body.title. So the body of the request contains the title we got from our front end. And we do this for body, the body of the post, the UID, which is the user ID of the user who submitted the post, and the username of the person who submitted the post as well. So we start off with pool.query again, and then the SQL query to submit a post to a database would be insert into post, in parentheses title, body, user ID, author, and date created. And then we do the values. Values would be $1, 2, 3, 4, and then the now function. The now function is a given PSQL function, and we can use it here like so. And $1 means the first argument in the array. And same with 2, 3, and 4. It's saying the first, second, third, and fourth argument of the array. And notice it has to match up with the order that we declared it in post. So insert into post, and then title, body, user ID. The title is the first column of the value we're going to insert. So your first element in your array has to be the title, because the first argument in the post parentheses is title. So it has to match up and line up. So your values, every element in the values parentheses has to match up in the post parentheses. And also one thing to note, if you want to do multi-line SQL queries like so, I'm not using parentheses, I'm actually using backticks. So backticks are the symbol that's it should be the key under the escape key on your keyboard. So they're not parentheses. Notice they're backticks that I'm using to make this SQL query multi-line. And then next we pass in values. And again, this is the const values array we set up, and we pass it in here separated by a comma. And then we do the QArrow and QRest arrow function that we saw in the last SQL query we set up. And here I'll also show you how to use the next middleware. So we do if QArrow return next QArrow. And this is basically a better version of handling asynchronous errors. So if you have a synchronous error in Express, it can be handled easily. You just do throw new error and then pass in a string. But with next, it makes it easier to handle asynchronous errors. So next, basically, if you get an error, next basically passes on the error to the next handler that actually processes it. And this is what makes it have better asynchronous error handling. And then the next array, we can just do rest.json qrest.rows. But remember, this is a post request. We're just sending data to the database. So in our response, what we're going to get back is a status code from the server. And if everything is working, we should get back a status of 200, which means the server sent back a okay, everything's working code. So next we have a put request, and this is the update request in the CRUD operations. So CRUD is create, read, update, delete. And these are the four main basic operations that you see in web development. And put is the update of this CRUD operation. So we do router.put and then API/put/post. And then the same way we do rec, res, and next as in the arrow function. And then we also need values here as well, because we're going to be sending data to the database. And we do the same exact thing. We do title, body, user ID, and we also have a new one, PID, which is going to be the post ID. Because remember, we're making a put request, so we have to look up the post that we want to update, and we do this with the post ID, which is PID. And finally, we just have the username. So in the same way, we do pool.query, and then the put request in SQL is going to be update posts. So update the post table and set title equal to $1 and then the same body, user ID, author, and date created. And we don't use the PID here. We're not setting the PID because it doesn't change. And again, $1 just means the same thing it did in our post request. It is the first element in the array, but instead of having a separate values clause, we just set it here like so. Then we need our where clause, and this is the condition we're going to use to look up our post. So the where is just going to be where the PID is $4. So update the post, set the title to this, this, and this, where our PID, our post ID, is equal to the PID. And then we do comma values, and again, this is the same values. We set up the array of values, and then another comma, and then QArrow and QRest. And we'll just do rest.json QRest.rows. Since again, we're sending data to the database, we're not expecting anything back. So what we will get back is the status code, and this will let us know if everything's working. And now we have our delete route, or I should say routes, because we will need two routes for handling delete operations. So the first one will be to actually delete the post comments, because we can't just directly delete the posts because certain posts will have comments associated with them. So if we delete the posts, then we'll just have a bunch of comments sitting in our database that are not attached to a post. And not only that, but we can't even do this in PSQL because of the foreign key constraint. And we'll discuss foreign key constraints in a later section, but we just have to know that we can't just directly delete posts because they might have comments with them. So let's first create a route for deleting the post comments before deleting the actual post. So we can do /API/delete and /post comments. And then the same exact way, we need an arrow function as the second argument. So how we will delete comments is by looking the comment up with its associated post ID. Remember, when we created the PSQL schema, we set up each comment to reference a post ID, and this post ID is exactly the same as the post ID that's in the post table. So because of that, we can just delete all the comments associated with the post by just using the post ID in the where clause as a condition, and this will easily just delete all the comments associated with a post. And of course, this post ID is going to be coming from our React front end, and we can just save it in a const called post ID, and it's going to be contained in rec.body.postid. So our SQL query can be very simple. It's just delete from comments where post ID equals $1. And remember, comments is a table that contains all the comments. And post ID is actually a column in each comment that is referencing the post ID, the PID in the post table. So the post ID is actually a column in the comments table that's just referencing post ID, the PID. And then after our SQL query, we do comma and then array post ID. So this is another way to pass in values. You, instead of wrapping rec.body.postid in an array, you can just wrap it in an array here. And then comma and then qr and qres as we've seen before. And in addition to receiving the server status code, we can also console.log qr. And now that we have the delete route for deleting the post comments, we can now delete the actual post. And we'll do this with the post ID as well. So we can save the post ID in a variable and then pool.query delete from post where post PID equals $1. And that's just the post ID. And on our React frontend, we'll actually be calling these two functions sequentially. So we'll run the delete post comments first on our React frontend, and then immediately call this one right after. And similar to the other functions, we can just do qerror and qres, and then console.log the error and get back the server status code. And this is it. This is the 4 main routes we'll need. These are all our CRUD operations. So these are the main routes we'll be using for our blog for making posts. And in the next section, we'll see similar CRUD operations for the comments. So in the last section, we set up all the routes for the posts. In this section, we'll set up all the routes and the SQL queries for the comments. So we'll first start off with /API/post/comment2db, and we'll need our rec, res, and next arguments. And I'll go a little bit faster in this section since we basically did the same identical thing in the last section with the posts. So in the body of the arrow function, we need our const values. It'll be rec.body.comment, and then same thing for user ID, username, and post ID. And since this is a create operation, we do pool.query and then insert into comments, and then comment user ID, username, and post ID. And then date created will just be created with the now function, and we're not getting the date from our front end. And then we'll set up our values in the same way we saw before, and comma, and then we pass in the values array, and then another comma, and then we need our qres and qerror arrow function. And then in the same way we've been doing, we can just do response.json qres.rows and then console.log the qerror. And we can work a little bit smart here and just copy this entire function and then paste it, and we can modify it for the put request. So now we can change the route from /API/post to /API/put. Then we will need our post ID as the third argument in the array. And then the last element in the array will be the CID, the comment ID, since that is what we will look up the comment with. And next we can refactor our SQL query from insert to update comments. And then we need the set keyword. And then we just set the column to the respective element in the array that matches that column. And again, this is all something we've seen before. And then we just use the where clause to do where CID equals $5. And then after that comma, we just pass in our values array. And then another comma, and then we have our query arrow function. And finally, we need our delete function. So we had the delete all post comments in the last section, and this function is just to delete a single comment. We're not deleting all the comments associated with the post. So we can start by changing the API/put to API/delete, and then we can get rid of values since we only need the CID, which is the comment ID. And then our SQL query is going to be delete from comments where CID equals $1, and then comma, and then we do the array with CID, and then another comma in our query arrow function. And again, since this is a delete, we're not getting any data back, we're just getting the response of the server status. And we can also just console.log queue error. And then our final route will be to get all the post comments. So let's just paste the function that we've been doing so far to save us some time. And again, this one's going to get all the comments associated with a post. And we can get rid of the CID because we will need the post ID, and it will be equal to the string of rec.query.postid. And then we have a very simple SQL query. It will be select star from comments where post ID equals $1. And again, this is just select all the comments from the comments table where the post ID matches the post ID we got from our React front end. And then comma, and we just pass in the post ID, and then comma and our usual arrow function. And we are, since this is a GET request, we are expecting a response. In the response we access in the same way, rest.json qrest.rows. And this is it. This is all the routes and queries we need for having a usable forum for the comments and posts. And in the next section, we'll create express routes for saving the user profile data to the database. So in the last sections, we set up our routes for the posts and comments. In this section, we'll set up our routes for the user profile data. And we'll only need 3 routes. One to save the user profile data to the database, one to get all the user's posts associated with the user, and one to get the actual user profile data from the database. So let's start with the user profile to database, our post request. So we can set this up in the same way as we've been seeing so far, with the /api/post/user profile to db, and then a request next arrow function as the second argument. And then we'll save all our user profile data in a const called values. And this user profile data is not only coming from our React end, but also auth0. So our React frontend is getting the data from auth0, which is then passing on here to our Express server. So this is the rationale again behind this, is the user should not have to submit their own profile data to the database to save it. And then the SQL query we need is the very basic one. It's just insert into users, and then our username, email verified, and date created, and then the values as we've seen. And we also need on conflict do nothing. And this prevents a user from having their user profile data saved more than once into the database. Because remember, we're going to call this route every time the auth check component is called from our React frontend, because we want the user profile data every time a user logs in. But we also save the user profile data in the auth check component as well. So to avoid saving the user profile data to the database every time a user logs in, we do on conflict do nothing. And this ensures that our user data is not saved twice to the database. And after this, we just do comma values, and then the query, the QR and QREST arrow function. And this is it. We're done setting up this route to save the user profile data to the database. And next we have a route to get the user profile data from the database. So we can just copy and paste and then change router.post to router.get, and then also update the API route name to get. And we're going to be looking up this user with their email. So we can save their email with rec.body.email, and then we stringify it. We make it a string because that's how it's saved in the database. And next, our SQL query will be select all from users where email equals $1 in comma, and then we pass in the email to the array, and another comma, and we have our usual query arrow function. And finally, we just need the route to get all the user's posts that are associated with a certain user. So when a user visits their profile page, they'll have all their posts available to them where they can edit and delete it. And we'll look up the post associated with the user ID. Because remember, in our post table, we have a user ID field that references the user ID. So each post has the user ID of the user that submitted it. And in the same way, we can stringify and save the user ID in a user ID const. Then our SQL query is just going to be select all from post where the user ID equals $1. And remember, user ID is a user ID column in the posts table because we're selecting from post. But user ID is also the unique primary key in the users table. They're both the same value. The user ID in the posts table is just being referenced as a foreign key, which is what allows us to have relations in a relational database. And then comma, and then we just pass in user ID to the array. And after that, we have our usual query error function. And this is it. This is all we need. We completely set up our skeleton Express app, and we have all the routes we need for a functioning blog. In the next section, we'll set up our front end to work with this Express server. So in the last section, we set up all our routes and queries for the CRUD operations for our server side. In this section, we'll set up all our CRUD operations for the client side blog. And this will be made up of 5 React components. First, we need the add post.js component, and this is just a form to submit the posts. Next, we have the edit post.js, and this will be a form as well, but it will have the fields already populated with the data of the post that's being edited. And edit post is going to be only accessible from the profile component, which we'll see in a second. And next we have posts.js, and this is just a component that renders all the posts, and this is just a typical form that you would see around the web. And next we have the show post.js component, and this is a component to render each individual post. So when a user clicks on a post, this is where they're redirected to. And this component will also contain all the all the comments associated with a certain post as well. And finally, we have our profile.js, and this is going to be the user dashboard, and it's going to render the user profile data, and also it will render all of the posts the user has made. And each post will have a edit and delete button, where of course the user can here edit and delete the posts. And this is going to be our full stack blog, and these are the 5 components we'll be using to set it up. So in the last section, we went over an overview of how we're going to build a blog. And in the following sections, we will actually build a blog. So let's begin by creating a new directory which will hold all of our components for our blog. And we can just call it blog, and it will be in the root source directory. And we can begin with the add post.js component. So in our blog directory, let's create a new file called addpost.js. So we can begin with our imports. So we need React and component from React, because this is going to be a class component. We also need Axios to make our requests. We need our history utility. And since it's a post, we're going to use a stylized form field, so we can get text field from Material UI. We need connect from React Redux. So let's begin. Let's create a class of add post, and we can just start it off with an empty div. And then let's start off with a form with an onSubmit event, and it takes a function of this.handleSubmit, and we'll set up this function after setting up the form. And then we need our first text field, which will be the title of the post, and this can be text field, and then it takes 3 attributes of ID, which is title, label, which is also title, and then margin of normal. And then let's create a BR to line break, and then we'll need a second text field, and this is going to be ID of body, label of body, and we also have to specify multi-line and rows of 4, since this is a text box. And finally, we need a submit button, and then after that we can close the form. And then let's also have a cancel button that will go back to the forum if a user wants to cancel adding a post. Great, so our render method is now done, and we can move on to the functions. And let's start off with handle submit. So let's start it off as an arrow function, and then remember to pass in the event keyword, and the first thing we need to do is event.preventDefault. And again, since this is React, we don't want the browser to reload when the user submits a form. So this is essentially preventing the browser from reloading when a user submits a post. And next we're going to need the user ID of the user that submitted this post. And again, this is not something they're going to submit with the form, so we need to get it from our Redux. So let's go to the bottom of our file and declare the map state to props. So let's set a property of db profile and then set it to state.authReducer.db profile. And remember, this DB profile is something we set up already in the auth reducer. So that's where the profile is coming from. And also note that this DB profile is different than the profile property we also set up in the auth reducer. The profile property contains the user profile data from auth 0, but we need the user ID, and auth 0 does not give us the user ID. So this is why we need the DB profile, so the database profile, which does have the user ID. And remember, the database is just the PSQL database we set up in the previous section. And back in our add post.js file, remember to do export default and then connect map state to props with the add post component. And remember, we set our user ID to this.props.db profile 0 because it's returned to us as an array, and then .user ID. And we also need our username, which we can access in the same exact way. So let's now combine all of our data into one object. So let's declare const data and then set it to a JavaScript object of title, body, username, and UID. And title and body are coming from our form, and then username and UID are just the variables we just set up. And remember, since it's a form, it's event.target.title.value and event.target.body.value. And now for our Axios post request, and this is what's going to send our data from our front end to our Express server, which is then going to save it in our database. So we do axios.post and then /API/post and then post to DB. And our second argument is just the data const that we just set up. We do a .then call right after this Axios request, and it is a post, so we're not getting anything from the database, but we're still going to get our status code, so we need to know if our response worked. Then we just do the .catch with the error. And finally, we want to redirect the user when they add a post. And if you didn't do this, it would look very off when a user submitted the post, because remember, we're doing event.prevent default, so when a user hits submit, nothing would happen. So to sort of mimic a regular form submit in regular non-single page application apps, we do a set timeout. And again, I mean, you can try this yourself, but if you don't have a set timeout method, the user will just submit a post and seemingly nothing will happen. So that's why we have it here. And we can set it to 700 milliseconds. And this is it. This is all we had to do to set up our add post component. In the next section, we'll set up our post.js component, which will display all the posts and function as our main forum. In the last section, we built our add post component. In this section, we'll set up our post.js component, and this will be our main forum. This will display all the posts to the users. So let's begin by creating a file called post.js in our blog directory, and we can start with our usual imports. And we'll be displaying all our posts in a table, so let's import all the different pieces of the table we need from Material UI. And then let's set up our post class as an empty div. And now we can begin setting it up. Let's first start with a header of posts, and we'll wrap everything in a paper. And this will give it a nicer overall look than if we didn't use this and just had a table. And inside the table, we'll start off with the table head, and these are just the headings we have for our table. So the first heading is obviously going to be title, which will be in a row and in a table cell. And we're not going to put a heading for the body of the post, because I think most people will understand if they see the title heading, they'll understand the body of the post as well. And after this, we can now declare our table body, and the table body is going to be what actually contains the posts. And since we're going to be getting these posts from a database, let's set up our usual map state to props function. And let's declare a property called posts, and then let's set it to state.postReducer.post. And remember, this post is coming from our post reducer that we set up in the previous sections. And this piece of state is what actually contains all of our posts. And since it's an asynchronous operation, let's do a ternary expression. So this.props.post, and then if post is present, then use the map function on the array. And then each post will be its own table row. So let's set up a separate render post function to render each post. So const render post, and then this is going to take a argument of posts, and then we start with a table row, and then inside each table row is going to be a table cell. And let's first start off with the title, so post.post.title, and we'll actually make the title a link, because in our main form, if a user clicks on the title of a post, they should be taken to that individual post. And then inside the to property of the link element, we can do path name equal to post/plus post.post.pid. And this will ensure that each post has a unique URL. And then as a second argument, we can do state, and then we can pass in the entire posts. And this will allow us to access the post information in the show post component. And next we also need the post body. So we do post.post.body, and we can wrap it in a paragraph tag. And we're done setting up this render post functional component. So let's now declare it in our render method. So just do render post, and then remember we also need the key since this is an array. So we set the key equal to post.pid, and we also need to pass in the post. So it's going to be post equals post. And for our else statement, we can just do null. Now let's set up our Axios request that will be used to actually retrieve the post from the database. And we'll need to use this in the component did mount lifecycle method, since we want this done automatically when the user renders this component. So inside the component did mount method, we do axios.get /API/get/all posts, since this is an API request to our Express server. And then we do a .then call. And inside we do a arrow function with the res, which is the response. And we need to save the response in the Redux state. So let's do that now. Let's set up our map dispatch to props function. So let's name the property set posts, and then we do an arrow function post, because this is what the response will be, an array of posts. And then we do dispatch actions.fetch db post. And after setting it up, we can now use it in our .then statement. So we do this.props.set db post, and we do, remember, res.data, because the entire response object is more than just the array of posts. It includes the headers and other properties that we don't need to use. So to access just the array of posts, we do res.data. And then after that, we do the .catch, and then a console.log our error. And this is all we need to retrieve our posts from the database. So we went a little fast setting up the component. Let's see and fix any bugs or mistakes we made. And yes, the key for a render post functional component should be posts.pid, not posts/pid. And also our fetch db post should be lowercase in the map dispatch to props method. And our argument for render post should be just post, not post. And same thing in the h4 title, it should be post.post, not posts. And we also need map dispatch to props passed into our connect function. And finally, we need a way to access the add post component that we set up in the last step. So we'll include a add post button, but we'll wrap the entire button in a link. This will make the entire button clickable. If we didn't wrap it in a link, but we wrap the link in a button, the entire button will not take the user to a new link. So we can just set it up like so, and we're done. That's it. This is all we need to do to set up our main forum. In the last section, we set up our post.js component. In this section, we'll set up our show posts component that will display each individual post along with the comments. So let's create a show post.js file, and inside let's start with our usual imports. And we also need the dialog box from Material UI as well. And this will be used for a user to edit and delete comments. So let's set up our show post class with an empty div. Then we can start with an h2 header of just post, since again this is just a single post. Then to actually display the title, we have to do this.props.location.state.post.post.title. So this is a very long property name, so let's break it down and understand how each of these property names works and comes from. So this.props is the standard way to access properties in a class component. .location is actually a given property from React Router, and we have this available to us automatically since we already have React Router set up. .state is actually a property of location, and we set that in the link component in our post.js component. So remember, when in the link component in the to property, we specified state and we set it to the entire post. So this essentially allows the state property to have the entire post available to this property, which is why we can access it in the show post component with post.post.title. And again, this is the same way we access the title in the post.js component. And we can access the body and the author of each post in the same way as well. And below this post, we want to display all the comments associated with it. So we can start off with the h2 comments tag. And this is going to be an array of comments, so we're going to display them in the same way we did the array of posts. So let's start off with the Turner expression of this.props.comments. And since we're going to be getting it from our Redux store, let's set up our map state to props function. And let's set a property of comments to state.postReducer.comments. And again, this is the exact same pattern we just saw when we set up the posts. And we can also set up our map dispatch to props function and just leave it empty for now. So in the same way we had a render post functional component, let's also create a render comments functional component. And of course it will have a argument of comment and it will be an arrow function. So let's start off with a div, and then to access the actual comment, we'll just do h3 and then inside curly brackets comment.comment.comment. So this may seem a little confusing. So the first comment is the comment argument we just declared in the render comments functional component. The second comment is each comment as a prop that we're going to set up in the functional component. So in the render method, we pass in a prop to this render comments functional component, and that prop is referring to the second prop. And the third dot comment is the actual property of each comment object. And again, comments don't have separate titles and bodies, so it's just one object. And next we need a date created property, which will wrap in a small tag. And then in the paragraph tag, we can do by and then the author of the comment. And next we're going to need a ternary expression that compares the current user ID to the comment user ID. And if true, we can pass in an edit button. And this is how we handle for a user to be able to edit their own comments. And in the onClick method, we can handle a click open function. And this is going to be a helper function we're going to set up in a second. But this will essentially open the dialog box where the editing comment can take place. So let's now set up our local component state in the constructor. So let's do constructor props and then super props. And then this.state and then equal to three properties. So open, false, and open is going to control our dialog box. The second argument is comment, which is an empty string, and then the CID, the comment ID, which is also an empty string. And next we have our first helper function, which is handle click open. And this is what we declared in the onClick event of the button in our render comments functional component. So we pass in two arguments, CID and comment, and then we set the state to first open equals true, which will open our dialog box, and then comment equals comment and CID equals CID. And this will set the comment and CID in our local state. And again, this is coming from our render comments functional component. And then we need our handle close helper function. And of course, this will close the dialog box and reset all the state. And in the same way, we just set up our render post functional component in the last section. We can do the same thing for the render comments here. So inside the Turner expression, we need to call the .map function on the comments array. And then each comment will be passed individually to the render comments functional component. So in our render comments functional component, let's first set the prop to comment, which will equal each comment. And then we need a second prop of current user ID. We'll leave it blank for now, but this will essentially hold the current user's ID. And finally, we need a key because this is an array, and it will just be comment.cid. So before we set the current user ID, we need to get it from the Redux state. So let's declare a property called dbProfile and then set it to state.authReducer.dbProfile. And remember, dbProfile is just the name of the property that we set in the authReducer. So now we can pass in the user ID to the current user ID prop. And to make it a little bit nicer, let's also format our code a little bit. And we also need a form that will handle actually submitting the comments. So let's create that here. So form and then on submit is going to equal a handle submit function, which we'll set up in a little bit. And we just need one text field for our comment. And of course, we need the submit button, and we just have our closing form tag. And next we need our dialog box. So we can start with dialog, and then we need to set the open prop to this.state.open. And this will allow us to toggle the dialog box. Then after that, we have the onClose prop, which takes in a function to close the dialog box. And this can of course just be this.handleClose. And then we have an area and then labeled by prop, which is alert dialog title, which is going to be the ID of the dialog title. We'll see in a second. And then area described by, which is the same thing. It's just the ID that's going to be associated with the dialog content. Then we have our dialog text, which of course takes the ID of alert dialog title. And then our title is going to be edit comment. And here we can close the dialog title tag. And after this, we need the dialog content, which will first take the dialog content text and remember the ID of alert dialog description. And then we need a input tag here. And this is going to be a type of text, and its value is going to be pre-populated with the comment because the user will need to edit this comment. And we can pass in the function of this.handle comment change, which we'll set up in a second, to the onChange event handler. So let's set up handle comment change, and remember to pass in event as the keyword. And in the arrow function, we'll need to use this.setState and then comment equal to event.target.value. And this will essentially allow us to keep track of the comment when the user is editing it in the dialog box. So back in our dialog box, we can close off the dialog content text and then create a new dialog actions tag. And this will contain all our buttons and actions we want to set up in the dialog box. So the first thing we'll do is create a agree button, and in the onClick method, we can do this.handleUpdate, which we will set up in a second. And we also need to close the dialog box when the user hits agree. So we can do the second argument to the arrow function. We can do this.state open false. And again, this is going to be a confirmation to updating the comment. And of course, it's going to have an Axios request. And again, we'll see this in a second. The second button we need is a cancel button. And again, this is just a simple one that just closes the dialog box. And finally, we have a delete button, and of course, it's just going to delete the comment. And again, we'll set this up in a second, but just pass in this.handle delete comment to the onClick method. And remember to wrap both the function calls in the agree button with curly brackets. Since we're calling two functions in an arrow function, we need to wrap them both in a curly brackets, otherwise it's not going to work. So let's now begin setting up our Axios request. The first thing we need to do is get all the comments from the database, and we'll do this in the component didMount lifecycle method. So inside our lifecycle method, we do axios.get and then /API/get all post comments. But in this get request, we also need parameters, since we don't want every comment for all the posts. We just want the comments associated with a certain post. And again, how we do that is by passing in a params object to the get request. And this params object will contain the post ID, which is again associated with every comment. And again, we saw this in the SQL section of how that's set up. So just refer back to that one if you're not sure. And remember, we have the entire post available to us in this show post component, and we saw that before with this.props.location. So the same way we access the title and the body of the post, we can also access the post ID. So we can do the same thing. We can just do this.props.location.state, then post.post.pid. And again, we need our .then statement call, and we pass in res response. And let's set up the actions that are going to be dispatched to work with this Axios request. So in our map dispatch to props function, let's do set comments equal to an arrow function comments, and then dispatch actions.fetch post comments. And then now we can go back to our axios.get request, and then it's going to be this.props.set comments. And remember, we pass in res.data, not just the entire response. Then followed by our error handling. And that's it. That's all we need to do to get all the comments associated with a certain post. Now let's create our handle submit function, and this will be used to save the comment to the database. So let's first set the event.prevent default keyword, because remember this is being called from a form and we don't want our browser to reload. And then we do const user ID, and this user ID is going to be coming from our DB profile. And we saw this before. And next we have the post ID, which is going to actually be coming from a React router. Remember, so this.props.location.state.post.post and then .post ID. And then we need the username, which is also coming from a Redux state from the DB profile. And finally we combine all of these into a data const. So comment would be event.target.comment.value, because remember that's the text field ID we set. And then the rest of our properties can be set just by the variable name. And next we have our Axios post request. And again, remember post just means we're sending data to the database. So we do /API/post/comment2db, and then we just pass in the data variable we just created as a second argument. Then we do .then, and then we console.log the rest. And we do our error handling, and then we also want to redirect the user to the main forum after they submit this comment. And let's set a millisecond timer of 700. And now let's go to our handle update, which will handle editing a comment. So first, of course, we need the comment that we're going to send to the database. So we do this.state.comment, and remember this comment is set in local state by the dialog box. So this ensures that if the user made any changes, they will be updated automatically to the local state, which ensures we're getting exact edited comment that the user wants to save to the database. And then we have our comment ID, and of course this is set when a user opens the dialog box. So this is set automatically in local state, and this again ensures we have the right comment ID. And then we have our usual user ID, post ID, and username. And like we've been doing, let's combine all of these into the data const. And next we need our Axios.put request. So we do API/put/comment2db. And in the same way we post comments, we also just pass in data as a second argument to the put method as well. And then we do .then res and our error handling. And then the final one, we just redirect the user back to the main forum after they submit. So finally we need our handle delete comment function. And all we need to delete the comment is the comment ID. And of course, since the dialog box opens, it sets the comment ID automatically, which is why we can just access it with this.state.id. And we need our Axios.delete statement, and we pass in the CID as a JavaScript object where the first property is data, and then the data itself is a JavaScript object, which is CID. And then we console.log the response in our error handling, and here we'll also redirect the user to the main forum. And now we're done with all our CRUD operations for this component. And let's look back and see if we made any mistakes. And this is a little bit harder than it seems, so please forgive me if I make any typos, but I will go back and fix them in real time. So yes, our first one is in the component didMount lifecycle method. For params, it's actually another object, which is itself an object. And the first property should be post ID, which equals the post ID. And yes, the next one, we do need to pass the event keyword to the handle submit function. Great, we're now done setting up the show post component. In the next section, we'll set up the user profile dashboard. So in the last section, we set up our show post component. In this section, we'll set up our user profile dashboard, which will allow us access to our edit posts component. So let's begin by setting up a little bit of styling to help us with the user dashboard. So let's first start with the flex profile drawer. And this will just be a drawer on the left side of the user profile dashboard. And we can do display flex and then flex direction row. And then we can just set the margin top to 20 px, margin left to -50, -90 px, and margin right of 25 px. And next we can set the header of the second column of the profile dashboard to text line of center, which will center the header. And then we can have another styling property for each row of the drawer. Because remember, our user profile data will have multiple properties, and we'll display each of those properties in a row. So we can also do the flex box for this as well. So display flex and flex direction row. And each row will have a margin of 10px, and we can give it a little bit of padding as well. And this is it for styling. And now we can go to profile.js. And remember, this one already has some starter code because this is a component I set up in my last course. So if you're wondering how to set up this component from scratch, just see that course. It's a completely free course, and yeah, it's just under React Redux course on my profile. So we're going to update this component, and unlike displaying all the posts in a table like we did in the post.js component, we'll display each post in a card. And we'll also need a dialog here to both edit and delete the post. Now that we're done with our imports, let's go to the render method. And in the exact same way that we set up the comments and posts in the post component, we'll set up this as in the same exact way with a ternary expression and a map statement. And this map statement is going to be called on the array of user posts that we get from Redux. So let's start off with this.props.userPost. And we actually haven't set up the actions and reducers for this, so let's set it up now. So let's start off with our action types.js file, which is located in the actions directory in the store folder. And we can create two new action types of fetch user posts and remove user posts. And now we can go to our action files and set them up as action creators. So let's set up fetch user posts, and remember to pass in posts as the payload property. And now we can set up a remove user post. And then we can set up the actual user post state property in the post reducer, since it's the most logical place to put it. And we can just copy and paste two additional case statements and set it up in the exact same way that we have comments and posts set up. So let's now save and close all our files and go back to our profile.js. Now we can declare the user post property we just created and set it in our map state to props function. Now that we have the actions and reducers set up, we need a way to get the user posts from our database. And we're going to put the Axios request inside of our component didMount method. And of course we need a parameter to look up these posts, since again we don't want all the posts. So we are going to use the user ID. And we'll get the user ID from the DB profile, which is again in the auth reducer. So we can add it now to our map state to props function. And then we have our axios.get request, and then it's /API/get user post. And if you didn't watch the express route section, it's this API route is located in the routes file in the main folder in our express server. And this is the route right here we're using to get the user post, and it's under the user profile section. So back to our profile component, and again we need to pass in params in the user ID, which we're getting from the DB profile. We then chain a .then statement to our Axios request, and we need to save the response to Redux. So let's go to our map dispatch to props function, and we'll create a property called setUserPost, and then pass in post as the parameter, and then we dispatch actions and then fetch user post. And remember, fetch user post is the name of our action creator we set up in the actions file. And it's important to understand this. It may seem like I'm over explaining things, but it's easy to get lost and you may forget where something is coming from. So for that reason, I like to explain everything in detail. And now we need to import our actions from the actions directory at the top. And let's just go back and fix a small mistake. Fetch user posts, of course, should be all lowercase, because remember, it's not an action type. And now we can go back to our Axios request, and then in the .then statement we can just use the setPost property that we just set. And remember, just pass in rest.data, which is what contains all of the user's posts. And then we just do our error handling. And let's now go in our render method and declare the render post functional component. And again, we'll create this in a second. And in this exact same way, we're going to call the map function on the array of user posts and then pass in each post as an argument to the render post. So now that that's done, let's create the actual render post functional component. And again, it's going to be a card, so let's add the card and let's give it a style of width of 500, height of 200, and then we'll give it a margin bottom and a padding bottom. Now we can start with the card header. And in the title, we'll need to make it clickable, so let's import the link component from React Router. So again, same with the post.js component, let's wrap our title with the link and give it a path of post to each individual post ID. So even in the user profile dashboard, a user will be able to click on a post and go to that individual post. And now let's start with the subheader. So pass in an empty div to the curly brackets of the subheader. And next, let's create two new styling classes to app.css. And these are going to be very basic. These are just going to be a flex display with that is either a column or a row. So a flex column or a flex row. And then be sure to import the app.css file to profile.js. So our subheader is going to be set up as a flex column, and each column will have several flex rows. So our first row will just be the date created of the post. Next, we'll have our edit and delete buttons here, and both of these edit and delete buttons will be one row. And let's wrap our edit button in a link, since again, clicking on edit will take the user to an edit post component. So editing a post should have its own component, which again we'll set up in the next section. And then for deleting, we don't have a separate delete post component, so we can just use a dialog for that. And again, to do this, we can just do this.state and then open equals true. And again, we're going to set up the dialog the exact same way as we did in the show post component. And finally, we can finish off our card with the card content. And this will be the body of the post. And remember to include style overflow hidden. And what this does, if a post is much longer than the card, the post gets hidden. The overflowing post gets hidden. So you don't have a situation where there's text that's coming outside of the card. And now we can set up our local component state. So let's go to the top of the class and create a constructor with the super method. And let's declare this.state, and we're going to need two properties, open and post ID. And again, open, like our show post component, is just to open the dialog box. And post ID is going to be used to help us know which post the user wants to delete. So let's now declare two helper functions, handle click open and handle click close. And of course, these are just to open and close the dialog box. And since we now have these helper functions, let's replace the setState method in the delete button and replace it with this helper function. And let's also finish up our handle click open, and because we do need the post ID passed in as an argument. Let's now set up our dialog box, and we can work smart, and instead of writing everything from scratch, let's just copy and paste it from the show post component. So let's now make some changes to this. So let's first start by changing edit comment to delete confirm, since this dialog is to delete posts. And next we can get rid of the input element because we don't need to enter any text here. And we can change it to deleting post. And then our first button is going to call the this.delete post function. And our second cancel button can actually be left as is. So let's now set up the delete post function. So set it up as an arrow function, and the first thing we need is the post ID, which we get from our local state. Remember that when a user clicks on the delete button, the post ID of the post that the button is on is automatically saved to the local state, which is what allows us to accurately delete the right post. After our post ID variable, we need an axios.delete statement. So the very first thing we have to do is actually delete the comments that are associated with the post before we can delete the actual post itself. And this is due to PSQL's foreign key constraint. And we'll discuss foreign key constraints in much more depth in the admin module. But for now, just know that we can't just directly delete the post. We have to first delete each comment associated with the post. Because, I mean, if you think about it, if we just delete the post, what would happen to the comments? So let's do axios.delete API/delete/post comments, and then we pass in the post ID as an object to the data property. And remember, data itself is a object which holds the value of a object. We then do a .then statement, and we do another axios delete statement here, and this is where we delete the actual post. And we do it with the same exact post ID. And we do another .then statement inside of our first .then statement to just console.log the response. Then we do our regular error handling, and we have to finally close the dialog box, and then we'll redirect the user to the home page. And make sure you've imported the history utility. So let's just look through our app and see if we made any small mistakes. So yes, so the first one, so it should be handle click close on our delete post function. And remember to import Axios as well. And let's also fix something in our click handle opener. Remember to put the curly brackets inside of the parentheses. And then we need a closing tag on the card header. And let's see if we need anything else. And yes, padding bottom should not have a L after it, and replace it with the colon. And hidden should be a string. And let's add a underscore to user ID. And the edit post link should have a slash before it and after it as well. And our cancel button should be handle click close. And we definitely need to pass map dispatch to props to the connect function. And now we can test our app. So let's click on the login button. And after login, we do see, yes, if we go on the profile, all our profile info is here. Perfect. And let's finish setting up our blog and the edit post component before we completely test everything out. And we'll do this in the next section. In this section, we will set up our remaining component to complete our front-end client-side blog, and that is the edit post component. So as we've been doing, let's go in the blog directory and create a new file called editpost.js. So let's start with our usual imports. We're going to need React and the component class, and Axios, history. We need a text field, button, and the connect from React Redux. And how we're going to set this up is going to be very similar to the add post.js component, except for we're going to have the fields already populated, and our Axios request is going to be a put request instead of a post request. So basically this is just going to be a add post component, but with a few differences. After our imports, we can set up the class with an empty div for now. And we're also going to need the database profile, so let's declare this property in our map state to props function. And finally, don't forget to connect the map state to props to the edit post component. So let's go in our render method and then declare the form. And inside the form, we're going to need our first text field, which will be the title of the post. And after that, we're going to have our body of the post text field. Next, we'll need two pieces of local state to keep track of the changes to the title and body of the post. So let's set that up now. And we're going to set this up in a constructor. And this.state equals JavaScript object and then title of an empty string and then body, and also set it to an empty string. And we'll want to auto populate these title and body local pieces of state. So let's do this in our component didMount method. So let's do component didMount and then this.setState and then title equals this.props.location.state.post.post.title. And again, we've seen this one a couple of times before, and if you didn't see those sections, they're basically coming from our profile.js component, which is the user dashboard, and the edit button. If you see, we pass in the entire post to the link object, which is what allows us to access it here. And we will do the same exact thing for the body of the post as well. And to make sure the text fields are pre-populated, we set the value prop to the local pieces of state. So in our form, in our text field, we go value equals and then this.state.title. And we do the same thing for body as well. And since this is a form and we want to make it a controlled component, we also set the onChange event handler as well. So let's declare the onChange event handler for both of our text fields. And then we can declare the two functions that are going to work with the onChange event handler. So we do handle title change and then remember to pass in the event keyword. And then we do this.setState and we just do the title equals event.target.value. And this will keep track of the changes the user makes to the title and body. And in the next function, we do handle body change and we do the same thing. And now we can pass in the reference to these functions to the onChange event handler. And remember, we're passing in the reference to the function, so don't use an arrow function or call the function here. Simply just pass a reference to it. And of course, we'll also need a handle submit function for this form as well. So let's pass a reference to it first to the onSubmit event. And we'll also need a button of type submit at the bottom. And we'll also need a cancel button, and we can just do history.goback, which goes back to the previous page. So let's now begin setting up the handle submit function. So again, we need the event keyword passed in as a parameter. The very first thing we do is event.prevent default, since we do not want the browser to reload when the user submits this form. Next, we have the user ID and username. And again, we're getting this from the DB profile, the database profile that we got from the PostgreSQL database. And next we have the post ID, which again is available in this entire component because we passed it in to the link element from the profile.js file, and then we access our title and body from the form, and then we save everything in a data variable. And you can just make the name of the property equal to the name of the variable. And then we have our Axios HTTP request, and this is going to be a put request because we're making an edit to the database. We're not posting new information. So if you're unfamiliar, HTTP put request means an edit to the database. So we can make the path the API/put/post, and then the second argument is going to be the data variable. We do a .then statement, and we'll just console.log the response because we're not getting any data from the database. The database is just going to send us a status code. And then we do our error handling, and then let's do set timeout and then history replace to the profile component. Because remember, the user is accessing edit post from their profile, their user profile dashboard, and we'll do 700 milliseconds. And don't forget the period in front of the then, like I just forgot right here. So we created that component pretty quickly. Let's just go over and see if we made any small typos and fix them. And yes, we're missing the state keyword in the body of the setState method. And we need the .value property in the title and body variables in the handleSubmit method. And we're missing an equal sign to the onClick event. And in our import statements, material UI should be RIAL. And component didMount is missing an N. And that's it. We're done setting up the edit post component and our Fullstack client-side blog. And we just need to do one more thing before we can finally begin testing our app. We need to set up the routes and header, which we'll do in the next section. So this is going to be a very quick section where I just go over how to set up the routes for our client-side blog and also set up the links in the header. So let's first start in our routes.js file and import all the components. So let's do import posts from ./blog/post since we're in the same directory, and try to chunk all the components that are similar the way I have set up here. So I have all the containers set up in one section and then all the functional components set up here. And the same thing we can do with our client-side blog, just have all the blogs in one section in the import statements. It makes your code much cleaner and easier to read. And now we can set up the routes. So let's set up our main forum with a path of /posts, and then we can just pass in the post component. Our show post will need to be dynamically routed. So we do /post/:PID, and then the component would be just show post. And same thing with our edit post. It needs to be dynamically routed. So we do edit post /:PID. And again, the PIDs can be the same because again, it doesn't matter what we use as a placeholder for what we want to route to. So /edit post will be /edit post /a number, and this will not conflict with our show post, will be /post /any number. So this is why we can do :PID for both edit post and show post. And finally, let's just do add post, which will be just /add post. So let's now add a link to the main forum in our header, and we'll only need the link to the main forum because everything else has its own routing in its own specific component. For example, our add post will be accessible through the main forum, which is why we don't need to add a link in the header. Our edit post component is accessible through the profile component, and our show post component is available by clicking on the title of a post. So therefore, we only need to add the link in the header for the main forum. And let's just go in our main forum and change the path from new post to add post, since add post sounds a little bit better and it's a more accurate description. And this is it. This is all we need to do to set up the routes and links in the header for our client-side blog. So we are done. We can now finally begin testing out our skeleton full stack blog. So first thing we need to do is go to our app and log in. So I've already created a user to save time, and it's test344@yahoo.com. And we do get redirected to the callback page after logging in, and you can see that we were very temporarily on the auth check component as well. So far so good, everything is working as expected. Let's go in our PSQL shell and then select all from the users table so we can see for sure if our user was in fact saved to the database. And yes, if we see at the very bottom, we have test344@yahoo.com. So great, it is working. Our user is now in our database. And again, this was all done automatically. This is information we got from auth0. We did not have to do anything manually. Next, let's go in our main forum. And we can ignore these warnings for now. We'll make our forum have cards instead of a table in the next section, so we don't need to worry about this error for now. So let's go ahead and add a post, and we can just type in some random text here and just hit submit. And perfect, there it is. The text we just submitted is at the top, which is what we set up to do in our SQL query, and it's here immediately after submitting it. Perfect. And we don't really even have to bother checking our database, because the fact that it is here means that our database is working, because, well, there's no other source where this information could have come from. So let's now click on our post and add a comment to it. And perfect, let's hit submit, and we're redirected to the forum. And if we click on the post and see, yes, it is still there. Perfect. And let's now edit our post, and awesome, our dialog box should open like this. And if we go to our forum and go back to this comment, yes, it did update. Perfect. And if we hit the delete and go back to our forum and check, yes, it did work. And it just takes a little bit of time for the virtual DOM to update. So yes, our delete statement is working. Perfect. Now let's go to our profile component and check the editing and deleting of posts. And yes, perfect. Clicking on the edit button should take us to that edit post component. And here, let's just change some text and hit submit. And perfect, we are redirected to our user profile page. And yes, the test post did change its text, and we are seeing it here. Perfect. And finally, we can just delete this post, and we're redirected to the home component. And if we look down, we do see all our status codes from our database, and our last one is from profile.js. So yes, our delete post did work. So we're far from completely done. We still have a lot of things we can do with this basic skeleton app, and we will be building upon it through the entire course. And the very first thing we'll do is add more styling, specifically animations and transitions in our main forum. And this is what we'll do in the next module. So in the last section, we finished setting up our Fullstack blog. But we do have one problem. When we go to our forum, it doesn't really look that nice. And also, we're getting a bunch of warnings in our console saying a table cannot appear as a child of another table. And we're just going to solve this warning by getting rid of the table altogether. We will just display all of our posts in cards instead. And we will also animate them so they'll have a nicer looking transition when the posts render. So let's go back to our app and get rid of the imports for the table. And instead, let's import the cards from Material UI. And the card is going to have three main parts: the actual card itself, the card content, and the card header. And we can also get rid of all the table elements in our render method and in the render post method. And let's also move our render post arrow function inside of our class this time. And we can get rid of all the table elements here in our render method. And now, because our arrow function is inside of our class, we also have to add the this keyword to the render post element. Now we can just start off our render post function with an empty div. And if you remember from the last section, we already have the post set up in a card in our profile.js component. So to save time, we can just copy and paste it from there. And really, we don't have to make any changes to this. On the contrary, we should keep it the same so that there is a certain level of symmetry between our profile dashboard and our forum. We can now begin to apply a basic transition animation to our post. So let's begin by wrapping everything in divs. And then to our divs, let's apply a style property. And then we need two properties of the style to animate our posts. We need opacity and transition. Opacity is really how faded an element looks. And how a animation transition is going to work is that the posts are going to start at 0, so they're going to be completely invisible, and then they're going to become less faded over the 2 seconds, which is what we specify in transition. So in transition, we write opacity 2s, 2 seconds ease. So essentially it's saying ease into the opacity over 2 seconds. And again, ease is what's known as a transition timing function. So ease basically says that it's going to start slow, then it's going to speed up a little bit and then end slowly. And ease is just one of many other transition timing functions. There's linear ease in, ease out, and I'll link to a resource that lists all of the timing functions, but for now we can just use ease. And then let's now create a piece of local state to handle this opacity function, this opacity property that we just defined. So let's first start in the constructor and then do this.state equals and then posts. So we're going to animate by first saving all the posts we get from our server to the local state. And this will just make animations a little more reliable and predictable. Since they are in local state, the animation is just going to be a little bit smoother, since it's not going to be we're not just going to animate them directly right when we retrieve them from our server. And then we set opacity to 0, and this means all the posts are going to be completely invisible. Then we're going to use a helper function to change this opacity piece of local state to 1. And let's just do this.handle transition, and then we use a set timeout because we want it a little bit delayed. And then we simply just do set state and then opacity to 1. And let's just do a 400 millisecond timer. And then let's just create another helper function to save the posts we get from our backend to our local state. So we can just do add post to state, and then we pass in a parameter of post, and then we just set the state to post, and then we use destructuring to flatten the array of posts. So that's the ... is a spread operator that just flattens our array, so we don't have an array within an array. And then we now need to call these functions, and we're going to do them in our component didmount lifecycle method. So we do this.handle transition first. Since it does have a 400 millisecond timer, we can put it ahead of the Axios request. Then we use our add post to state after the first .then statement. So we just do an arrow function, and then we do this.add post to state, and then we do this.props.post. Because remember, this is after our API request and after our dispatching of actions of the set post action. So since this is after we dispatch the set post action, our posts are already saved to the Redux store. So we can simply just access them with this.props.posts. And let's just fix a small typo here. Let's just get rid of that this keyword before handle transition. And this should be it. This is all we need to do to animate our posts that we're getting from our database. And if we go to our form, we see, yes, our posts are animating as we expected. Perfect. They're starting from invisible and then fading in slowly. Awesome. In the last section, we successfully animated our posts in our forum. In this section, we'll add pagination. And pagination just means we'll organize the posts in our forum to have pages. And this is really because we don't want one gigantic single page that has hundreds of posts. And we'll use a helper library for this called React.js pagination. And so you don't have to look at a loading screen. I already installed this library. And to install it, you just do npm install and then React.js pagination. And it's exactly how it's spelled right here with the dashes. So let's go to our render method and then declare this pagination object we just imported. And we'll need 5 attributes to make pagination work. We need active page, which is going to be just the page the user is on. And our active page is going to be handled by React in the local component state. So as a value, we pass in this.state.activePage. Remember, .activePage is going to be a property of local state. Then we have items count per page, which is 5. So we'll just have 5 posts per page. And then total items count. So this is going to be the total number of posts. And we'll leave this blank for now. And page range displayed. So it's going to be how many pages we have total. And we'll also leave this one blank for now. And finally, we have onChange, which is the function that's called when a user changes the page. And we will, of course, set this up later on in this section. So let's declare the local state properties we're going to use to make pagination happen. So the first one we're going to need is numPosts, and this is going to be the number of posts. And then we have page range, which is we're just going to initialize it to 0, but of course we will calculate this out. And then active page, we'll just set it to 1. We want 5 posts per page, and then we also have the post slice. So the post slice is going to be an array that contains the posts that should be displayed on a certain page. And the first thing we'll do is set the number of posts. And we can do this in the add post to state function. Since we are getting all the posts here, this is the ideal place to set the length and the number of posts. So we go on the next line and then we do set state and then num post, and then we set it to this.state.post.length. And remember, our previous post call set the post to local state, which is why we can call the length function on it here. And then the second property, page range, we do this.state.numPost/5, because remember, we need 5 posts per page. So we just do the total number of posts /5, which is how many pages we need. And next we have our slice post function. So I'll just set it up first and then I'll explain it afterwards. So we have const index of last post, and this is going to be this.state.activePage times this.state.post per page. And then next we have const index of first post, which is just index of last post minus this.state.post per page. And then we do this.setState and then post slice, which is going to be an array. It's actually going to be a slice of our main post array. And the index will be, of course, index of first post and index of last post. And if you're not sure, slice just means we're taking a portion of the array. And slice is just a given JavaScript function. It essentially takes a portion of an array and gives you a new array from that portion. And it takes 2 parameters. It takes the index where you want to start the new portion of the array, and the last one where you want to end that new portion of the array. So I think this kind of gives you a glimpse into how we're doing pagination. We have our entire post array, and then we slice a certain portion that will be displayed with a certain page. So basically what we're doing is we're first setting the active page number, then we call slice post to use the active page number and the post per page to index, and then slice all of our posts. So since there's 5 posts per page, the last index on the page will be 4 if we start counting at 0. And the 5th index is actually the 6th post, but we don't have to subtract 1 from our index of last post variable to get the index of the last post, since slice does this for us automatically. It excludes the last index. So basically, here's an example. So the index of the last post on page 4 will be 20. So 20 will be the index, but it's going to be the 21st post, since again, we start counting at 0. But again, we don't have to compensate for the fact that we started counting at 0, because the slice method automatically excludes the last index. So we're correctly showing 5 posts per page in the correct order. And then for index of first post, index of last post for page 4 will be 20. So 20 minus posts per page, which is 5, which is index of 15. So the index of 15 is actually, remember, the 16th post, since we started counting at 0. And since we're on page 4, we should be seeing the 16th post at the top. So this is essentially how we do pagination and how it works with indexing. So we're just taking a small slice of the entire post array and then just showing that to the user based on the active page number. And again, whenever a user changes the page, this post slice array is updated automatically. And even if a user jumps many pages at once, this function will still work. For example, if they jump from page 1 to page 3, this function will still be valid and they will be seeing the correct posts. And even if they do something like jump from the very first page to the very last page, they'll still be seeing the correct post. And then after that, we have our animate post function, and this will animate each post individually. So in our last section, we animated all the posts at once. And in this function, we'll do each animation separately. So let's first start with the this.setState and then post motion, which we'll set as an empty array. And again, this is because every time a user changes a page, we want to empty out our post motion array. And how it's basically going to work is the post slice array we just set up, we're going to call a map function on it, and then we're going to take each post in the post slice array and then add it to this post motion array. Then as a post is added to the post motion array, it is animated. So whenever a post is essentially set in the post motion array, it becomes animated. So after our set state function, let's do let I equals 1, and this will keep track of the counter. And then we do this.state.postMotion.postSlice.map, and then post arrow function, and then we do a set timeout because we want each of them to be animated separately. And then we do an arrow function, this.setState post motion, and then we do a spread operator and comma post. And the order is important. We don't do post first and then run the spread operator. And again, the spread operator ensures we have a flat array. We don't want two-dimensional arrays within an array. And then we can just pass in 400 milliseconds as the second argument. And then after this, we need to iterate our counter. So we do I++. And then after this, we need our handle page change function. And this takes page number as a parameter. And page number is a reserved word. This is essentially how we communicate with our pagination element to make sure we're getting the right page number. And then we just set the state of active page to the page number. And whenever a page changes, we want to also call the this.slicePost and animatePost functions. And we have to put them in a timeout because even though it's a very small time, it does take some time to add the post to local state and make the required calculations. So I found 50 milliseconds and 100 milliseconds to be the minimum time needed. So let's now go back to our render method and then finish off the pagination attributes. So for total item counts, it's going to be this.state.numPost, and page range display is going to be this.state.pageRange. And on change, we can just pass in a reference to the handle page change function. And remember, we're not calling this function here, we're just passing a reference to them. So we don't need the parentheses or an arrow function. So let's just now put some finishing touches on our app. So the first thing, in the add post to state function, we need to call this.slicePost and this.animatePost. This is going to be the very first time a user visits the page. So we'll need to do this for page 1 basically. And these functions are going to be called whenever a user then subsequently changes the page. Then in our animatePost function, we want to multiply 400 milliseconds times I. And again, this is what will give us sort of a animation that the posts are transitioning in one at a time instead of all at once. And again, this is because, remember, we're running the map on the post slice. So each post has its own set timeout function, which means that the first post is delayed by 400 milliseconds. And since I is 1 on the first post, and then at the end of the first post, we do I++, which iterates I. So on the second post, I is now 2. So 400 times 2 is 800 milliseconds. So that's essentially how we're doing it. It's the first post is 400 milliseconds. The second is 8. The third will be 12. And the fourth, 16 and 100 and so on. And again, this will give us a transition of the posts coming in one by one. And then in our render method, we now want postMotion.map. We don't want just the regular posts. And in our animatePost function, let's just also add a curly brackets in our map function call. And this is because I++ is considered a separate function. So since we have two function calls, the set timeout and I++, we have to wrap them both with curly brackets. And this is it. We can now test our app. So let's go to our forum, and yes, perfect. Our posts are coming in one at a time as we wanted. And if we go to the second page, yes, it is working as well. Perfect. So this is good, but not good enough. Our posts are coming in, but they're not transitioning in, meaning they're not fading in as we saw in the previous section. They're just appearing, and this doesn't look as nice. So what we're going to do, we're going to make each post transition in the next section. In the last section, we set up animations on our posts, but they're not animating one by one. They're simply appearing, and we want them to transition in with a fade-in style animation. So let's go back to our code and see if we can implement this. So the very first thing we can do to try and solve this is we can just add a style property to the div and then pass in opacity and transition like we did before with the other elements. So let's try that. Let's just copy the code in our render method and then paste it to the root div in our render posts function. So let's now save and go back to our browser. So if we go to our form, it does seem like it is kind of working. And let's try going to another page. And no, if we go to another page, it doesn't work anymore. Because remember, we set the opacity in local state. So our opacity is 1 now. So it doesn't go back to 0 automatically. You can try setting it back to 0 in the handle page change function, but I can save you some time and tell you it doesn't work at all. How we'll instead do this is through the keyframes that's part of CSS. And keyframes essentially allow us to have custom animation functions. And again, we'll see this in a second. So the first thing we can do is get rid of the style property to our root div in render post. And then let's go in our app.css file and begin setting up this keyframe. And the first thing we'll do is create a class of card styles, and we'll initialize it with an opacity of 1. And next we have our keyframe. So keyframes are created with @keyframes and then the name of the function we want. And again, this is user defined and we could make this anything. So let's just call it fade in. Then we need our curly brackets, and inside we have a from and to. So essentially the first animation is going to be the beginning animation and the beginning state of the element we want to style. And the second one is going to be the final result that the animation will take. So again, and 0 means 0% when the element is at the beginning, the very beginning of the render. And 100% is going to be the final stage that the element will be in. And so we want our element to be 0 opacity when it first starts, and then 100% it will be completely filled. It will be in opacity of 1. And again, this is going to be a fade in transition. So now in our card styles class, we actually use this keyframe that we just created. Because remember, a keyframe is just a custom function. So to actually use this custom function in our card styles, we do animation name and then fade in. Then we do the animation timing function, which will just do ease in. And then the animation duration will just set to 2 seconds. And that's it. We can now pass this class into our div in the render post functional component. So we can just go back to our file and then class name equals card styles. And we don't have to pass in the keyframes here. Remember, we just pass in the keyframe to our card styles in app.css. So let's go back to our app and test. And if we click on the form, we do see, yes, it is working as expected. This is a much nicer, cleaner animation. And you can clearly see that each post is animating by itself. There's a very clear sequential animation happening here. And let's click on the next page. And yes, the same thing. Our posts are animating in the same exact way as they did before. So this is perfect. This is exactly what we wanted. Awesome. So in the last section, we animated our posts. In this section, we'll animate our comments. So currently, if we click on a post, we can see the associated comments, and we can also type in a comment and then hit submit. We're then redirected to the main forum, and if we click on that post again, we see that our comment is there. So the full stack submitting of our comment is working, but let's make it so the comment appears automatically here. And we'll do a similar fade in transition. So let's go back to our code and then go to the show post component, because it is here where we render our comments. So let's first start by setting an opacity property to 0. And we're going to be animating our comments in a similar way to animating our post, because there's no reason to reinvent the wheel here. But there are going to be some differences, however. So let's start with the handle transition function, which will again change the opacity to 1 after a set timeout. And this is the exact same thing we saw when animating our posts. So set timeout, and then inside we have an arrow function that calls the set state function, and it just changes our opacity to 1. Then after that, we can have a add comments to state function, which again, this is very similar to adding post to state, which we saw in the last section. And if you didn't see the last section, the spread operator, which is a ... just means we flatten the array. So we don't have an array within an array. Then in our axios.get request, after our first .then statement, we can declare another .then statement. And then we can do this.add comments to state, which is the function we just set up. Then we pass in this.props.comments as an argument. And remember, this.props.comment is coming from our map state to props function, which is getting our comments from the Redux state. Then we have our two pieces of local state, comments are, which is the array of comments, and then comments motion, which will animate each comment. And now we can set up our animate comments function, which is going to be in the exact same way that we set up the animate post function. So just declare arrow function with curly brackets and then let I equals 1, and then this.state.comments are .map, and then comment, then the curly brackets, and then we do a set timeout, and we set the state, and we set post motion to the spread operator, which flattens the array, and then comma, and then comment. And now we can call our handle transition function from within our component did mount lifecycle method after the .catch call. And we can also call our animate comments function right after our set state call in the add comments to state function. Then we can go in our render method, and similar to animating posts, we have to call the map function on comments motion instead of the regular comments array. And we can also define a style prop to the div and then set opacity to this.state.opacity, and then we can have the same transition as posts as well. So now we can test and see what our app looks like. So let's go in our forum and then click on a post. So we do see that our comments are animating. So this is somewhat working, but we do have a few problems. For example, when we submit a comment, we are actually redirected to the forum, and our comment does not, or newly submitted comment does not automatically animate. And when we delete a comment, we're similarly redirected to the forum. So let's take care of these few problems. Let's also animate each new submitted comment as well. So back in our code, we can declare 3 new functions to help us with this. We can do handle comment submit, handle comment update, and handle comment delete. And each of these functions will be counterparts of their full stack functions. So the handle comment submit function will be the counterpart to the handle submit function. Because remember, the handle submit function makes a HTTP request with Axios. And this handle comment submit function is going to handle submitting a comment on our front end only. And this is the same with handle update and handle delete as well. And to keep our function naming scheme consistent, let's go to the handle delete comment and then just delete the comment word at the end. And this will make it recognizable as the Axios request. And this means we'll also have to change it in the dialog box as well. So let's get started with our handle comment submit function. So first we have to pass in submitted comment as the argument to this function. And remember, this is going to be separate from our Axios handle submit function that we have, which saves our comment to the database. And we want this to be very speedy and instantaneous. So we're not going to retrieve that same comment from the database right after a user submits it. So what we do is we both submit it for saving in our database, and we also have another function that just saves it to the UI. So it can be instantly animated and show up to the user screen. So first, inside of our function, we do a set timeout, and then we do set state comments motion, and then the submitted comment is going to be added to the comments motion array. And the submitted comment has to be first before you do the spread operator with this.state.comments motion. This will put the comment at the very top, which makes sense because it was just submitted, and that's what you want to happen. And this is seen in many other forums and comment systems as well, such as YouTube. When you submit a comment on YouTube, it's submitted to the top. So having submitted comment first before the spread operator ensures this will happen. And again, we're adding it to our comments motion because this is what gets animated. And if you remember from our render method, the comments motion array is what we're using in our render method, and we're calling .map on it and rendering each comment in the comments motion array. So adding the submitted comment to our comments motion array automatically animates it and adds it to the user interface. And now the question is, well, where's the submitted comment coming from? And it's coming from our handle submit function, which again makes the Axios request to save the comment to our database. So we're going to both save the comment to the database, and we're going to use that same comment here in the handle submit comment function. And how we do that is first we go to our handle submit function, and let's refactor and restructure our code a little bit to make it look nicer. And let's also make a const of comment, which will save event.target.comment.value. Then we can just set comment to comment in our data const. And again, this will make our code much better looking. And now here in the handle submit function, we can create our submitted comment const. And this is going to be the same submitted comment that we pass into the handle submit comment function, handle comment submit function. And we'll first start off with a CID or comment ID, and we'll set it to actually a random number. So again, in a real app, you'd probably want to use math.random and then randomize the temp ID. But the purpose behind this is, well, this is just to render the comment to the UI. We don't care what the CID, this comment ID is. We only care about it when it's being submitted to our database and being retrieved from our database. But this is just temporary. We're just saving it to the UI, so we need a temporary ID. And so we can just supply it with a random number. And again, for brevity, I'll just write a random number here instead of doing math.random. And then for comment, we'll just have the comment user ID and username will both be the same. And then for date created, we'll actually just do just now as a string. Because remember, our date created is actually created by PSQL. And since we're just submitting the comment here, we can just use a string, which would actually be a more accurate description as well. Then we want to call our handle comment submit function at the very bottom, and we'll pass in this submitted comment const we just created. And we don't want to redirect the user back to the form when they submit a comment. So let's get rid of the history.replace call, and we'll replace it with window.scroll, and we'll do top 0, left 0, and then behavior smooth. So this will basically scroll the user's view back up to the very top, and behavior smooth will make sure it's done basically smoothly instead of just instantaneous, which doesn't look as nice. And that's really it for the handle comment submit function. Let's now work on handle comment update. So we'll first pass in a comment as an argument. Then we have to think a little bit about how we're going to do this. So the comment we want to animate is already in the comments motion array. So the very first thing we have to do is find the index of where it's at. So we can do this and save it in a const called comment index, and it will be equal to this.comments motion.find index, and then comment, and then inside of the find index function we do com arrow function, and then com.cid equals comment.cid. So we're trying to match the CID of the comment ID. And again, this will give us our index, which we can then use to edit the array. And next we need to create a new array, and we'll call it let new r, and then equal to the spread operator this.state.comments motion. And then we use the comment index that we saved in the first line, and we use that index and set it to the new comment. So now we have a updated array with the new comment, and the other comments are all the same in this new array. Then we can simply just make our comments motion array this new array with the new updated comment. And then let's just go in our handle submit and then set the state to comment to an empty string, and this resets the string whenever a user submits a comment, and this will ensure that our updated comment will work properly. And let's go in our handle update function and then restructure the code a little bit to make it look nicer. And then we can create a new const of edited comment, and then we do CID equals CID, comment equals comment, post ID, user ID, and author are all the same. And similar to the submitted comment, we can do date created of just now. And then we also add a new property called isEdited, and we'll set it to true. So this is going to be similar to YouTube system, where it shows you if a comment was edited or not. And then at the bottom, we just pass in the edited comment to the handle comment change function. And now we can go over the handle comment delete function, and we'll need the comment ID to delete the comment. And also in the code block, we'll do this.setState and then save the delete comment ID to the local state. And let's create that property now. And then back in our handle comment delete function, we can just set delete comment ID to CID. And then on the next line, we're going to create a new array. Then we're going to filter that array for everything that does not match the comment ID we want to delete. So we'll essentially create a new array that does not include the deleted comment. And again, we'll do this with the dot filter on our comments motion array. And then we can do a set timeout and then set our comments motion array to this new array. And then let's now go to our handle delete function and then get rid of the history.replace call. And then here we can just call our this.handle delete comment function and then pass in the comment ID. And just quickly here in our handle submit function, make sure to wrap the parentheses of window.scroll to in curly brackets. And also, instead of the string of just underscore now, we can just make it just now. And here in our handle comment submit function, we are missing a parentheses. So we can just add a parentheses after the 50 milliseconds. And to help us with our animations, we'll also be making use of keyframes like we did with the post animation. So let's go to app.css. And here we can create a comment styles class. And then first we'll set our opacity to 1. And we'll actually just use the same fade in animation that we did for posts. We don't have to create another animation. And we'll keep the timing function and duration the same as well. And let's create another keyframe that we'll use to fade out a comment after it's been deleted. So let's copy and paste the code from the fade in keyframe and then just change the name to fade out. And since this is a fade out animation, we'll actually start at 0% with 1 opacity, and then 100% will actually go to 0. And the width and the height will also go to 0 as well, so it will really look like the comment is fading out completely. And now we have to actually use this keyframe in a class. So we'll just do a .fadeOut comment class and then pass in our fade out animation here. Now let's go back to our show post component and then use these styles we just created. So essentially how we're going to do this is we're going to use a ternary expression. And what we're going to do in our render comments functional component is compare the delete comment ID to the specific comment ID of each comment. If the delete ID comment matches the comment, we're going to apply a fade out comment styles. If not, we just apply the regular comment styles. And again, this will make sure that if a comment is deleted, the correct styling is applied. And now let's work on the date created. We can also do a ternary expression here as well. So if true, if the comment is edited, we can just display the text of edited, or we can just display just now. And if the comment is not edited, we can just display the date created. All right, and let's just look through our app. And in the handle comment update, remember to add this.state.comments motion. And we were missing the state keyword there. And in our app.css file, let's add linear to the animation timing function. And in our render comments functional component, let's add just now to the ternary expression condition of comment.date created. And this is just saying if the date created equals just now, then we can also check if it was edited as well. And if it was just now and it was edited, then we would display edited. If it was just now and it was not edited, we would just display just now. So it's a ternary expression nested inside of a ternary expression. And now we can save and test our app. So let's first log in. And so far so good. And our comments do seem to be animating, but let's check a submit. And yes, perfect. Our newly submitted comment is being animated as expected at the top. And we are seeing just now as well. And let's try to edit. And yes, perfect. If we edit, we are seeing the new text and it's displaying is edited. And finally, let's delete. And yes, if we delete, it is being faded out and animated out. And perfect, we have all the animations we need for our comments. Awesome. So a modern feature of many blogs is to have a functionality where users can like posts. So this is what we're going to do here. And it's going to consist of implementing a way to count the number of likes and store them in the database, preventing a user from liking a post multiple times, and preventing an unauthenticated user from liking posts. So this is what we'll implement here in this section. So let's first start with the SQL and create 2 new fields. One called like user ID and one likes. Like user ID is actually going to be an array that contains all of the user IDs of people who like the post. And likes is just going to be one number that's going to be the number of likes for the post. And like user ID might seem a little intimidating, but really all we're doing is int array. So in array of integers, default, this is the default value, and the default is going to be an array of integers. And the double colon is what's called typecasting. So we're saying default or empty array of type integer of arrays. So to put it another way, we're just creating a field of an array of integers, that's like user ID, and then we're setting the default value of it to an empty array, which we're using typecasting, which means we're setting the type to an empty array of integers. So it's not that complicated. And then likes is really just a number, and the number of likes for each post. And now we can move on to our routes and our SQL queries. So we're only going to need one express route for handling likes, and it's going to be a put request. And this is because our likes are already initialized with a value. For likes it's 0 and like user ID is an empty array. And we're not going to use post since, again, it's already initialized, so we just have to update it. And this is why we only need the put request. So let's start writing the code. So it's going to be router.put, then API put in likes. And first we're going to need the user ID. So we can save it in a const called uid. And then we need the post ID, which is going to be a string, and then rec.body.postid. And then we can just combine these two variables in a const called values. And then let's now do our SQL queries. So we're going to do update post, because again, it's a put request. And then we're going to set like user ID equals like user ID line $1. And this double line means we're concatenating the array, because remember, like user ID is an array. So we have to concatenate the array to add the user ID to the array, and then comma likes equals likes plus 1, and we're just doing a simple iteration of likes. And then we need our where condition, and again, we don't want a user to be able to like a post multiple times, so we do where not like user ID at greater than $1, and at $1 means contains. So we're doing where not like user ID contains our $1, which is our UID variable. And since we're using the not clause, we're saying where the like user ID does not contain our user ID. So this ensures a unique value for our array of user IDs. And we also need another condition where PID equals $2, since again, a user may like multiple posts, so we don't want to exclude them from liking other posts if they already liked one post. And then we just do comma values and then our QR and QREST function. And this is it. This is all we have to do on the server side to like posts. Let's now go on our client side and begin setting up the like user posts in our blog. First thing we'll have to do is get material icons, and this is what we'll use as a thumbs up symbol. Since again, this is a very recognizable icon and not having it will not make any sense. So how we do it, we first import it from Google Fonts. This is the URL, but I'll leave it in the resources at the end of the section. Again, it's a long URL. It's better to just copy and paste it. And again, it's going to be in the resources at the end of the section. So let's now go in our post.js file and then display the number of likes for each post. And let's go to our render posts function and then display them here. So let's just first start off with a flex row, because we want the net likes to be in their own row. And we will do it right under the date created. So div class name flex row and then I, which is the icon. And you can use this here if you're not familiar with material icons. And we have to pass in the class name of material icons and then thumb up and then closing tag I. And again, this may seem a little bit strange if you've never used material icons, but this is the correct syntax to display any material icon you want. And there's hundreds of them, so if you're curious, I'll link to different material icons in the resources section. And next we have another div, and we'll give it a class name of notification numPost. And this will basically style the thumb and the likes. And this will give it an overall nicer appearance. And then for our actual likes, we do post.post.likes. And again, this is very similar to how we display all the other properties of our post. So let's now go to our app.css file and then add a little bit of styling to this notification numPost. So we'll just do padding left 5px. And we'll leave it simple for now. We'll do a much more complex styling setup on our actual show post component where the user will actually be able to like the post. In the forum on the main page, the user can see the likes, but they can't actually like the post. Liking the post will handle in the show post component where each individual post is displayed. So let's do this now. And let's also close our post.js file because we are done with it for now. So the very first thing we need is 3 properties of local state, and we need likes, which is going to be this.props.location.state.post.post.likes. And again, this is very similar to what we've seen before of how we got the post ID in post title. And if you didn't see those sections, this is just the given default functionality we're getting from React Router. So this.props.location.state is a given property of React Router, and we use this property in our post.js component, and from there we're able to pass in all the data and information for each post, and we can access them here like so. So again, remember, likes is just a property of each post, so we can just access it with location.state. And then we'll set it to our own property of likes in our local component. And then next we need the like user IDs. And again, we'll access this property the same exact way we did with likes. And then we need a like post, and we'll set it to true. So this is basically saying, is the user able to like the post? And if they already liked it, this will go back to false. But if they haven't, it will just stay true. So this is how we handle a user not being able to like a post multiple times on the front end. And on the back end, this is handled with SQL. And now we'll go to our render method and then implement the like functionality. So we'll implement likes by wrapping it in a anchor tag. And then the first thing we'll do is give style, cursor, and then pointer. So this will make the cursor change to a pointer, which will let the user know that this item is clickable. Without this, you will not have this. So it will be difficult for the user to know if they can click this like icon or not. Then we'll have the onClick method, and then we have to first make sure if the user is authenticated. And if yes, we will run the this.handleLikes, which we'll set up in a second. And if not, we'll replace the user to the home page. And next we'll have our material icon. And again, this is the same thing we saw in the post.js component. And then to actually display the likes, we'll do it in a small element, and we'll give it the class name of notification numPost, which we'll set up in a second. And finally, we can just close off the anchor tag. And let's now begin setting up our handle likes function. So we'll need the user ID and post ID. And we saw this when we were setting up our Express server. And we'll get the user ID from our Redux state with the this.db profile, element 0, and then .uid. And then we'll also need the post ID, which we can get from location.state. And let's just combine these two variables in a data const. And we'll set UID to user ID and post ID to post ID. And remember, our Express server, we set up a route as a put request. So we'll do this here with Axios as well. So it'll be axios.put/API/put/likes. And then data as the argument. We do a .then statement, and then we'll need to set up a ternary expression inside of this .then statement. We'll do exclamation point, which means not this.state.like user ID includes user ID. And .includes is a given JavaScript function, and we can use it on arrays. So remember, like user ID is a array, and it contains all the array of user IDs that's liked the specific post. And if the array of user IDs contains the user ID of the current user, then we don't want to let them like this post again. But that's not enough. We also need another and condition, and we'll do this.state.like post. And again, like post is a local property we set up that's saying, is the user able to like this post? Because if it's the first time they're liking this post, then obviously it's not going to be available from our database, and their user ID is not going to be contained in like user ID. So we need both of these conditions to make the likes work properly. And then if true, we do this.setState and then likes equal to this.state.likes +1. So when a user likes a post, it will show up instantly on their user interface. And if not, we just do null. And finally, after this .then statement, we need another one, and this will make sure our user cannot like the post again. So we'll just do like post and set it to false. And finally, we just console.log if we have any errors. Alright, we're done setting up our handle likes. So let's look through this app and see if there's any small mistakes. And yes, in our handle likes, our user ID, we need this.props.db profile. And our history.replace should be an arrow function. Otherwise, this history.replace will run automatically whenever the component is rendered. And we also need is authenticated in our map state props. So this is it. Let's now test our app. So let's first begin by logging in. And let's now go to our forum. And perfect. As you can see, our likes are showing up. And of course, I did pre-populate the forum and the database with likes already. And let's just create a new post, and we'll just enter in some random strings. And let's now click on this post and then like the post. And awesome, it is working so far. And let's click the back button. And yes, if we see, our like is now showing up as before it was 0. And let's now go on this forum post and see if we can like it again. And no, if we click on it again, it is not updating, because again, our user ID is in the array of like users ID, and since the user IDs are matching, we cannot like the post. So let's try something else. Let's go on a completely random indifferent post and try to like that one. Alright, so we are able to like this post, and clicking on it again, no, we cannot like it again. And if you remember, we passed in a class name of num notification post when in our code in the show post component. And I just wanted you to see what it looks like without styling. So as you can see, the number is on the bottom right of the thumb icon. And again, it doesn't look as nice. It's usually what you see in websites is the number of likes is usually on the top right. And there's usually a red circle around the number. So let's implement this here. So let's go in our app.css file and create a .notification numPost class. The first thing we'll do is position relative, and this will allow us to play around with the position of the number and set it where we want. And next we'll do padding 5px and 9px, and this will again just give the number a little bit of padding because we're going to wrap it in a red circle. And then background color red, and the color of the actual text will be this. And again, this is just a random color I like. You can make it whatever you want based on your preference. And then bottom is 23px. And again, this gives us a way to position the red circle. And right 5px. So bottom means we're going to make the notification appear above what it is right now. And right, we're just going to move it a little bit right 5px. And then we'll do z index of -1. So this will mean it will be behind the thumb icon and will not be obstructing it. And then we have our border radius of 50%, and this is what makes it a circle. And let's save and check our browser. Since this is CSS, it will update automatically. We don't have to reload our browser to check if the CSS worked. And again, we do see, yes, we do have a little red circle in the number of likes. And again, this just makes it look a little bit nicer. And it's more common to see this styling in most websites. And just to really make sure, we can even go back to our main forum and then click on another post. And yes, it's still working. It's still the same. So we have our blog here, but if you look, we have one glaring problem. If we look at the date, it's this weird bunch of numbers, colons, and dashes. So we want to format our dates more nicely, and we can do that here in this section. So let's go back to our code. And the first thing we'll do is install the moment.js library. And this is the library we'll use to actually format our dates. So go ahead and just run npm install moment. And again, so you don't have to look at the loading screen. I've already done it here. And next, let's go in our post.js file and import moment. And let's now go in our render post functional component where we have our date created property. And let's put the entire date created property inside the parentheses of moment. And also be sure to wrap moment in curly brackets. To actually format the date, we do .format and then pass in the string of the format we want the date to appear. So I'll do mmmd0 and then comma YYY, which is month, date, and then comma year. And then we'll do a line and then do h:MMA, which would be hour, minutes, and then AM or PM. And again, this is it. This is all we have to do. And there are many other formats and ways of displaying the data you can do. And I'll leave a link to the moment.js docs if you want to format the date another way. But this is all we need to do for now. And if we go back to our forum, we'll see the date and it looks much, much better and more readable than it did before. And here's the moments.js page, and here you can see all the different options we have for formatting the dates. In this section, we'll continue building out our blog and set up a unauth redirect component. So a component the user will be redirected to if they're not signed in. So we don't want to redirect the user in all cases. We just need specific places where the user would be redirected if they're not signed in. For example, guest users will be able to read posts and comments, but redirected when they try to add a comment or a post or like a post. So really, we just need three main functionalities. We need to add a redirect to the add post and the submit comment button, and also the like post thumb icon. So let's do that now. So the first thing we'll do is create the actual sign up component, and we'll only need to import the button here. And again, it will be a functional component. Our sign up component will not have any state. So let's do const sign up and then props, and then we'll do a div with a header of sign up and create an account. And the next we'll have the actual button, which the user will be able to click. And we can just pass in some styling here. So color primary, and we'll have a large button and it will be contained. And then in the onClick method, we can do an arrow function and then call props.auth.login. And auth is going to be passing as a prop in our routes, which we'll see in a second. And again, this auth is the same one as the one we find in the utility file that we pass into the header as well. So this is going to be the same login function and auth object. And finally at the bottom, we can just export default signup. And now let's go to our routes and set up this component. So let's first import signup from functional/signup, and then we can just set signup to a route of signup. And again, remember to pass an auth as one of the props. So the first thing we can do is change the redirect for all private routes to /signup. Next, let's go in our post.js file. And here we need to modify our add post button. And we'll need the is authenticated property from our Redux to check if the user is logged in or not. So you can just do state.authReducer.isAuthenticated. And now we can use this state in a ternary expression and our add post button. So let's wrap the add post button in curly brackets and then set this.props.isAuthenticated as a condition. And if false, we will display a button that says sign up to add post. And of course, it will just take us to the sign up page. Now let's implement the unauthor redirect in our show post component. So let's go down to our render method, and then in the anchor tag, we have history.replace, and it just goes back to the home page. So let's just change this to the sign up page. And we'll also need to redirect on the submit button of the comment. So let's do that here with the ternary expression. So let's do this.props.isAuthenticated, and of course we'll need this property from the Redux state. And if isAuthenticated is true, we'll show the submit button, and if not, we'll show sign up to comment. And finally, we just need to import the link element from React Router DOM. And now we can save everything and check our app. So first we'll go to the forum, and of course, since we're not logged in, we should be saying sign up to add post. So it is working. And yes, clicking on the sign up to add post does take us to our sign up component. And then let's check our submit button for the comment. And yes, it is working as well. And let's now log in and see if it's working. And yes, after logging in, we are able to add post still. And let's click on a post. And yes, so our submitting post is working as well. So perfect. In this section, we'll implement our Fullstack search engine. And we'll do this with PSQL's built-in TS functionality, TS meaning text search. And we'll be making use of a special data type with PSQL, and this data type is called TS vector. And basically what this is a list of lexemes. And lexemes is a list of words that allow you to merge different variants of the same word, such as past tense or the plural form of the word. And as an example, dogs will come up in a search for dog. And this is all default functionality. We don't have to manually set up anything. And then the next PSQL data type we'll need is TS query. And this is basically what allows us to search and compare lexemes. So dog will be a TS query that will be compared with the TS vector. And if there's a match, a row is returned. And TS is a much more effective solution than the like operator, which you might see in older search engines with SQL. And the like operator does something similar to TS, but it does not handle natural language processing. So to get a result of dogs from a search of dog, you would have to set that up manually with like. So TS is obviously a better solution for handling all search. So we'll implement our search engine in our main forum. So let's go in our post.js file and begin setting it up. So the first thing we'll need is a text field where the user can enter in text. And we'll do this right under the sign up to add post and add post buttons. So let's set up our text field. We'll set an ID of search and a label of search, and we'll also pass in a onChange attribute that we'll set up. And we also want to animate our search results. So let's go to our local state and create two new properties. Let's create post search and set it to an empty array, and then post search motion and also an empty array. So post search will be an array of all the search results we get back, and then post search motion will animate these search results. So let's create our first function to handle searching. So let's create a function called add search post to state. And this is the function that will add our search results from our Express backend to our local state. And we'll first set this.setState post to an empty array. And this is because on each search, we want the array to be completely empty. We don't want to stack multiple search results together. And then our second one will set the posts. And again, we're doing the spread operator to flatten the array. And next, we'll also call this.animate search posts, which will be very similar to how we animate posts in our regular forum. And here's a good place to show you how TS vectorization works. So basically, when user submits a post, the title of the post, the body of the post, and the author of the post are all data that's contained in this post. And then to vectorize it, we actually combine all of these separate pieces of data into one TS vector. So this entire TS vector is an array that includes the title of the post, the body of the post, and the author of the post in one array. And each word is one element in the array. And vectorization also makes sure there's no duplicates, and it takes out arbitrary filler words like the and a. So that way you get more meaningful search results. So just typing in the will probably not yield anything because it's just a filler word that's taken out automatically. And now we can set up the function to animate the search posts. So we'll set this up in the same exact way we did for the regular post. So we can just copy and paste the code from our regular animate post function, and then we can modify it. So let's change post motion to post search motion, and then post slice to post search, and then this.state.post motion to post search motion. So let's now create a Redux store that we'll use with this Fullstack search engine. And as always, let's begin in our action types and then create two new action types, search post success and search post failure. And now we can just set up our two action creators to work with this action. So let's first start off with fetch search post. So it will just be action.actiontypes.search post success. And remember the payload of posts as well. And then we can do the same with the remove search posts. And then the most logical place to use these actions would be our post reducer. So let's set them up here. And then let's also create a search post property to use with these actions as well. And then back in our post.js file, we can set up our map state to props and map dispatch to props functions. So we'll do search posts and then set it to state.postReducer.searchPost. And then we want our post success, the action that actually saves the post to our Redux store. So it'll just be post success, then pass in post as a parameter, and then we just do fetch search posts. And now for our handle search function, and this will be the main function that will allow us to use search on our client side. So we'll first have to pass in the event keyword, since again we're going to be using this in the on change of our text field. So what we're going to need is the search query, and this is going to be event.target.value. And again, we do this because it's just a text field, it's not a form. So we don't need to do event.target.search.value. And then we do our axios.getRequest, so it'll be api/get/search-post. And then for the parameters, it will just be the search query. And this is all something we've seen many times before. We then use a .then statement, and then we do res response. And then we do this.props.postSuccess, our action that we just set up. And then we're going to pass in res.data, which is going to be our posts. We then do another .then statement, and since our last one just saved the post to the Redux store, we can now access it from a Redux store. So it'll be this.add search post to state, which is our local function that saves it to our local React state from our Redux state, and then we just pass in this.props.searchPost. And again, this.props.searchPost is coming from our Redux store. And then we just do our error handling on the next line. And now we can simply pass a reference to this handle search function to our onChange event. Remember, we're not calling this function, we're just passing a reference to it. And also notice we don't have a submit button here. This is because we're going to call this function on every keystroke. So what this is going to do is allow instantaneous search results. And again, since this is React in a single page app, we don't want to do submit and then reload the page with search results. We can do it completely dynamically. The user will just enter in key phrases and then have the search results automatically appear if there's a match. They don't have to submit and wait. And again, this makes the forum look very modern and high tech, and it's definitely the way to go. And then we also want to render our posts, so we'll do this in a ternary expression. And we'll just do this.state.postSearch. So if the posts are in our local state, then we do the map function on our search motion, and then we pass in each post to the render post functional component. Remember, the render post functional component is the exact same functional component we use to render the regular post in our forum. So we can use the same one here as well. And again, this will give us more consistency and a better overall look in our app. And then for the else statement, we can just do null. And that's really it for the client side. We can now go to the server side and set this up as well. So to use your search vector, we'll actually need to create a new column in our post table. So just create a column called search vector of type tsvector. And as we know, just typing it in here in the SQL schema file does not do anything. So let's open up our shell and then type in the command. To add a column to a table, you do alter table post, add column search vector ts vector. And this essentially just adds a column to our already existing table. And this is really it for the SQL. We don't really have to do anything else. We can now go in our routes and set up the query to work with this ts vector. So we'll first have to modify our post request for saving posts to the database. So we'll have to modify it to basically add ts vectors when the post is being submitted. So let's just copy the post request and then comment out the old one while we set up the new one. So as mentioned, we're going to turn both the body, the title, and the author of the post into ts vectors. So let's create a separate variable for each of them, and let's also pass them into the string function. And then we can combine these three vectors in a search vector variable. And finally, we'll just add this search vector variable to our values array. And then now let's add this to our SQL query. So insert into post, and then let's add search vector as the third argument, since that's what it is in the variables array. And then in our values, we actually do two ts vector on the search vector, and this converts our input to a ts vector where it is saved in the PostgreSQL database. And I'll show you exactly how this works when we submit our post. But for now, just know that our array is now being converted into a ts vector with this PostgreSQL given function. And next we have our get request to get the post from our database. So we'll do router.get API get and search post. And then we'll do a search query of string and rec.query.search query. And this is going to be the same search query that's coming from our text field in the post.js component. And again, remember, this is called every time a user enters a key in the text field. And then we'll do pull.query and then select all from post where search vector @ means equals to ts query and then $1. So to ts query turns our search query into a ts query, which allows PostgreSQL to compare them together. So to put it another way, so select all from post. So post table, select all from there where search vector, which is a column name in our post table. So search vector is one column. @ is a match. So where search vector matches to ts query $1. Remember, ts query is a data type that allows us to match ts vectors. And we saw that in the first slide at the beginning. So to ts query turns our search vector $1 that we're getting from our front end to a ts query. And search vector is a ts vector. So ts vector compared to a ts query. And this is what makes search possible, comparing a vector, ts vector, to a ts query. And then what's returned is everything that matches. And remember, dogs will match a search query of dog. And this is all the code that's needed to make that happen. And before testing our app, let me just fix one small typo. Post here in the add search post to say it should be post search. And this is really it. This is all we need to start testing our app. So let's save and go to our browser. So we first have to log in to start making posts. So let's do that now. And then let's add a post of cats and fishes. And this will allow you to see the search query being able to get plural forms of the words that I was speaking of earlier. So let's go to our search bar and enter in cats. And as expected, we do see our search query. And again, we just got returned 2 because cat and cats are both matching. So it accidentally returned it twice because we did it so fast. But if we take the S off cats, we do see cat is still turning up a search results for cats. And this will work for fishes as well. So let's type in fish. And again, remember, our body of the post is available as a search query. And even though it's fishes with a ES, the PostgreSQL dictionary still knows that this is still the plural form of fish. So our search query is still returned. So let's test the past and present tense of words. So let's create a post called walking, and the body can be acted. And let's hit submit. And then if we go back to our search bar and enter in walk, walking does appear as a matching search. So again, the present tense is working. Awesome. And if we enter in act, and again, acted matches act. So our post is returned. So awesome. So this is basically how the present and past tense of words is still shown up in the search query. And then I'll now show you how this looks like in our PSQL database. So let's open up our shell and then type in select all from posts. So here are the 2 posts we just submitted. So we have cat and then :1, fish :2, and then test91 :3, which is the author of the post. And this is essentially how it works. Cat is a string that's being converted to the first lexeme. Fish is the second lexeme. And then test91 is our third lexeme. And that's essentially how it's stored in our PSQL database. And again, notice it's not cats and it's not fishes. Fishes and cats were our original submission to our PSQL database, but since it was a TS vector, it's converted to its base root form, which is what allows it to be compared with other variations of the word cat. And if there's a match, then it's returned. And again, this is the same thing for our second post. Acting and walked was what we submitted, but we see here it's act and walk. Again, this is because, again, even though we submitted the past tense, the TS vector is going to be the root word. And this root word is what allows PSQL to compare different variations of it. And this is essentially how text searching works. And then now I'll just quickly show you that you can also search for the username of the person who submitted the post as well. So if we enter in test91, we see that all the posts that this user submitted are rendered here. So we can also search for posts by the username as well. So a common functionality seen in modern blogs is the ability to click on a username of another user and have their profile dashboard display. And you would also see some of their latest activities, such as their posts. And this is what we'll implement in this section. We'll have the ability to click on a user's profile name from our main forum and then display that user's posts. So we'll need a new directory for this, and we can call this directory profile. And let's start with our usual imports. So we need React and component, and then we need connect from React Redux. We also need the link from React Router DOM. We need the actions, Axios, moment, and then we're going to be displaying the user's posts in a card. So we'll need our card imports as well. And finally, we'll just have a button. And then let's just initialize our class with an empty div for now. So as mentioned, we're going to be accessing our show user page from the main forum. So let's go to our post.js file and then set up the routing. So let's go down to our render post functional component and then add a link. And we'll wrap the author name with the link. And then we can also pass in styling of padding left 5px, text decoration none. And then 2 will be /user/post.post.author. So the username of the user will be in the URL. And then we can also pass in the entire post to the state property as well. And we'll also display the posts in a card in our other user profile page. So let's just copy the code from here and then paste it to our show user.js component. And we can also get rid of the link element here. So we can now set up our component did mount method. And here we're going to do 2 things. We're going to call a get request to get the user's profile data from our database. And then we're also going to get all the posts associated with that user. And we're going to do both of these things with just the username of the other user. So I'll start with our first axios.get request. And this will be API/get/other user profile from DB. And then we'll pass in the username to the params property. And again, this is all something we've seen several times before. And then we do a .then statement and then res, and then this props.set profile res.data. And again, this is how we're going to save the user profile data to our Redux store. And then our second axios.get request will be /API/get other users post. And same thing, we pass in the username to the params. And then we do the exact same thing with the .then statement. And then finally, we need window.scroll top 0 left 0. Because when a user's scrolling through the post and they click on a username, the page is not going to automatically go to the top. So if they click on a username of a post that's at the bottom of our post.js component, it's going to stay at the bottom. So this is just how we ensure that the page is on the top when a user clicks on another user's profile. And then let's go to the bottom of our file and then set up the map state to props and map dispatch to props functions. And again, we haven't set up these properties or actions yet, but we will in a second. So let's just do first user profile and then state.userReducer other user db profile. And then user posts, we do state.userReducer.db other user posts. And for actions, we do set db posts, we pass in the posts, and then we do dispatch actions get other user db posts. And we do the same thing for the profile as well. Then next we'll do the render profile, and we'll keep it simple for now. We'll just display the user name in a h1 in large heading tag. And since we're passing in the profile as a props, we can just access the username with props.profile.username. And then in our render method, we can use a ternary expression to display this render profile. So our condition is going to be this.props.userProfile. And then if true, we do this.renderProfile, and then we set a profile prop and then pass in this.props.userProfile and then the first element in the array. And if false, we'll just do null. And then after this, we'll do a header of latest activity, and then we'll display each of our posts. And we'll do this in a very similar way to what we've been doing. So we'll just do this.props.userPost as the condition, and then we'll just run the map function on the user post. And then to give a little bit of space between each post, we can do div and then this.renderPost key, because again, this is an array. And then the key is just going to be the PID, and then we'll pass in the entire post as well. And then also do BR as a element after the render post. And again, this will just give a little bit of space between each post. And then we'll just have our closing div tag. And that's it. We can now import our show user component to our routes.js file. So let's go here, and then remember it's ./profile/show user. And then the path will just be /user/:uid, and then component equals show user. And that's it. There's nothing really complicated we have to do to set up the user's route. So let's now set up our Redux store. And we'll of course start with the action types. So the first one is going to be set other user DB profile. We need remove other user DB profile and set other user posts and remove other user posts. So let's now go in our actions.js file and then set up some action creators to work with these action types we just set up. So let's just copy and paste our other action creators to save us a little bit of time. And remember, the actions we want are going to be get other user DB posts and set other user DB profile. So this is the names we will set here. So let's first start with our set other user DB profile. And remember to pass in profile as the parameter and then set it to the payload. Then we can do the same for remove other user profile. And then we can do the exact same thing for get other user DB posts. And now let's set up our reducer. So we'll need two properties, other user DB profile, which will initialize to null, and then DB other user posts, which will just be an empty array. And then let's just set our case statements as we've seen many times before. And make sure do not wrap other user profile DB or DB other user posts in an array or an object. Just leave it action.payload. So we can now move to the server side and set up our routes and SQL queries. So as mentioned, we'll just need two routes, one to get the user profile data and then one to get the user post. So let's start with getting the user profile from the database. So let's first set the username const to a string of rec.query.username. And remember, rec.query.username is what we're getting from our client-side app from the show user component. And again, it's contained in the params property, which is the second argument we set in our axios.getRequest. And we'll run the string function on it. And then we'll do pull.query and then select all from users where username equals $1. And then we'll set username in a array. And then we'll have our queue_error and queue_res arrow function. And then we'll just do res.json and then return the rows to our client side. And then we can just copy and paste this get request and then we'll modify it a little bit. So we'll do API/get/other user posts. And then the username const can stay the same, but our SQL query will be select all from post where author equals $1. Because remember, there's no username column in the post table, it's author. And then we just pass in the username const in an array. And of course, we'll just get rest.json and then the rows. And then the last thing we have to do is just go to our show user component and then connect our map state to props and map dispatch to props to the show user component. And that's it. That's all we need to begin testing our app. So let's go to our browser and go to our forum. And to save time, I've already pre-populated the forum. And if we click on test91, yep, we are directed to the user/test user URL, and we see all the posts that test91 made. So perfect, it is working as intended. In the last section, we set up a user profile page that allows you to see another user's posts. So another functionality in a lot of blogs is the ability to send messages to other users. So when a user clicks on another user's profile, they should be able to see a send message button and then message this person. So this is what we'll do here. So our custom messaging system will comprise of 3 components. We'll need a send message component to actually send the message, a show messages component that will display in a table all the list of messages a user received, and then reply to message. And again, this will automatically set the username in the component so the person does not have to enter it in manually. And our messages will be saved in a messages table with the username as a reference. So we can look up and query messages based on the username. So let's go back to our app and get started writing the code. So it's going to show user component, and then under the username of the person, when a user looks at another user's profile, they should see that send message button right under the username. So let's create a button and then wrap it in a link. And then the path name will be /send message. And then we'll also pass in props to the state, which will give us access to the entire profile of this user. Now that we have our entry point for sending messages set up, we also need a way to show the messages, and we'll do it in the user profile dashboard. So again, this is the original profile.js component we set up that is our original user dashboard, and we'll display the show messages button under the user profile, and we'll do it in the same exact way. We'll wrap a button with the link, and then the path name will be /show messages and then plus the user ID of the user. And we didn't need to specify a unique user ID for the send messages because again, it's just a form, and the form is the same for all users. Each user will not have a separate form to send the messages, which is why in that component we just had to use /send message without a unique user ID contained in the path name URL. So let's now begin setting up our send message component, and we'll set this up in our profile directory. So let's do sendmessage.js, and then let's handle all of our imports. So we're going to need Axios, history, connect, text field, because it's going to be set up as a form, and then a button. And then we can initialize our class with an empty div. So now let's set up our form. And remember, the form takes an onSubmit event, which we'll just leave blank for now. And then we're going to need 2 text fields, one for the title of the message and one for the body. And of course, the title is just going to be a regular input element, and our text field is going to be a multi-line text field. Next, we can have our submit button, and then we'll also include another button that will be a cancel button, and it will just redirect the user back to the home page. And we can leave this without any styling because again, it's just a cancel button. And let's now set up our handle submit function. So we'll do handle submit equals event. Remember, the event keyword is important here. And then we'll do arrow function, and then the first thing we'll need to do is event.prevent default, since again, this is a form and we don't want our browser to reload when a user hits submit. And then we do const message to username. So this is going to be the username of the person we're sending the message to, and we're going to get this username with this.props.location.state props.profile.username. So in case you missed the last section, we are getting this username from our showuser.js component, and this is a functionality we get from React Router. We're passing in state in the props object to the link element, and this allows us to access the username here. And we're getting the props from our render profile element, and we pass in profile as a prop and set it to this.props.userprofile0. So this is the user profile data we're getting from our Redux state. We're passing it to the render profile element in the profile prop, and then we're passing that profile data as props to the state property of React Router. So this is where everything is coming from in the flow of where we're getting our username. Then we can go back to our send message component and then finish it off. We need the message from username here as well. So we'll set that to this.props.dbprofile0.username. And this is the username of the person that's sending the message. And then next we have the message title and body from our form, which we can access in the same way we've seen before. And let's now combine all of these data points into one const of data in a JavaScript object. And then we can have our axios.post request. So it would be /API/post/message2db, and then pass in data as the second argument. And then we can just have our usual .then and .catch helper functions. Great, and let's now go to the bottom of our file and set up our map state to props. And we only need one property. We need the DB profile of the current user that's sending the message. So we just do DB profile state.authReducer.db profile. So let's now set up our show messages component. So we'll first start off with our usual imports, but remember we'll also need a table because that's how we're going to be displaying our messages. And then after the imports, we can initialize our show messages with an empty div. And then let's get started with our table. So we'll first need a table element and then the header, which will be a row that just has messages. And that's it for the header. We don't need to specify that we're also displaying the body of the message as well. And then let's go to the table body, and then inside we'll do a Turner expression with a .map statement. So we'll do this.props.userMessages, and again, this is going to be coming from a Redux state, which we'll set up in a second. And then if true, we run a map statement on the user messages array. And then for each message, we just pass into the render messages functional component, which we will set up in a second. And then we need the key because again, it's an array. And then we pass the entire message down to the message prop. So let's now set up our render messages functional component. So we'll start off with a row, and then each row will have a table cell, which will contain all the message data. So in the first line, we'll do a paragraph from, and then it's going to have the name of the person that sent the message, and then title, which will be the title of the message, and then the actual message itself. And then we'll also have the date created of the message. And then we're going to need a reply button and then a delete button. So for the reply button, we can wrap it in a link because clicking on reply will take the person to another component, the reply to message component, which they will then reply to the message. Our delete button can just be a regular button that calls a delete message function, which we will set up. And then our cancel button can just go back to the previous page. And at the bottom, we can set up our Redux store. So in the map state to props, we're going to need DB profile, which is just the profile we've been working with so far, and then the user messages, which will just be an array of all the user messages. Then we'll also need a action to set the messages from our database to the Redux store, and we'll just call this set user messages. So we can now set up the reply to message component. So let's set up our usual imports and then the empty div class. So the first thing we're going to do is display the actual message. So let's start off with a header of message, and then each of our pieces of the message data can be displayed in a flex column. And we'll use the syntax we've seen before, this.props.location.state. And again, this is coming from our render messages functional component in our show messages.js file. And then we can also have the two other pieces of the message, which is the body and the sender. And then underneath this, we'll need our form to reply back to this person. And again, since this is just going to be a form that we use to reply to the message, we can just use the code from the send message.js component. Because again, it's the same thing. We're just creating a form to send a message. So after setting up the form in a render method, we can set up the handle submit function. So first thing we need to do is do event and then event.prevent default. And then we need the message to username, and we get this from location.state.props and then message sender. The message from username is just the username of the current user, which we can get from DB profile. And then the message title and message body we're getting from our form. And then we combine these pieces of data in a data const. We then do a axios.post request and then API/post/message2db. And then we pass in data as a second argument. And then we can just have our .then and .catch console log error statements. So then in our map state to props function, we just need the DB profile. Now we can set up our action types and actions. So we're just going to need two action types, the set user messages and then the remove user messages. And now we can set up our action creators, and remember to pass in messages to the payload property. Now let's go to our user reducer and then set the user messages property to an empty array, and then we can set the user messages property to action.payload. And then let's just go back to our show messages component and check it really quick. And the render messages functional component should be a wrapped in parentheses instead of curly brackets, so let's change that here. And then we're going to need -UI in the import statements of the table. Let's now set up the routes for each of these components. So let's go into our routes.js file and then import send message, reply to message, and show messages from our profile directory. And let's now declare our routes. And remember, all of these are going to be private routes, meaning a user needs to be authenticated to access them. And then show messages, remember, is going to have a /:ID because it's going to be a dynamic route. And then all of these three routes will need the auth prop passed in. And this just passes the entire auth utility object to each component. And this is it. Let's now move to our server side and first start with the SQL. So here at the bottom, we have our messages SQL schema. So first we have MID, which is just the primary key, and then the message sender, which is just a character that references the user's username, and then the message to, which of course is also referencing the users table and the username. Then we just have our title and body of the message. And title, I set a limit to 255 characters, and then the body can be any length. And finally, we just have our date created, which is a timestamp. So now let's go to our routes.js file in our remember server directory, and then we'll set up the express routes and the SQL queries. So at the bottom of our file, let's do router.post, and this is going to be to save the message to the database. So we'll do API/post/message2db, and then we'll get our data from our front end in the usual way. So it'll be const from username, then we'll do rec.body.message_sender. And again, remember, this is all coming from our client side handle submit function that we set up in the send message.js file. And then our username, title, and body are also coming from our front end client as well. And let's wrap everything in a string function. And then we can just combine these four variables in a values array. Then in our SQL query, we just do a very standard insert into messages, and then we do the name of our columns in our PostgreSQL database, and then the next line we do values, and this is just going to be the values const array, and then we just do $1, and remember to match up the values with their correct column name. So message sender is matching $1 since that's the from username, the person who's sending the message. And then we just do comma and then values. And then we have a regular QRES and QError function. And we're done with the post message route. And then we can just copy and paste this for our router.get to get all the user messages. So one thing we're going to change is we're going to just delete everything except for the username, because that's all we need to look up the messages. And then our SQL query is going to be select from messages where message2 equals $1, because again, message2 means the person that received the message. And then we do comma and then pass in the username into an array. And then we have our regular QRES error function. And then remember to do rest.json because we want the response saved in JSON format. And then finally we have our delete statement. So it's just going to be router.delete and then /API/delete. And then here we only need the MID, which is the serial primary key of each message. So our query will then be delete from messages where MID equals the $1, which is the MID we're getting from our front end client. So this is really all we need to begin testing our app. Let's go to your browser and then sign in. And let's click on the forum, and then we'll click on test91. And again, this is a different test user than I signed in with. And then we'll just do a random message we'll send to him. Okay, let's sign out and then sign in with this test91 user that we just sent a message to. And we need to go to our profile page to access the show messages. And yes, this message that we just sent is right here. And if we test our first delete statement, yes, we do see that it is working. And again, I just have a few more messages here just for demonstration purposes, because you don't want to sit here and watch me send 3 messages. Then let's test our reply to function. And since we replied back, let's sign in to that other user that we replied back to. And there it is, perfect. Our message that we just sent from test91, it's here. So there it is. We built a custom messaging system from scratch using PSQL. Well done. So we can begin now setting up our admin app. And one of the main things we will need in the admin app is global edit and delete privileges on the entire forum. That's one of the main functions of having an admin app. And we'll also be setting up an admin dashboard, and this will be a big calendar that will list appointments for the admin. And we'll also need the ability to delete users along with their posts and comments. And deleting the posts and comments associated with the user is going to be handled automatically. The admin should not have to do it manually. So here's a basic diagram of how we're going to set up our admin app. So our admin app is actually going to be a completely different web app, and it's going to be completely separate from our regular app. Even if you deploy it, it will be hosted on its own URL. And it's not even going to use the same authentication as our regular app. We're going to set up a completely different authentication for our admin app, and it's going to be connected to the same PSQL database as a regular app though. We're just going to access the database from a different web app. And this is how we're going to implement edit and delete privileges. Because if it was a separate database, we would not have the ability to do this. So in the last section, we said we're going to have a completely different authentication system for our admin app. And we'll set it up here. And we're still going to be using Auth0 for authentication. It's going to be a different application on Auth0. So first, let's actually create the application. And just name it something related to admin, so you know it's an admin app. I'll call mine admin app 10. And since we're also going to be using React to build this admin app, we also need to select single page app. Next, we need to create a database connection to this app. So go to connections and then database, and then name it something to identify it with our admin app. So I'll call mine admin app 10 dbcon. And then very important, make sure to click the slider that says disable signups, because again, this is a admin app. We don't want random people to be able to sign up for it. And then doing this, we will only have a login screen when any user visits the admin app. And then just go ahead and click create. Next, let's go back to our applications and then go on admin app 10, and then let's go to the connections tab. Here we can disable all the other database connections and just check the slider for the database connection we just set up. And again, this is what ensures that our authentication systems are completely different. We're not storing our regular users with our admins and vice versa. Our admins are going to be stored in a completely different database in Auth0, and they'll have no connection to our regular users for our regular apps. And again, this is done for security reasons. We want to keep everything compartmentalized and separate, and this makes it easier to control and therefore is more secure. So you might now be asking, if a user can't sign up, then how would we add admins to this app? And let's do that now. Let's go under users and then just click create user, and then you can enter in the email, password, and the connection. And remember, the connection is just admin app 10 dbcon, and this is essentially how it works. We manually add users, and then they get stored in our db connect, which is just our database. And in our regular app, when a user signs up, then they are added to the database. So this is just a separate way of adding users to a Auth0 database. And then after you're done, just hit save. And this is really it. This is all we have to do. We can actually now test to see if this works right here in Auth0. So let's go to connections and then database, and then admin app 10 dbcon, and then you'll see a try connection tab, and let's click on that. So again, let's now enter in the login info that we set up just a short while ago. And actually, to really test this, let's actually enter in the the wrong login info and see if it's letting us sign in. Just do admin 155. And if you see no, we can't log in with this. But let's try the real one, the actual login info. And yes, it's working. Awesome. So let's now hook up our admin app to our actual code. And this is going to be the same exact way that we hooked up our regular app to Auth0. So we first need the client ID, and then we can just paste this into our code. And then back in Auth0, we need to allow the callback URL for React, which is localhost 3000. And then we just need to hit save changes. And that's really it. That's all we had to do to set up our authentication system for our admin app. And this is really due to Auth0 being a very easy to use and having a lot of out-of-box functionality. So we don't really have to worry too much about hashing and saving the passwords. This is all handled for us by Auth0. So in this section, we'll set up our admin forum. And as mentioned in the intro slide, our forum will have global edit and delete privileges for all comments and posts. And to implement this, we'll first start off with our post.js file, which will have to be refactored. And posts will be displayed in a table instead of the animated cards we had in our regular app. And this is because we don't need pagination in our admin app. We can just display all the posts in one big table, and this will make looking through them much easier. Our show posts will also require minimal editing. We will just need to have edit and delete privileges for all the comments on a post, which will not be too hard to do. Our edit posts and add posts will also require very minimal changes. And we actually don't need to change the server code at all. We can just work through our already existing API requests to our database. So let's get started. And again, we're using our posts and our blog setup that we used for our regular app. We don't need to start everything from scratch. That would be just a waste of time. So we can just refactor our already existing blog that we had for our regular app. So let's go to our post.js file, and the first thing we'll do is delete all the local states. We can delete our two helper functions that we use for animation because, again, we're not going to be animating anything here. It's just going to be a plain app. And in our render method, we can also get rid of the sign up to add post button because in the admin app, a admin will always be authenticated and signed up. And then let's get rid of our pagination. And great, let's now import our table and our dialog. And our dialog is going to be a modal that's going to essentially confirm a deleting of posts. And then we'll need our usual two properties to handle our dialog box. We'll need an open, which will set to false, and a post ID null. So basically when a user clicks on a post to delete it, that post ID is going to be saved to the local state, which will then be passed off to our delete function, which will then delete the post. And then after these two pieces of state, let's also create the two helper functions we'll use, handle click open and handle click close. And again, this is all something we've seen a few times before. And let's now go into our render post functional component and delete the card elements, because again, we're going to be displaying it in a table now. And before setting this up, let's also set up the table in the render method. So here, let's set up our table as we've seen before. And then to actually display the posts, we'll do this.props.posts. And again, this is coming from a Redux state directly. And since we don't have to animate them, there's really no point to saving the posts in our local component state. So we'll just get them directly from our Redux state and then pass them into the render post function. So let's now set up our render post function. And let's start as usual with our table row, and then all the data is going to be displayed in a table cell. So we'll first start off with the usual post data, and then important to know, we're going to add the edit link right here in the main forum. Because again, the admin will have global edit privileges, and this is how we do it. We have it on the main forum. We just have a link to the edit post from our main forum, which will give a edit link to the entire forum and therefore all the posts. And then we have our delete button here as well. And for the same reasons, it's global delete privileges, and it's accomplished right here in our post.js component. And remember to also pass in the post ID to the handle click open function, because this is how we keep track of what posts we're editing or deleting. And then now let's import our text field, and this we'll use to search for posts. So again, we're going to have a search capability in the same way we did for our regular app. So let's change it in our render method. Let's do this.props because again, we're getting it directly from our Redux state. And we also want to display the search results in a table. So let's just copy and paste our code from the regular posts. So now let's set up our dialog box. So the first property we pass into our dialog box is open, and this is going to be this.state.open on close, and this will be handle click close. And remember, we're not calling handle click close, we're just passing a reference to it. And then we have our two labels, and this is going to be area labeled by, and it will be alert dialog title, and then area described by and alert dialog description. And then we have our dialog title, which is confirm delete. So again, this is just a pop-up box that's going to be basically confirming deleting a post. And then we let our admin know that they're deleting the post by passing in deleting post to the dialog context text. And then our dialog actions will just be agree and cancel. So let's now set up our delete post function. And this is going to be a very similar way of doing it that we set up in our profile.js component in our regular app. So let's first start with the const post ID, and it's going to equal this.state.post ID. And again, remember, this post ID that we save to state is coming from our handle click open function on our render post functional component. And again, this ensures that we're deleting the correct post. And next we have our Axios delete statement. And remember, because of the foreign key constraint, we have to delete post comments before we delete the actual post. And I'll explain foreign key constraints in PostgreSQL in great detail in the users component when we set up the users component in the admin app. And after the deleting posts request, we do a .then statement and then do another Axios delete statement and delete the post. And we're passing in our post ID to the data property in both of these Axios delete requests. And after this, we have our catch error console.log and our .then, which will close our pop-up box. And then we have our history replace, which will redirect to the home page. And let's also make sure to import history since we're going to be using it here. And now for our edit post component. In the handle submit in the edit post component, let's change user ID and username. So how we currently have it set up is our edit post submits the post with the current user's ID and the current user's name. But this is the admin app. We are submitting from the admin, but we don't want to save it in our database as the admin. We still want our posts to be associated with the user who originally submitted them, but we still want to be able to edit it with our admin. And to handle this, we change user ID and username to this.props.location.state, and then the post UID and then the post author. And again, we have all this data available through our main form, because again, we pass in the entire post to the state property of the link element. So we can access it here like so. And then let's also just redirect to the home component instead of the profile component. And we're done with the edit post component. Let's go to our show post component and set up that. So in the same way we have global edit and delete privileges on the posts, we also want the same privileges on the comments. To accomplish this, let's go in our render comments function and simply delete the ternary expression that checks if the user ID is equal to the current user ID. And this will make the edit button appear on all the comments, which will give us global edit privileges and delete privileges as well. So let's now look at our handle submit function. Do we need to change this? And really think about it. And the answer is no, because the admin should be able to submit a comment as normal. And remember, this is connected to the same database, so this admin app will submit a comment and save it in the database like a regular comment. So for that reason, we can actually just leave this alone, and we'll have our comments appear in the regular app as if a user submitted it from the regular app. So we don't actually have to change anything in the handle submit function. And in our regular app, it will also show that this comment was submitted by an admin. So it works as is, we can just leave it alone. And how about our handle update function, which edits a comment? Do we need to change this? And the answer is yes, we do. Because remember, we're editing a comment as an admin, but that comment is posted originally by someone else. And because of that, we want to keep their original user ID and username to the database. So that comment is still associated with that user. We're just editing it as the admin. And again, the reason for this is maybe you have a user that posts something that's maybe worded incorrectly or has a typo. We can edit it for their benefit. And again, this is a very common functionality you see in most blogs. So we have our user ID and username, and we're getting it currently from this.props.db profile. And this is how we set up in a regular app, which gets that current user's user ID and username from the Redux store, from their profile. And now we actually have to change it to keep that user ID and username. And how we do that is the same exact way we did for the posts. So we use this.props.location.state, which again contains the entire post, including the user ID and username. So let's change our UID and username. Now in our render method, let's get rid of our authentication ternary expression for showing the submit button or not. And this is because in an admin app, the admin should always be authenticated. There should never be a situation where an unauthenticated user is viewing or using our admin app. That would not make any sense. So for that reason, we actually don't need the authentication state. Therefore, we can just always show the submit button. And let's make one change in edit posts. Let's add a set timeout to the history.replace call. This will make it look more natural. And let's just set 300 milliseconds. And back in our post.js file, we can set up the link to our show post component that we just set up. So we're going to do this in the same exact way we did for the regular app. We're going to have a link of posts and then the post ID. And again, this will ensure a unique URL for each post. And then we'll pass in the entire post, which again is our argument in the render post functional component. We have post, and we're going to pass that entire post object to the state property of the link element. And then we'll display the post title in a h3 tag. And that's it. We can now test our admin app. So let's do a fresh login. So after clicking on the login, we see the name of our app, which is admin app 10. So this is good. Auth0 is using the correct app. And then we do admin app 15 at admin.com. And this is the user we manually inserted into our database in Auth0. And again, we should not be seeing sign up anywhere in only the login form. So this is good. This is what we want. So good. Our authentication is working and we are signed in as our admin now. So let's go to our forum and test it out. Let's click on the first post and hit edit. And then let's just write some text here and then hit submit. And yes, if we are redirected back and our post did edit, and important to note, if we look under bike, it's still for test 91. So even though we edited it as the admin, it still belongs to the original user who posted it. And let's now click delete. And yes, if we go back to the forum, it is working. And you can also see in the console, we have our response from the server saying status 200, which means it did work. All right, and let's just click on a couple of posts and see if it's working. And now let's edit a comment. And yes, perfect. We are able to edit comments. And also notice we did not change the user here as well. It's still test RR. And let's now try deleting it. And you'd maybe want this if maybe a user submitted an inappropriate comment or something along those lines. And if we hit delete, and yes, it is working perfect. And our console clearly shows our server response, which is also showing a status 200, which means the delete comment request did work. So perfect. And just to really make sure, let's go back to our forum and come back to this post. And if we do that, we see clearly that we don't have the comment here anymore. So it worked. So awesome, we're done. We set up an admin forum with global edit and delete privileges for our posts and comments. In this section, we'll continue building out our admin app in the admin dashboard. So let's create a new file in our profile directory called admin-.js. So as always, we'll start off with our usual imports. We'll need React and component, and we'll need connect because we're going to use the Redux state in this component. We'll need our actions, the link from React Router DOM, we'll need the history utility, and we'll need Axios. And a very common feature in admin dashboards is a calendar. So we'll be implementing this here. And we'll use a helper library to build the actual calendar. And the library is called react-big-calendar. So you don't have to look at a loading screen. I've already downloaded this library. And if you haven't done so, just go ahead and just run npm install react-big-calendar. And of course, we don't want to manually handle all the dates, so we'll use the moment library to assist us with that. And finally, go ahead and import the CSS for the React Big Calendar as well. And the import path is going to be React Big Calendar /lib/css/ React Big Calendar. And again, this is just importing all our styles, and this will actually set up the calendar. And then let's continue with our imports. We're going to need paper from Material UI, and this is going to actually display all of our appointments, which we'll implement also. We'll need a card, we'll need a dialog, and then finally we'll need a button. So let's now create a variable to initialize our big calendar, and it's going to be a const of localizer, and the value is going to be bigcalendar.momentLocalizer, and then pass in moment as an argument. Again, this just initializes our big calendar and makes it work with moment.js, and moment.js is the same library we used before to handle the dates. Next, we're going to set a bus open time and bus close time. And this is going to be the business open time and business close time. Since we don't want users to make an appointment, for example, 1 in the morning on a Saturday, we want to keep it within the business time. Next, we have all views, and this is going to be the views the calendar is capable of displaying. So pass in a string of month, week, and day. And this is saying that our calendar is capable of displaying dates as the month, week, or day. And again, we'll see this when we do our testing. And finally, we can initialize our admin dash class with a empty div. So the first thing we'll do is actually get all of our appointments from our database. And we'll do this in the component did mount method, and we'll use the Axios get request. So do /API/get in all appointments. We'll then run a .then statement, and then the response we get from the database will pass it to our Redux state and save it there. Next, we just do our .catch error handling, and we'll need another .then statement to actually save our appointments to the local state in the events property, and we'll see why in a second. It's basically because we have to pass in all of our appointments to the big calendar. And finally, we have another .then statement that will be date string to object, and this is how we'll convert our appointments to a usable format for big calendar. Because again, the way it's stored in the database is not how you would use it in the big calendar. So this is what this function is for. So let's now set up our local component state, and we'll do this in the constructor. So we'll do this.state equals, and then we'll need the first property to be open. And again, we've seen this many times before. This is for the dialog box to open and close it. Next, we'll need events, which will be an array, and this is what we'll save all our appointments to, our array of appointments that we get from our database. And we'll need another array called format events to hold the formatted events that are formatted to be used in big calendar. And we'll have our start display. So this will actually be a start time that is displayed to the user, to the UI, because you can't just directly display dates without formatting them correctly. So this is what this property will do. And then we have our start slot and end slot, and these will hold the dates of the appointment, the start date of the appointment and the end date. And again, start display and start slot are the same exact time. It's just that start display is a property that is formatted to be displayed to the UI. So when a user wants to make an appointment, they'll see start display displayed to the UI, a formatted date. The start slot is the unformatted date that's to be saved in the database. Alright, and now let's get started with our helper functions. So we'll need handle click open and handle click close, and these are the same exact helper functions to open and close the dialog box. So we'll just set state open true and set state open false. And then we have our dates to string object, and this is what will format our appointments correctly to be used in Big Calendar. So remember, this.state.events holds our unformatted raw appointments, and so we run the map function on them because it's going to be an array of appointments. And then for each appointment we do this.setState, and remember, format events is a property we want to save our formatted events to. And then format events is an array, so we have to declare the array and then flatten it. So we do ... this.state.format events, and this just flattens all of our array. And then how we add a new formatted appointment is we do comma. So this will put our appointment at the end of the array, and it's going to be a JavaScript object. So we do the curly brackets, and then how we format each appointment is first we need an ID, and this ID is going to be contained in appointment.aid, and AID is a primary serial key that's generated by PSQL. So that's where it's coming from. And then we have title, so it's going to be appointment.title. Our start time is going to be new date, and then appointment.start time. And again, date just formats our date time so it can be displayed appropriately. And then we need the end time as well. And that's really it. That's how we format the dates. And now we'll set up our handle appointment confirm function, and this will be how we save our appointments to the database. So it's going to be an Axios post request. So first we'll need the time start, and again we'll get this from this.state.startSlot, and this time is going to be coming from our Big Calendar, which we'll see in a second. Our time end is going to be this.state.endSlot. Our data is going to be a combination of this, and for now we'll just put the title as a string of booked. And then we now need our Axios.post request. So it's going to be Axios.post/API/post/appointment. And then of course we pass in our data variable as the second argument. And then we can just console.log the response. We also need a set timeout, and we'll redirect to the home page after 700 milliseconds. And let's also do a alert of booking confirmed. So this lets the user really know that the booking was confirmed. And now we have our show to-dos function, and this will display each appointment for us in a list. So we'll display all of our appointments on the physical calendar as well, but we'll also have them in a list, which makes it a little bit easier to see and know when the next appointment is. So we'll pass in props as an argument, and then we'll do div and then a paragraph of props.appointment.start.localstring. And this just formats the date appropriately to display in a paragraph. And we'll just keep it simple for now. This is all we need. And now to actually set up our calendar. So calendar is set up as a functional component, and we'll do it between a div with a height of 500 px. And this height is important. I did run into errors when not specifying the height directly. And in between these divs, let's set up the Big Calendar. So the first thing we have to do is pass in the localizer, which we set up at the very top, remember, in the const called localizer. Next, we pass in the attribute of selectable, and this allows the user to just directly click on the calendar to set an appointment. And we have next the events, and it will be equal to this.state.format events, because again, we need the formatted events. We can't just pass in events directly from our database. Next, we have min, which is the minimum time a user can make an appointment. And this, again, remember we set this at the business open time, which was 9 a.m. Max is the maximum time a appointment can be made, which is just the closing time of the business. Then we have the default view, which we'll set as bigcalendar.views.month. So this is saying the default view is a calendar that displays the month. And again, we'll see this more when we go and test it. Views, we pass in all views, which was the array we set up at the top. And this is just saying all the views the Big Calendar is capable of. So the default view is month, but it can also, the calendar can also display days and weeks as well. Next, we have the default date, which we'll just randomly set to July 7th, 2008. On select event. So this is a function that is fired every time a select event occurs. So when a user books an appointment, this function will be called. And we have it set up to do an alert. So we'll alert the user when they make an appointment of the start time. So that's what it is. Event.start is the start time of the appointment that the user booked and confirmed. And then we have onSelectSlot, and this is how we pass in the date to our React state. So this is how React state is aware of what date is selected from the calendar. So this is also an arrow function, and we do slot info, and then curly brackets, we do this.setState because we want to first save the start and end time to the local state. And start slot is slotinfo.start, and end slot is slotinfo.end. And then we also set our start display, which again displays our start time. So it's going to be slotinfo.start to local string. And then we also want to do this.handle click open, which will open our dialog box, which we'll set up in a second. So let's now set up our render method. So we'll start with the header of appointments, and then we'll display our list of appointments in a paper. So let's do paper and then a Turner expression, this.state.format events. So if the events are formatted, we do the question mark and then this.state.format events.map. And then for each appointment, we pass it in to the show to-dos functional component. And remember to pass in the key as well, because again, this is an array. And then let's do a line break, and then we can pass in our calendar with the Turner expression as well. Now we need our dialog box, and we'll work smart, and to save time, we'll just copy it from our post.js component and then edit it here. So in the dialog box, we'll want to display first confirm appointment. Then for the content text, we want to display the appointment time. So we'll do appointment time : and then this.start.start display. Then for a button, we can do this.handle appointment confirm, and we can change agree to confirm to keep everything consistent. And because we're going to be getting these appointments from Redux state, let's also set up our map state to props and map dispatch to props functions. So we'll need the DB appointments, which we'll set up in the user reducer. So we'll just do state.userreducer.db appointments. Then for dispatch props, we'll do event success. Then we'll do appointments, and we'll dispatch it with the action creator, as we've seen several times before. And finally, we'll just export default at the bottom with the connect function as well. So let's now set up the actions in Reducer to work with this. So as always, we'll set up the action types first. So we'll do appointment success, and we'll set it to a string of appointment success. And now we can set up our action creator, and we'll set it up in the same exact way we've seen before, and pass in a parameter of appointments, and then type of action types.appointment success, and then payload of appointments. Now let's go in our user reducer, and then first set up a property of DB appointments, and then set up our case statement. All right, and we're done setting up the Redux store, so we can go ahead and close these files. So let's now set up a route and a link in the header for the admin dashboard. So let's first import admin dashboard from ./profile/admin dash. Then we'll set it up as a private route because we don't want unauthenticated users to be able to access it. And next we can just set up a simple link in the header for our admin dashboard. So let's now go back to our admin dashboard. And the first thing we'll do is add .css to this import statement. Because again, remember, we're getting the CSS from our npm module and manually importing it here. And then let's just have a quick look through of our admin dash and see if everything's as it should be. And yes, let's just change the name of our function from date2string to date string2object, since that's what we have set up in our .then statement. And one more thing here, we need to set event to events in our big calendar. And then we'll need a closing tag for our big calendar because it is a functional component. And let's change get DB appointments to get appointment success, since again, that's what we set up as an action creator name in our actions file. And here in our render method, we'll need a colon before null. And that looks to be it. Let's now set up our server to handle our appointments. So let's go to our schema.sql file. And you'll see I have the SQL command set up here for our appointments table. So the first thing we'll need is AID, which is again just the primary serial key. the title of the appointment, which we'll keep short to just 10 characters. And then start time will be timestamp with time zone unique. So this is important because with time zone unique ensures that we're not saving multiple appointments in our database of the same time. So this ensures, the unique keyword ensures, that we won't run into any conflicting scheduling issues. Our database will only hold unique start times and end times. So there cannot be a overlap of appointments that start at the same time. And let's now go to our routes and then set up the SQL query. So we'll go at the bottom of our file and first do a router post to save the appointment. So it will be API/post/appointment. And then for the values, we'll need the title, the start time, and the end time. And again, this is going to be a very standard regular SQL insert query. So we'll just do pull.query and then insert into our appointments table the title, start time, and end time. And we'll do values $1, $2, $3, and make sure the values array matches up with the order that you declared the column names. And then after our SQL query, we'll just do comma and then pass in the values array. And after that, we have our standard query arrow function. Next, we'll set up our router.get statement, and it will be API/get/all appointments. And since all we need to do is get the appointments, we'll just run a query of select star from appointments, and that's it. And then our arrow function, we can do rest.json and then qrest.rows. So we'll get back our array of appointments in JSON format. And one more quick fix. In our admin dashboard, it should be .toLocale string with an E. And again, this is a given JavaScript function. And just converts our date to a displayable format. And in our user reducer, let's also get rid of the array, since again our appointments will already come as an array, so we don't want to put an array within an array. And now we can begin testing our calendar in our admin dashboard. So let's go to our app and then do a fresh login. And since this is the admin app, remember to log in with the admin. So we click on our admin dashboard, and I already have this pre-populated with dates, and the user can clearly see when their next appointment is on what date. And our admin calendar also displays the appointments, and as you can see, the default is a month view, but we can also do a weekly display of the appointments and also day-to-day displays of the appointment as well. And to change the range of dates, we just click on the next button. Now let's click on one of the slots to make an appointment. So let's click July 31st at 3:30, and you see we have a dialog box that's asking us to make the appointment at July 31st at 3:30. So you can just do confirm, and awesome, we see the booking was confirmed as an alert. And if we go back to our admin dashboard, yeah, we see July 31st at 3:30 right there. And our calendar is displaying our appointment as well, and we see an alert if we click on that appointment. And let's just make another appointment to really confirm. And let's check, and yep, it's working as expected. Perfect. So in this section, we'll finish off our admin app by adding a users component. And this component will allow the admins to delete users and their associated comments and posts. So let's get started by creating a users.js component in our profile directory. And as always, we'll start with our imports. We'll need the usual imports, and we'll also need a table because that's what we will be displaying our users in. And then we also need a dialog box because when a admin clicks on a delete user button, we'll need to open up a dialog box to confirm the delete. And then we can just initialize our users component with an empty div. So in order to delete a user, we first have to get all the users from our database. And we'll do this in the component didMount lifecycle method and do it through our Axios GET request. And of course, we'll set up the server and the SQL query after setting up our client side. So let's do axios.get, then /API/get/all users. and we do a dotted then statement, and then we save our users in the Redux state. So let's do res and then arrow function this.props.user success, which will again be our Redux action dispatch. And then we pass in res.data because, again, similar to posts and comments, the actual user profile is stored in res.data. We don't need the entire response with HTTP headers and other properties we don't need. And then we can just do .catch and then our console.log error. Then we can set up our usual pattern for opening and closing a dialog box. So we need state, and then we'll set it to open and UID, and open will be false, and then UID is going to be the user ID. So again, we'll do the same thing we did for deleting posts. When a user opens a dialog box, the associated user ID is saved to the React local component state. So again, this just makes sure we're deleting the correct user, and they're doing it this way ensures that there can't be any accidental deletion. And then we do a helper method of handle click open and handle click close. And of course, these are just to open and close the dialog box. So now we have our handle delete user function, and this is going to be the most complex function in this entire course. So first I'll explain what we're doing, and then I'll go into great detail about why we're doing it. And remember, in this function, we're deleting the user and all their associated comments and posts automatically. So a admin should not have to manually delete all the user's posts and comments. They can just delete the user and delete their posts and comments automatically as well. So the first thing we do is get the user ID, and we'll just save it in a const called user_ID. So the very first thing we have to do actually is delete all the user comments. We can't directly just delete the user, as we'll see in a second. So what we do access.delete /API/delete/user comments, and then we pass in the user ID, which will be used to look up all the comments the user made in our database. We do a .then statement, and then we call another axios.getRequest, because again, we need all the posts that the user made, and then we look up all the posts the user made with the user ID as well. And then our second .then statement is actually inside of our first one, and this is because we want the response from our axios.getRequest for the post IDs. We don't want to chain the .then statement on our first axios.delete statement. This is why we declare our .then statement, our second one, inside of our first .then statement. So our second .then statement is chained to axios.get /API/get/user post IDs instead of being changed to our first axios.delete statement. And again, we want the post IDs response from the server. This is why we're nesting our second .then statement. And inside of that .then statement, we do res arrow function res.data.map, because remember, it's an array of post IDs, so we have to do the map function. And for each post ID, we run a axios.delete statement. So if a user makes a post, other users can make comments on it. So when we delete the post that user we want to delete made, we also have to delete all the comments associated with that post. We can't just delete the post and then just have the comments just associated with nothing. So before we delete the actual post, we have to delete all the users' comments on that post, regardless of who made that comment. So we do this with .map, and we run a axios.delete call on each post to delete all the comments associated with that post. Our third .then statement actually then deletes the user posts. So once we've deleted all the comments associated with all the posts that our user made that we want to delete, we can just delete all the posts. And this is what we're doing in our third .then statement. We do axios.delete and then API/delete/user posts, and we use the user ID to look up those posts. Our fourth .then statement can then delete the user. And again, notice our fourth .then statement is inside of our third .then statement. Because why? Because before we delete the user, we have to make sure all the user's posts are deleted. This is why we chain our fourth .then call to our third axios.delete call and not to the main axios.delete user comments call. And you'll notice this because we indented our second and fourth .then call. This signifying that it's nested and not changed to the original axios.delete user comments call at the top. Then we just have our .catch error handling, and then we redirect the admin to our home page. So we're now done setting up our handle delete user function. And now let's go over why in the world are we even doing this. And we're doing this because of a PSQL concept known as a foreign key constraint. And I've referenced foreign key constraints and alluded to them in previous sections. And I'll break it down here and explain how it works. So remember when we set up our SQL table, we had a users table with the user's ID. We then used the user ID in the users table to reference the user ID in the post table. This means that the user ID in the post table is a foreign key, and a foreign key means a primary key in another table. So user ID is the same primary key in the users table, but it's just being referenced by the post table, which means it's a foreign key in the post table. So if we were to just delete a user that made a post, then what would that field in the post table be now referencing? Since we delete the user ID in the post table would be referencing nothing. So this is what a foreign key constraint is. We can't just delete users because it's being referenced by another table. So this is also why the first thing we delete are the comments the user made. Since even though the comments table is referencing both the user ID and post ID, the comments table itself is being referenced by nothing. It's on the bottom. It's referencing other tables, but it's being referenced by none of the tables, which is why we can just delete it without any foreign key constraint errors. There's no other table we have that's using the comments table column. So after deleting all the comments the user made that we want to delete, the user we want to delete made, you would think we can then just move up to our post table and then just delete all the posts that user made as well. And we can't do this because remember, even though the user we want to delete made posts, those posts may have comments from other users. So what do? We have to get all the post IDs the user made and then use those post IDs to look up all the comments in our comments table that are associated with that post. And then we have to delete those comments on those posts before we can actually delete the post associated with the user we want to delete. So this is what we do. We delete all the comments first associated with that post, and then we can delete the post. Then after we've deleted all the comments associated with the user and all the comments associated with all the posts the user made, we can then delete the posts all associated with that user. Then we can finally delete that user. So you might be thinking that this is just overly complex and there should be some hack or workaround to this. And who cares if the foreign key field is referencing nothing? And you have to understand this is done to ensure referential and data integrity. You can try to override it and find a workaround, but this is not recommended for the same reason mutating state directly is not recommended in React. It's an easy, short-sighted solution that might lead to problems and errors down the road. Especially when deleting data, it's best to be cautious and try to be as proper as possible. And I'll link a Stack Overflow answer in this resources section that goes over this in more detail. So let's go back to our app and finish setting it up. And we'll begin by setting up our dialog action. And again, we'll work smart and just copy and paste the code from our post.js component and then modify it. And we can also copy the table as well, since we'll be displaying the users in a table. So first thing, let's change the header of our table from search results to users. And we're going to be displaying users, so in our table body, let's change everything that's posts to users. So let's now work on our dialog box. So the first thing we'll do is change confirm delete to delete user. And then let's also change the content text to deleting user will delete all posts and comments made by user. And again, this will just let the admin know that deleting the user will not only delete the user, but also delete their posts and comments as well. And then in our delete button, we'll do handle delete user. And now we're done setting up the dialog box. Let's go set up the render user function. And we'll set it up the same way we did for render posts. We'll first pass in a parameter of user, and then we'll render each row separately. So let's do table row, and then each cell, let's first start off with a line break, and then display the username, and then on the next line, the user email. And then we'll also include a delete user button, which will, when clicked, activate the handle click open, and then pass in the user ID to local state. And then this user ID will then be used by the handle delete user function. And now let's begin setting up our Redux state. And we'll start with our map state props and map dispatch to props functions. So let's first set a property users, which will be an array of all of our users. This will be state.user reducer and then all users. And then we'll also need a action to save our users from our database to the Redux store. So let's do user success and then an arrow function users, and then pass in this argument to dispatch actions.getAllUsers. All right, and now we can set up the action types. So we'll do get all users and then remove all users. And now we can use these action types in our actions.js file. So let's go to the bottom and then create two new action creators, get all users and then remove all users. And remember to pass in a parameter of users and then also set it to the payload property of the get all users action creator. And let's now set up our user reducer, and we're not going to do anything fancy here, just the same thing we've been doing so far. So we'll need a empty array of all users, and then we'll set a case statement that will set action.payload to our all users property. All right, and let's now set up a route for this component. So in routes, let's import users from /profile/users. And then for the path, we'll do /users. And again, we don't need to display each user, so we don't need a dynamic route. We'll just display all the users in one table. So this is why we'll just have a route called /users. And now let's also create a link for it in the header. So we're done setting up our front end and we can move to the server. So let's first set up our routes. So we'll first need to get all the users from our database. So let's do router.get/API/get/all-users. And the SQL query is going to be very simple. It's just select star from users. So select all the users. Then we need a route to delete the user comments. So we'll do router.delete/API/delete/user comments. And then we'll need the user ID to delete the comments. So our SQL query is going to be delete from comments, where user ID is the UID we're getting from our front end. So remember, the comments table has a column that has the user ID of the user that submitted that comment. So this is how we delete all the comments associated with the user. Next, we'll need the post IDs for all the posts the user submitted. So we'll do router.get/API/get_user_post IDs. Then we'll need the user ID from our front end. And then the SQL query is going to be select PID from posts, where user ID underscore equals our user ID from the front end. And this will give us all the post IDs. And again, we're not doing select star because we don't need all the post information. We just need the PIDs, the post IDs. And now these post IDs we just got from our database, we'll use it in our next router.delete function. So let's do router.delete/API/delete user post comments. This is how we delete the comments associated with all the posts. And again, refer back to when we were setting up our front end if you didn't watch that part and want to know why and how these routes are set up. So we first need the post ID. So it would be rec.body.postid And then our SQL query is going to be delete from comments where post ID equals $1. So again, we're just deleting all the comments in the comments table where the post ID matches. And after deleting all the comments associated with the user posts, we can now delete the user post. So it will just be router.delete/API/delete/user post. And we'll use a very basic SQL delete statement. We'll do delete from posts where user ID equals /1. So this will delete all the posts associated with the user. And after deleting all the user's posts, we can finally delete the user. So it will just be API/delete/user. Then we're getting our UID, the user ID, from our front end. And then in our SQL query, it will just be delete from users where user ID equals our UID. And that's really it. That's all the routes we need to handle our admin users component. And let's also do one thing. Since these are mostly delete statements, let's just delete .rows from these router.delete calls. And we can actually leave .rows on our router.get all users request. And let's just also add a comma after all of our values in our pool.query function call. So let's now go back to our users component and see if everything's as it should be. And right away, we see in our handle delete user, we need to pass in the data, the user ID, and our /delete/user post comments Axios delete call. So let's do that here. So that's really it. We can now begin testing our admin app. So the first thing we'll do, we'll actually create a user in our regular app. And then after creating that user, we'll submit a post with that user in our non-admin app as well. And then after that, we'll then log into our admin app, then edit and delete those posts and comments and delete the user as well. So let's do that. So to save time, I've already created a user called testadmin100@test.com. And as you can see from the login, this is my app 5. This is not the admin app. So let's go ahead and log in. So let's first add a post and we'll just type in admin user test. And let's also add a comment on another post. So let's just pick this one, TTT, and then GGGA for the body of this post. So remember that when we go to our admin app. All right, and let's just add in admin user test for the comment as well. So let's now go to our database and actually check to see if all these properties are present. So let's first select all from users, and we see at the bottom, testadmin100@test.com is right there. So our user is in the database. And now let's check our post table. And yes, our post is right there, admin user test. And it's between post ID 63 and post ID 47. And now let's select all from comments. And yes, third one down, we have our admin user test comment. So great. So all of our data is saved in our database. So this will really let us know if our admin app is working or not. And remember, the admin app is a separate app with a separate login, but it connects to the same database. So let's log into that admin app now. So let's hit login. And as you can see, our login now has admin app 10. So this is now the admin app that we're logging in, and we're logging in with admin15@admin.com. Remember, this user is what we created on the Auth0 website. We can't sign up for the admin app. So let's first go to the forum, and yes, so we do see our admin user test posts, and also notice that these posts are not in cards as they were in our regular app. We're displaying the posts in a table. And here's our post as well, and it's on the TTT post with the GGGA body. And on our users component, we see our testadmin100 right here as well. So let's go ahead and delete this user, and we should see that the comment and posts made by this user are automatically deleted as well. And our dialog box gives us this warning, as it should. So as you can see, our admin user test post is no longer here. It was deleted automatically. And let's check the comment. And yes, our comment is no longer here either. And to be completely sure, let's also check the database. So let's do select all from users. And we don't see it here. our test admin 100 user is now deleted. And looking through the posts, no, it's not here either. Our admin user test post is gone as it should be. And let's also select all from comments. And here either, we don't have it. It's been deleted along with the post and user. So great, our handle delete user function is working as intended. Perfect. So in this section, we'll deploy our app we've been building so far to AWS. And before doing that, let's go over why you should even learn AWS. Well, first of all, AWS is the biggest cloud computing platform currently, and it does not show any signs of slowing down. So because it's the biggest cloud computing platform, people with AWS skills are in huge demand. So learning AWS is definitely a big career move and a good one. For this section, you will also need to sign up for an AWS account, but we will stay in the free tier and it will not cost you anything to build out the app and follow along. And before we start building out the complex app server, we'll first go over an easy Elastic Beanstalk deployment to get our feet wet. Then we'll go over the complex production setup. And we'll do everything from scratch. I'll assume no knowledge of AWS at all. So in the last section, I said that AWS is the biggest cloud computing platform right now. And here's a table that shows exactly this. So it's not just the leader in North America, but worldwide as well. So AWS actually has 33% market share, and this is in 2018. So that's pretty insane, considering that Google only has 6%. And Microsoft is second with 13, so not even half. And in terms of web hosting, we see that Amazon is a close second to the GoDaddy group, but Amazon web hosts very high traffic websites, and it's by and large the leader in that category. So it doesn't have as many websites as the GoDaddy group, but it's used far more frequently by very high traffic websites. So this really definitely reinforces why learning AWS is such an advantage. So let's get started. So let's first go to AWS. So the address is aws.amazon.com/console. And go ahead and just click on create a new account and just follow the steps. It's pretty straightforward. And after doing so, I'll see you on the other side. So here we have our main page of the management console. And what we're going to do is first set up a basic Elastic Beanstalk app. So Elastic Beanstalk is just a framework by AWS that makes it easy to deploy a app very quickly. So you don't have to do anything with Elastic Beanstalk, such as setting up a Linux server or setting up a VPC or anything, or security groups. You can just very quickly deploy an app to AWS. So this is how we'll get our feet wet. We'll just start with a very basic AWS deployment, and we won't even use our app. We can just go ahead and use the sample code provided by AWS. So let's get started. So go ahead and click on create new application. And then we can call it app 1, and then under description, we can just write app 1 React Redux Express app. So here in our app, we're going to create a new environment to launch our Express node server in. So let's click on create one now. And since we're going to be launching a Node Express server, we'll need a web server environment. And like I said, we'll just launch the sample node app. So in the pre-configured platform option, let's select node.js. So I haven't had any luck just directly deploying the Node.js app. So what did work for me is a little bit more setup. And so let's click on configure more options. So the first thing we'll need to do is modify the network, and we'll do this by setting a VPC. And we'll of course discuss VPCs in great length in a later section, but for now we can just set it up. So for the VPC, just choose the default VPC, and you don't have to set up anything. The VPC, the default one anyway, is created for you automatically when you sign up for an AWS account. So just leave the VPC as a default. In the subnet, we can also select the default one, and this should also be created for you when you sign up for an AWS account. And then we can just hit save. Now for configuring the instances, and this means the EC2 instances, which is our CPU or our web server. So under EC2, EC2 security groups, just select the default one. And that's really it. We can now save and deploy our sample node server. And it should take a little bit of time to launch and create this. So we can just skip that and go right to the end. So when it's done, it should say successfully launched environment app1-env. And then it should take you to the main dashboard, which should look like this. So we can actually click on the URL and see our deployed app. And here we are. It says, congratulations, your first AWS Beanstalk Node.js app. So we successfully deployed an app to AWS. Awesome. And this is a completely running app. I mean, it's simple, but it is an app. And we deployed it to AWS. So awesome, it works. So let's go back to our app and I'll show you a little more features of Beanstalk. So you also have configuration, which takes you to the page that we saw when we were first setting up this app. So if you wanted to edit anything after a deployed app, you would do so here. And next you have logs, which holds our error logs if we had them. We don't have any here, so we're not saying anything. And next we have health, which just tells us if everything is working okay, if all our underlying infrastructure and assets are working or they're failing. Then we have our monitoring tab, which shows us how much our app is being used. And next we have our alarms, which tell us if anything happened, and our managed updates, which just updates all of our resources. We have events, and here we see that our app successfully launched. So you have similar events that are displayed here. And then tags are just user-defined properties, and we can attach to this environment. So let's now go through the cleanup process. And this is important because, again, you don't want to be charged for using AWS. We want to keep everything free. So make sure you do this cleanup step. So first thing we have to do is terminate the environment. And just click on actions and terminate environment, and then just enter the name of the environment. So I said Elastic Beanstalk to manage resources of AWS. That means there are underlying resources that we can look at and see that are deployed to our Elastic Beanstalk, because Elastic Beanstalk is just an environment to manage these resources. Like the web server, the EC2 instance is actually a deployed resource to AWS. We just manage it in Elastic Beanstalk. So we can actually see that EC2 instance that was created for us by going to the EC2 tab in our console. So let's do that now. So if we go to our running instances, which means our running servers or EC2 compute units, we see there, right there, name app1-env. So this is it. This is the EC2 server that was deployed when we created our Elastic Beanstalk environment. And as you can see, its instance state is shutting down, which means our terminate environment command worked, and it's deleting this EC2 instance that it was managing. So the EC2 instance that was part of our Elastic Beanstalk environment is being deleted for us automatically, which is good. This is what we want. And we also have to release the Elastic IP address that AWS gave us. So we can go to the Elastic IP tab, and then we can select the Elastic IP, and it's going to be this one. And under actions, we can do disassociate address. However, when we click on dissociate address, we actually see that it does not exist, because remember, our Elastic Beanstalk environment is terminating as we are doing this. So it's deleting all of our resources that we use in that environment. We are deleting them manually because we want to be completely sure that all our resources are not being used. So what I'm showing you here is just like a safety net, just in case situation. But Elastic Beanstalk usually deletes them by itself. So this is why, even though it's saying this does not exist, it's fine, because this means our Elastic Beanstalk environment deleted it for us automatically. Alright, and it seems the environment is still deleting, so let's just wait a little bit. And this is what you should be seeing now. If it worked completely, you should be seeing the word terminate in parentheses next to the environment name. So perfect, this is what we want. We don't want to be charged for using any of these resources, so this is good. So awesome, congrats on deploying your first app to AWS. It's a huge step. And let's keep going in the next section. So in the last section, we successfully set up our Elastic Beanstalk app. In this section and in the following sections, I'll be going over the theory of how cloud computing in AWS works. And without this fundamental baseline knowledge, we won't be able to do anything meaningful in AWS. So for that reason, this section and the next several sections will be dedicated to theory and understanding how cloud computing works. So we'll start off very basic. How does networking work in cloud computing? So networking in cloud computing is actually done the same exact way as networking is done with hardware. All hardware required for networking, such as routers, switches, internet gateways, are all virtualized in cloud computing, meaning they're all represented by code. They're virtual. There's no physical routers we provision whenever we set up a route table. For example, in most web hosting services, take care of networking for you behind the scenes, but we'll set up networking from scratch. This is why you can just deploy a app to Heroku or DigitalOcean, and you don't really have to set anything up. And networking essentially determines how resources or web servers and databases communicate with each other and the wider internet. And VPCs, IP addresses, and subnets are the most important concepts and the most difficult ones to learn for networking in AWS cloud computing. And because every resource is deployed in a VPC, as we'll see in a second, if you don't understand VPCs, you won't be able to do too many things in AWS cloud computing. So this is why I'm dedicating such a large portion of the course to the theory and understanding of how it works. And here's a diagram of what we're going to be building. So we'll go over obviously each of these different parts in more detail, but this is just a basic overview. So we have our VPC inside of AWS cloud. So our VPC is basically our own virtual private cloud and our own subsection of the cloud. And inside our VPC, we have a public and a private subnet. So private subnet is not accessible by the internet. And this is important because this is where our database is going to be. We don't want random people just being able to access our database however they want. And for this reason, we place it in a private subnet. And we also have a public subnet, which houses our server, our Node Nginx server. This is publicly accessible because we do want users to be able to access our Node server over the internet. We don't want it to be private. So this is essentially what our app and our infrastructure is going to look like. And we'll go into more detail in the next section. So in the last section, we went over a basic overview of how networking works in cloud computing. We'll do our first deep dive and then look at public versus private IP addresses. So let's first actually define network. What is a network? A network is just a way to connect computers to each other. What we call the internet is just one of many networks. It is not the only network, but it is the biggest and it is one network. IP addresses, both public and private, is a way to identify a single computer on a network. And this does not matter if this network is the internet or not. Every network can have IP addresses, even private networks. So therefore, a private IP address is just a way we can identify a computer on our own network, and a public IP address is a way we can identify computers on the internet network or the public network. And since a private network is just a network we created, we can actually make the private IP address whatever we want. Granted, AWS does have some restrictions on what we can do, but the point is that we can make our IP address anything, even if that IP address is taken in the public IP address range. And this obviously raises the question, what if we want our private network to connect to the internet? How do we do that? And we'll go over that in that section about connecting a private network to the internet. So that's a separate section that's after the next one. But just try to really understand private and public networks. It is fairly important to understanding how networking works and how AWS works. So now we can discuss IPv4 addresses, which are a type of public address. So an example IPv4 address would be 10.12.15.22, and it's referred to as a IPv4 since there are 4 bytes which can represent the address separated by a dot. Each byte contains 8 bits and is therefore referred to as an octet. Since each octet contains 8 bits and each bit can be a 0 or a 1, there are 2 to the 8 different combinations. But we start at 0, so an octet can be a number between 0 and 255. Since we have 4 octets, we have 256 raised to the 4, which is around 4.3 billion different combinations and therefore IP addresses. And we don't enter in IPv4 addresses into the URL bar since they're resolved to a human readable format, such as HTTPS google.com through a DNS, domain name service provider. And IPv4 addresses can be either public or private. And we'll see this in much more detail when we set up our VPC. So in this section, we'll go over how to connect a private network to the internet. And how we do this is through an internet gateway. So when a request is made by a computer in a private network, a routing table checks to see if the destination is for a local computer or not. If not, then the request is forwarded to the internet gateway, which forwards it out of the private network and to the internet service provider, where it is sent to the right address. The internet gateway also receives requests from the internet as well. And the internet gateway actually has its own public IP address. So a network can have a public IP address even if it has thousands of private IP address. Every computer in the network that needs to connect to the internet does not need to have its own public IP address. And this is a very favorable configuration. I mean, imagine if you have thousands of private IP addresses and you needed a public IP address for each of those computers. That would be insane. So this is a pretty good setup. And the protocol used for sending and receiving data is called TCP. It's not necessary to understand how TCP works in detail, but it's simply a pattern and a blueprint that ensures data integrity and reliability. And connecting a private network to the internet is, again, the same as in hardware as it is for cloud computing. So in this section, we'll go over the VPC and I'll give you a short analogy of what it is. So VPC stands for Virtual Private Cloud. It's basically like a private part of AWS. So it's essentially your own cloud computing infrastructure where you can deploy resources. And resources such as EC2, which is a virtual computer, you can deploy databases, file servers, and things along those lines. And each resource is identified by a private IP address. And this is what allows you to communicate within your VPC. For example, a database has to communicate with a web server, but it's not going to do this over the internet. You're just going to communicate over the VPC. And communication is done through route tables. And communicating to the internet is through an internet gateway. And of course, we'll see this once we set up AWS. So the analogy I like to use to describe a VPC is a big office building. And imagine the company that owns this building has dozens of computers for each of its employees. The computers are hooked up through a local router to each other. And each computer has its own local IP address and communicate and send information to other computers on the local network. And the computers are also connected to the internet through an internet gateway. And requests outside of the local IP address are forwarded to the internet and then subsequently forwarded to its destination. And then the company also has its own hard drives, which are stored in a server rack. And for security reasons, the database isn't accessible over the internet. It's only accessible by the local network. And then there's also a file server that's also many hard drives housed in a server rack. And the file server is also only accessible by the local network. So imagine this building, and everything that is hardware in this scenario is virtual and hosted on the VPC in cloud computing. So that's how it works. VPCs essentially allow you to have a very robust and complex infrastructure that previously would have cost hundreds of thousands of dollars. And with cloud computing and AWS, you can have this entire infrastructure for only $100 or so per month, which is insane. And that's really the magic of cloud computing. So in this section, we'll go over subnets and subnetting. And subnetting is unfortunately one of the hardest things to understand about AWS by far. However, if you're going to do anything useful in AWS, you have to become proficient with subnetting and subnets. So what is a subnet? A subnet is essentially short for subnetwork, or a small subsection of the entire VPC. So our VPC is part of AWS and our subnet is a part of the VPC. And essentially it's a way to divide up your entire VPC for performance and security reasons. So for example, you want to deploy a database in a subnet that is inaccessible by the internet, while another subnet has web servers and it will need to be accessible by the internet. So you'll have two subnets, but they're still going to be part of the same VPC. And subnetting in AWS is done with CIDR notation, which we'll see in a second, instead of classes. So let's now talk about subnet masks. Subnet masks are a way to divide up your subnet into an approximate number of IP addresses. So an example subnet CIDR notation would be 10.11.12.0/24. So your entire VPC would be 10.11.2.0 and /24 would be the subnet mask, which would divide up your VPC. So /24 basically means the first 24 bits are to be used as a network prefix and are therefore unusable. Since IPv4 has 32 total bits, we have 8 bits left, which are known as a host address, and these are the usable IP addresses for the CIDR notation. Since 8 bits has 256 combinations, our subnet therefore can be any address that is between 10.11.12.0 and 10.11.12.255, since again we start counting at 0. And ones represent the network prefix and zeros represent the host address. So just know, if we're doing /24, that means the first 3 octets are unusable, because again they are representing the network prefix. Only the last octet, which is 0.0, can have any value at all. So this is essentially what allows us to have a subnet. It's the combination of a network prefix and a host address. And again, remember, /24 is the same exact thing as writing 255.255.255.0, and which is the same as having ones for the first 3 octets. And as we just saw, ones represent the network prefix. So the network prefix is not part of the IP addresses we can use. The IP addresses which we can use is represented by zeros, which is the last octet. So again, our usable IP addresses are any IP address between 0 and 255. And don't worry too much if you don't totally understand this. This will become much clearer when we set up our VPC in AWS. This is just a basic primer. So in the last slide, we saw our subnet and it was divided evenly into octets. So we had 3 sets of ones and 1 set of zeros. But a subnet doesn't have to evenly divide into octets either. For example, you can have a subnet mask of /19. So what this will look like is 19 ones followed by the remaining zeros. And as you can see in the third octet, it does not divide evenly. We have 3 ones and 5 zeros. And let's go to a subnet calculator and see how this works. So a subnet calculator basically lets you see how many IP addresses a subnet can have. So if we do 10.11.12.0/19 and we hit calculate, we see at the very bottom host/net equals 8,190 private IP addresses we have available to us. And as you can see, the host min is 10.11.0.1. And again, it doesn't count from 0. And you'll also see host max. It only goes up to 254 because the broadcast and the network address. And again, we don't have to go in too much detail about the network and broadcast addresses because there's special IP addresses you need to handle some utility functions, but just know that we have 10.11.0.0 available to us. It's just used for a special purpose. And that's same with 10.11.31.255, which would be our last IP address, but it's being used as a broadcast. So what I want to point out is our host max, which is our maximum IP address, it's 10.11.31. So just ignore 254, but 0.31. Why is it 0.31? Shouldn't we have any IP address within 255 and 0? Why is our host max, the maximum IP address, only 31? So to understand that, let's go back to our slide. So since the first 2 octets are all ones, both the octets are used for the network prefix. But our third octet has only the partial network prefix. prefix, and we only have 5 bits to use as our host address. This means the second octet can only be a number between 0 and 31, since 2 raised to 5 is 32, and our last octet is all zeros, so as normal it can be any number between 0 and 255. So altogether, this means that our subnet can be any address that is between 10.11.0.0 and 10.11.31.255. So let's continue talking about subnet masks. So we just saw /19 in the last slide, but it's better to just use increments of 8. Doing so will ensure that all the octets are either a host address or network prefix. So this means /8 will have the entire last 3 octets available as IP addresses. /16 will have the entire last 2 octets, and /24 will have the entire last octet. So this is why it's better to just have subnet mask in increments of 8. And of course, we'll see this when we set it up. And finally, here's a real world example of a VPC with a private and public subnet set. So the entire VPC is 10.11.0.0/16. Since it's /16, the entire 2 last octets are available as IP addresses. So 10.11 is the network prefix. We can't change this. This has to be the same. 0.0.0 are the last 2 octets. And since we're using /16, both of those last 2 octets can be used for the private IP addresses. And our first public subnet can then be 10.11.1.0/24. So /24 means our last octet is available as an IP address. And we can make it anything between 0 and 255. So for our first public subnet, we can have any address that's 10.11.1.0 and 10.11.1.255. So this gives us 256 total IP addresses we can work with. And this is the same for our second public subnet. For our third octet, we just do 0.2 for our second public subnet to distinguish it from our first public subnet. And the same way, we can have any IP address that's within 10.11.2.0 and 10.11.2.255. And our private subnet 1 can be 0.3 for the third octet. And again, this is the same for the private subnet 2 as well. All we do is we increment the third octet to help us distinguish our different subnets. And we do this because it's /24. So this gives us the last octet to have for the private IP address range. So this is essentially how it works. Don't worry too much if you don't completely understand it. I've purposely kept this explanation concise to just give you just enough so you can successfully work with AWS. Because this is not a networking course. Having a complete knowledge of subnetting and private IP addresses is overkill and not necessary. So it's okay if you don't totally understand it. It will make sense once we actually set it up in AWS. And again, you don't have to completely master subnetting because this is not a networking course, and networking is not what this tutorial is focused on. And you don't need to master networking to work with AWS. So this is enough. So let's continue on to the next section. So in the last sections, we went over an overview of VPCs and subnetting. In this section, we'll actually set up the subnets and VPCs in AWS. So right now, I'm here on the home page of the console of AWS. And to access the VPC dashboard, we go to Services under Networking and Content Delivery. The first option is VPC. So you can go ahead and click on that. And here we are on the VPC dashboard. So you see the Launch VPC wizard at the top, and setting up a VPC using this method, the VPC wizard, is a little bit easier, but I'll show you how to do it completely from scratch. And this way is slightly more difficult, but it will really show you how to set up a VPC in depth. So let's click on the VPCs tab, and then we'll click on the Create VPC button. So just give it a basic name. I'll just call mine VPC3. And for the IPv4 CIDR block, we'll do 10.1.0.0/16. And remember from the subnets overview section, 10.11.0.0/16 means we have the last 2 octets available as IP addresses. 10.11 is a network prefix, and those are unchanging. We can't do anything to them. 0.0.0, the last 2 octets, we can make it any number between 0 and 255. So remember, that from our subnet overview. And if you're unsure or you skip that section, just go back and I explain in great detail how this IPv4 CIDR block works. We can leave IPv6 CIDR block to none. It's not really necessary for this demonstration. And for tenancy, we can just leave it to default. We don't need to do dedicated. And just quickly, tenancy just means the underlying hardware of our cloud computing VPC. So as you know, cloud computing, there has to be actual servers somewhere in a data warehouse. So tenancy just means the physical computer that's in that warehouse. So dedicated means that there's a dedicated physical computer for our VPC. And there's a perception that if you have a dedicated physical hardware, that this somehow makes your app more secure or more performant, but there hasn't been any data to suggest this. Default, on the other hand, just means we share physical hardware with other AWS users. So our VPC is separate, of course, through software, but we just share certain hardware with other AWS users. And there isn't really a huge performance or security issue with this. AWS is very smart and they know how to make our VPC completely isolated from other AWS users, even though we are using the same hardware as them. So after this, we can just hit the create button. And that's really it. This is all we have to do to create a VPC. And now we can see it here listed with our other VPCs. And remember, we're using VPC 3 for this demonstration. And after creating our VPC, we can now create our subnets for this VPC. So let's click on the subnets tab. Then we can hit the create subnet button. So let's first create a public subnet, because as you may recall, we're going to build a VPC with a private and public subnet. The public subnet will contain our web server, which can be accessed by all the users on the internet, and we'll also need a private subnet that will house our database. And for obvious reasons, we don't want our database to be accessible by everyone over the internet. So this is why we'll have a public and private subnet. So we'll call our first public subnet React Fullstack Public 1. And then go ahead and select the VPC we just created for the VPC option. And then VPC CIDRs will just remain the same. And we don't need a preference for the availability zone. And then here we'll set up our IPv4 CIDR block. And it will be 10.11.1.0/24. Remember, /24 means we have only the last octet available as IP addresses. So when we deploy our server here, it will have a private IP address that is 10.11.1. anything between 0 and 255. So unlike our main VPC, that is 10.11.0.0/16, and the 10.11 is the network prefix and unchangeable. For our subnet public 1, 10.11.1 is the entire network prefix and cannot be changed. So the 0.1 after the 0.11 is the network prefix as well for our subnet, which means it is unchanging. And the 0.1 identifies our public 1. And we'll see this when we set up our private subnet, which will be 0.2. So we're actually done setting up the public subnet, and we can just hit create. And you can see our newly created subnet here listed among all the other subnets. So let's go ahead and create a private subnet. So we'll call it React Fullstack Private 1. And of course, remember to associate the VPC 3 for the VPC. And of course, we have our main VPC CIDRs, which is 10.11.0.0/16. So availability zone for a private subnet for our database, we do need to specify. So we can just use US East 1B. And we'll see this in a second when we set up our database, why having an availability zone is important. And then for the IPv4 CIDR block, we'll do 10.11.2.0/24. So again, 10.11.2 is the entire network prefix, and it identifies our private subnet as opposed to our public subnet. So our public subnet was 10.11.1.0, and our private subnet is 10.11.2.0. So the third octet is important. It is what allows us to distinguish between our different subnets. And again, this is because /24 means only our last octet is available, and that this is what determines the network prefix. And after this, we can go ahead and click create. And then we'll need another private subnet because AWS requires that databases have 2 subnets available. So we'll do Fullstack private to same VPC, and then availability zone. Make this different than what we set in the first private subnet. And this is important. Our first private subnet was in availability zone US East 1F, 1B. And we'll make this one US East 1F. And I think you can guess what our IPv4 CIDR block is going to be. It's 10.11.3.0/24. Again, the third octet is what distinguishes between our different subnets. So another way to think about this is, well, how do we know our private subnet 1 from a private subnet 2? And it's that third octet, 0.3. That's what's saying this is a different subnet from our first private subnet, which had a 0.2 for the third octet. So we can go ahead and click create, and we're done setting up our private and public subnets. So to make a subnet public, we actually need an internet gateway. So we can click on the Internet Gateways tab and click Create Internet Gateway. And since all internet gateways function in the same way, the only thing we need to do is specify a name for our gateway. And we can just call this React Fullstack. So we see our React Fullstack Internet Gateway here with our other internet gateways. And you can see the state is detached right now. To attach it, we actually need to create a route table first. And you want to think of route tables as a virtualized router. So the same router you have at home, it's virtualized here in our cloud computing AWS platform. So we can go ahead and go on the route tables tab and click create route table. So let's go ahead and name our route table React Fullstack public 1, and then let's select our VPC3. So this is going to be a route table for our public subnet. And we'll configure it in a second. Let's just first create it. And you can see this route table is now listed here. And now let's associate our internet gateway. So let's go to the Internet Gateways tab, and then we'll select our React Fullstack and then click on the Actions tab. And then here we'll do Attach to VPC. And then for the VPC option, just select VPC3. And then just click Attach. Once attached, we can now add this internet gateway and associated routes to our route table. So let's go back to our routes table tab, and then React Fullstack public 1, and then we'll do edit routes. So we'll click on edit routes, and we have an add route option. So let's go ahead and click that, and then for target, we'll do our internet gateway. So this is basically saying that every route that is not local will be routed to the internet gateway. So as you can see, our first route is 10.11.0.0/16, and the target is local, meaning these are local routes. So when a route has 10.11, it's routed to our local VPC and local computers. But if it's anything other than that, 0.0.0.0, then it's routed to the internet gateway, which then routes it out of our VPC and into the actual internet. And then we can just click Save Routes. So we're not quite done yet. We still have to associate our subnets with this route table. So let's go on Edit Subnet Associations. Then we have this table here with all of our subnets. And we only want to associate the public subnet because this subnet contains an internet gateway. So we'll just select React Fullstack public 1. And then click Save. And we can't forget our private subnets because we still need a route table for them as well. So let's create another route table called React Fullstack Private. And then for subnet associations, we'll do React Fullstack Private 1 and React Fullstack Private 2. Because again, these private subnets should not be in our public route table association, since that route table has an internet gateway, and we do not want this for our private subnets. So we can go ahead and click Save. And finally, we need to set up a security group for our web server. So let's click on the Security Groups tab and click Security Group. And under the Create Security Group tab, we see AWS gives us a nice summary of what a security group is. So it's basically a virtual firewall, and it controls the inbound and outbound traffic. So this is exactly the same as the firewall you have at home. And in our AWS VPC, it's simply virtualized. So for the security group name, we'll do React Fullstack Web SG. So the web server security group. And remember to associate it with our VPC3 that we've been using so far. And then we can click create. Now let's click on this security group. And then under the inbound rules tab, we'll do edit rules. So we'll keep it simple for now, and we'll need 3 rules. We'll need SSH to remotely connect to our web server. We'll need HTTP and HTTPS. So SSH, if you don't know, it's secure shell login, and it allows us to connect to our web server from our remote computer at home. And then it's always on port 22, and it's source custom. And under the IP address, you want to put your IP address. For privacy and security reasons, I'm not going to put my IP address here right now. But if you're setting this up, remember under the source, make sure you put your IP address at home. And if you're in a home network, your IP address is probably going to be whatever your public IP address is, and then /32 or 31. You can try it out and see if it works for you. But you do need the /. You can't just put just your IP address. And then we also have HTTP and HTTPS. These are the exact same protocols that you use to access the internet every day. And it's going to be on port 80, and it's always on port 80. And then the source is going to be 000, because again, we want all of the internet to be able to connect to our web servers. And the same with HTTPS. It's the same thing, except you can use SSL with HTTP. And the same with this, it's going to allow every source. And you see we have IPv4 and we have a comma ::/0. So we have IPv4 and IPv6. That's what the comma ::/0 is. So this again allows all IPv4 traffic and all IPv6 traffic as well. And since this is our public subnet that has our web server, we want everyone to be able to connect to our web server and website. So this is how we do it. And then we can just click save rules. So that's it. We've completed a basic setup for now. We'll continue building on this in the next sections. And we can leave outbound rules to all traffic. It doesn't matter if we send out traffic to anyone's. There's no risk to us at all. And for this reason, we can just leave all traffic as the outbound rules. So in the last section, we set up our VPC and subnets. In this section, we'll set up our EC2 instance and log into it using SSH. So first, let's go over what an EC2 is. I would say aside from VPCs, the EC2 instance is probably one of the most important parts of AWS. It's essentially the backbone of AWS cloud computing. It is the computing in cloud computing. It is a computer basically. However, it's not a physical computer, it's a virtual computer, but it has everything your computer at home does, such as CPU, RAM, hard drive, and everything else your computer at home does. So this EC2 instance is what will actually be used as a web server. So before cloud computing, you'd actually have a physical server to handle your website or web app. But here with AWS, this EC2 instance is what will actually be our web server. And a web server without an operating system is pretty useless, so we'll be using the Amazon Linux AMI 2 as the operating system. And obviously this is a Linux-based system. It's very, very similar to other Linux systems such as Ubuntu and Red Hat. And this version of Linux, the Amazon AMI 2, it gives us a lot of functionalities out of the box, and we can take advantage of those and significantly simplify our web server setup. Not to say that other Linux operating systems or even Microsoft operating systems aren't bad. It's just since this is the AWS tutorial, I thought it fitting using the actual Amazon AMI as the operating system. And of course, if you use a Microsoft Windows server, you do get a GUI, a graphical user interface. So if you prefer working with a graphical user interface as opposed to the command line, it's worth checking out the Microsoft Windows server. And now we can discuss SSH. So SSH means secure shell login. And SSH is essentially how we log into our Linux EC2 server from our home computer. Because if you think about it, how else would we do it? We deploy an EC2 server, which is essentially a computer, to AWS in their VPC. So how would we access it? Do we go to the AWS warehouse where our virtual server is and then log in through there? And obviously the answer is no. So we log in from our home computer using Secure Shell Login. And there's a couple of different ways you can use SSH. So the first one is PuTTY, which a lot of Windows users will be familiar with. I personally don't like PuTTY. I prefer Git Bash instead. There's nothing wrong with PuTTY, especially if you prefer a GUI, a graphical user interface. But I find it simpler just to work with Git Bash. You don't need to configure Git Bash to use SSH. You can just use one command and it will work right out of the box. With PuTTY, you actually do have to configure it a little bit. And I don't mind the command line, so I prefer using Git Bash, and I will be using it for these tutorials. But if you prefer PuTTY or having a GUI, definitely check out the PuTTY website. I'll link to it in the resources section. So with that out of the way, we can now actually set up our EC2 instance on AWS. So I'm here on the homepage of the AWS console, and we can go to the EC2 dashboard under services. And here we can just click on the launch instance button. So our very first option is the Amazon Linux 2 AMI. So go ahead and just select that one. And we want to stay in the free tier. So let's click on the T2.micro and it should say free tier eligible. So next we can do the configure instance details. And we want one under number of instances. So we can purchasing option, it's free tier, so we don't need to worry about that. Network is going to be our VPC3. Our subnet is going to be our React Fullstack public one, because remember, this EC2 instance is our web server. We want it to be accessible over the internet. So our subnet is going to be the React Fullstack public one. And then auto assign public IP, we can just do enable. And everything else we can leave default. And this storage volume, we can also leave default as well. And it's not really necessary for us to add any tags right now, so you can also leave this blank. For the security group, we actually do want to use our security group that we set up in the last section. And remember, that was the React Fullstack Web SG, the web server security group. And we can do review and launch. And it does say up top, it gives us a warning, improve your instances security. Your security group React Fullstack Web SG is open to the world. And remember, I did this because I left SSH to all IP addresses, and you want to change that in your app to your IP address. I just didn't want to put my IP address for privacy reasons. But in your app that you're building along with this, make sure you put your IP address for the SSH under the security group. And when we hit launch, we see this pop up for a key pair. We want to choose create a new key pair, and we can call this whatever, key pair 2 or 3, it doesn't matter. And then just go ahead and hit download key pair, and that's it. We can now launch our instance. If you did everything correctly, you should be seeing this page. And great, we see that our EC2 instance is running now, and it seems our security groups and subnet ID are the proper ones. So let's try logging into this EC2 instance. So go ahead and open up the terminal window, and then to SSH from Git Bash, we do SSH -I, and then the path to our key pair 8. And again, just to simplify things, I'm not hiding my key pair in anything. I'm leaving it under my downloads folder. But again, if you want to put this somewhere safe in your home computer, because again, you cannot download this key pair again. So if you lose it, you're kind of out of luck. But again, just to simplify things, I'll just leave it here for now and try logging into our EC2 instance using SSH. And also, I know it's a little hard to see, but there is really no way for me to zoom into this terminal window. I will include all of the terminal commands and a brief explanation of each in an article that you can easily reference. So I know it's hard to see these commands that I'm typing into terminal, but I can't really zoom in or anything. But like I said, I'll leave all the commands, every single command I do, in a written article in this module. So just reference back to it if you can't really see the terminal commands here. So back to our SSH. So it's going to be SSH-I and then the key pair. Because I'm in the downloads folder, it's just keypair8.pm for me. And then we need to log in as a user. For AWS, it's going to be EC2 user at. So this is how you SSH. You have to specify user first and then at, and then it's going to be the IPv4 public IP address. And you can see it on my screen on the bottom right hand side. So this is the IP address you put after EC2 user at. And then we can go ahead and click enter. And that's it. We're now logged into our EC2 instance. It was really that easy. And you can now see why I prefer Git bash over PuTTY. We didn't have to do any configuration at all. We can just directly SSH into our EC2 instance. And here in our EC2 instance, we can explore this a little bit. So we'll do cd/, and cd is change directory, / means home. So we'll do cd/, meaning change directory to the home route. Next command we can run is ls, and this lists all of our files and folders here in our Amazon Linux AMI. And exploring all of these is way beyond the scope of this course. There's so much here. For example, let's do cd/bin, and then if you do ls, and again ls lists all of the files and folders, you can see just how many files and folders there really is. And this is just one /bin directory. There's so many more folders in files that we would be here all week. So I'm just going to skip that part. If you are curious, just go ahead and you can explore it on your own. It is pretty fascinating stuff. And then you also have sudo nano, and nano is actually the text editor for this Linux EC2 instance. So the same way you have Atom, Sublime, VS Code, and other text editors, you have a text editor on the Linux AMI as well, and the specific one is called Nano. Any file in this Amazon Linux operating system you can actually configure with sudo nano. So just go ahead and run sudo nano and then the name of the file that you want to edit, and you can actually edit the code in this operating system, which is pretty cool. And you can also delete directories as well. So you can do sudo rm and then the name of the directory. And then you have the pwd command, which stands for present working directory. And if we click enter, we see /bin, because again, remember, we cd'd, we changed directory into this folder. So this is where we're at right now. This is the present directory. And this is it. Feel free to explore this Linux operating system. It's pretty cool. But we're done for now. We'll continue building this app in the next section. In this section, we'll set up our database and deploy it to AWS. So from the home page, let's go under services, and then under database, click on RDS. And RDS stands for relational database. And here we are. We're at the dashboard for creating databases. However, before we can create a database, we must first create a subnet group. So let's go on to subnet groups, and then let's click create DB subnet group. And a DB subnet group essentially is a way to protect our database against failure. So if you remember before, we set up 2 private subnets in different availability zones. And we did this because we're going to deploy them in a subnet group. So because they span 2 availability zones, there's a very low chance of our database being accidentally deleted for some reason in case a server in AWS fails. So this is the point of having a DB subnet group. It's to ensure reliability and security for our database. So here we'll first name it React Fullstack group, and then we'll just give it a description of subnet group for VPC3. And of course we'll need to choose VPC3. And then we can now add the subnets. So remember the subnets in their availability zone that we set up previously. And we only need 2. And these are both our private subnets that we set up when we were setting up our VPC in the beginning. So we can add both of these here to our subnet group. And then that's it. We can just click create. So we're now ready to actually create our database. So let's go on the databases tab and then click create database. So before selecting a database engine, let's go at the very bottom and click on the only enable options eligible for RDS free usage tier. Because again, we don't want to be charged for just practicing our AWS skills. So make sure you have this option checked. And then we'll of course use PostgreSQL as our database engine. Then we can click next. So we can leave all the settings in the instance specifications to default. We don't need to change anything here. For settings, we can first specify the database name, and this is going to be, let's just call it dbname5. In master username, I'm just going to use my username and then set a password here. And then we can click on next. And now we have the options to set up our VPC. So under the VPC, we don't want the default VPC. Let's select VPC3. And then for subnet group, let's select the React Fullstack group that we just created a second ago. And we don't want this to be publicly accessible, so we'll leave that to no. Availability zone, we will just leave as no preference. And we'll set up our VPC security groups in a second. So let's just leave this as create new VPC security group. And then the actual database name we'll set as the same, dbname5. So it's very easy to get confused between the database identifier and the actual database name. So for that reason, I recommend just keeping them both the same. So remember, in the last step, we set the database identifier, which is a name on our AWS dashboard, to dbname5. So we'll just keep it the same here to avoid confusion. The port we can leave as the default, and this is the default PSQL port 5432. And everything else we can leave default as well. So for backup, I'm going to do 0 days, and I'm going to do this because it will create the database much faster, but in a real app, you'd probably want to make this a week or two. But again, just to save time and just to create our database very quickly, I'll just set it to 0 days here. And everything else we can leave default. And we can go ahead and go to the bottom and create our database. So while our database is being created, we can take this time to set up our security groups. So let's go to the VPC tab and do this now. So let's go to the security groups tab, and then we'll call this React Fullstack DBSG. And this will be our database security group. And remember, this is different from our web security group that we set up. And of course, we want this associated with our VPC3, which also holds our web server. So after creating the security group, let's edit the inbound rules. So we'll do a custom TCP rule. We'll do port range 5432. This is the PSQL port. And then the source is going to be 10.11.1.0/24. Remember, this is the CIDR range of our web server subnet. So our web server subnet will be able to communicate with our database through the security groups. And this is how we do it. We block all other incoming traffic except traffic that's coming from our local subnet that the web server is in. And this is how we establish communication between our web server and our database, because otherwise how would we store data from our web server to our database? And the answer is we can't. This is the only way we can do it, by communicating through the local routing. And this is how we enforce that no other traffic is going inbound into our database. So this is a very important security measure, and one you really have to understand. Otherwise, if you did not do this, anyone would be able to send inbound traffic to the database, and this will obviously be very, very insecure. So we can go ahead and save the rules. And it looks like our database is available. So let's go ahead and click on it and add our security groups. So let's go ahead and click on the modify button. And then let's go ahead and select the React Fullstack DBSG that we just set up. And let's go ahead and click on the apply immediately button. And we can ignore that potential unexpected downtime. This is just a demonstration. So a question you might have is, if our database isn't publicly accessible, how would we connect to it? We know that our web server can connect to it, but how do we connect to it from our home computer, if we can even do that? And this diagram explains essentially how we're going to do it. We're actually not going to directly connect to our PSQL database from our home computer, because again, remember, our PSQL database is not publicly accessible. It is not connected to the internet at all. And it's also in a private subnet that doesn't even have a internet gateway. So what we do is we first connect to our EC2 instance, that is our web server, Then through our EC2 instance, we then connect to our PSQL database through the local routing. So this is essentially how we're going to do it. We're not going to directly connect to the database from our home computer, but we're going to do it through the web server, the EC2 instance on our VPC. So let's go ahead and do that now. Let's log into our EC2 instance with SSH. And then the first thing we need to do is actually install PSQL. And how we do this is sudo Amazon Linux extras install PostgreSQL 9.6. So this command is basically saying that we already have PSQL on the machine. It simply is not installed. So you get a lot of default software with your Linux Amazon AMI 2. And one of them is PostgreSQL. So we can just install it from our Amazon Linux AMI. We don't need to download it from an external source first. And I know these commands are hard to see, but unfortunately I can't really zoom in on the terminal. So I will have all the commands I run on the terminal in a text format in an article I'll link in this module. So just if you can't see one of the commands, just look it up in the text article I'll include also in the module. And I'll also give a brief explanation of each command as well in there. So you can check if PSQL was installed correctly by checking the version, and it seems it did. So we can see what commands we have available to us from PSQL by running the command psql-help, and this lists all the commands that you can use with PSQL. So let's now try to connect to our PSQL database from our web server. And remember, this database is not hosted on this web server. It's hosted completely separately from AWS RDS, but we're just going to connect to it here from our terminal. So we'll do first PSQL, and then we'll first need the DB name. Remember, this is the database name that we set when we were setting up the Amazon RDS, and it's going to be DB name 5. Next, we're going to need the host name, which is under endpoint on the RDS dashboard. Next, we need the port, which is under the -p flag, and it's going to be 5432, which is a standard PSQL port. And next we need our username, which was myname125. And we actually don't need to enter the password because it's going to prompt us to enter in a password anyway. So you wouldn't include the password here in your initial attempt to connect to PSQL. And let me try one more time. Let's see. And here we go. We've successfully connected to our database from the web server. This is awesome. This is unbelievable, right? We are on a web server and we connect to an Amazon RDS in a private subnet not accessible by the internet. Pretty cool. So we're not done yet though. We have to enter in our SQL commands that we set up in our schema.sql file in our project. To here in our terminal, we have to enter in the SQL commands so our database structure can be set up. And we can just copy and paste the commands. And now after creating these tables, let's do /dt. And there it is. There is our database right there and ready to go. Awesome. So in this section, we'll go over how to build the project for production. So we can't just directly build our development build right now. We have to make a few changes. The very first thing we have to do is update our auth file. So since this project is going to be running on a public IP address, we will need to add that IP address to our auth0 allowed callback URLs. So let's copy the public IPv4 from our EC2 instance and then paste it here in our auth0 dashboard. So we're going to need to add the IP address to both the allowed callback URLs and the allowed web origins. And now let's add our client ID to our project. And then we're going to need to change the redirect URI to our public IP address /callback. Since again, we're not running this in localhost anymore, since this is going to be a production build. Now we can actually set up our React production build. So to do this, we need to open a terminal in the client directory of our app we've been building, and then run the command npm run build. This will create a build directory that we can deploy to to our server. Because again, we're not running this in localhost, so there is no create React app or npm start as a development option. We deploy a build directory that contains files that are then sent to individuals in their browser, which is how they run the app. So we can now cut and paste this build directory to our server directory. So now our project is one app. We no longer have a separate server and client app. Our entire app is just one directory now. And this is essentially how we're going to run it in production. Because again, we're not going to run two separate apps in a production build. That would not work. So to overcome this, we combine both our React app and our Express server into one app. And now we need to make a few changes to our directory structure to make our app function properly. So the first thing we have to do is cut and paste the entire contents of the www file into our app.js file. And then we can also delete both the bin and www file. And since we don't have that file anymore, we have to go in our package.json, and then for our start and def start commands, we have to run app.js now instead of the www file. So we can do this here. So in the beginning of this section, we built our React project and we had this build directory, but I didn't really go over what this build directory is. So I'll do this here now. So as you can see, we have a couple of directories and a few files here in our build directory. So I'll go from bottom to top. We have service worker.js at the very bottom. This is essentially how we set up a progressive web app. And I'm not going to go too deep into progressive web apps right now, but it's basically how we use a website offline, how we allow our users to use our website offline. In just a brief description of how it works, it's essentially when our user first visits our website, all the code is downloaded and saved in cache. And when they want to revisit our website, instead of having to re-download all the code for our site, they simply access it from the cache that's already saved by the service worker. And that's essentially how progressive web apps work, and that's the purpose of the service worker.js file. And actually the pre-cache manifest and also the manifest.json both are responsible as well for the progressive web app functionality of React, and that's the purpose of these three files. Index.html is our main HTML file, and this is essentially what the server responds with to our client user. So our Express server will respond to user requests that visit our website with this one index.html file. And again, since React is a single page application, this one HTML file is all we need. And all the code for our entire website is going to be in this index.html file, which itself contains our entire React app. And this is different from other traditional web apps, such as those built with PHP, where you need a different HTML file for every web page. So this would be equivalent to having a separate HTML file, for example, for each of our components in React if we were using a traditional web app. But again, since we're using single page apps, this one index.html file is all the server responds with and what the user downloads in their browser. After that, we have the favicon.ico. This is the basically icon that you see in your web browser on the tab. So on most websites, on your tabs, there's a icon next to the name of the website. And this is essentially what a favicon.ico is. And asset manifest.json, again, has to do with progressive web apps. And then we have our JS directory. And this essentially contains all of our React code. So if we click on main and then a bunch of letters and numbers, this is our React project. If you click on this, we actually see some recognizable code. So this is essentially what React Build does. It takes all of our components and then deletes all the white space. Deleting all the white space makes your app smaller and thus faster to download. So this is essentially what happens when you run npm build. And of course, our CSS directory just contains our CSS with the white space deleted. Okay, and let's go back to our app.js file and make a few final touches. We actually need a new function to actually run our app in production. So do if process.env.node.env equals production. So process environment equals the production environment. And of course, Node will know this automatically behind the scenes that we deploy to a production build. We'll first do app.use express static build. So this is essentially saying our build directory will be served as a static asset, meaning JavaScript is considered a static asset, so it will be served from our build directory. Next, we have app.get, and then we do /star, meaning all the routes. We do rest.sendFile, and then path.resolve directory name, comma, build index.html. So what this is saying, for every route, serve the index.html file. And our index.html file is in the build directory, so we connect them with the path.resolve dir name command. And again, /star, meaning every route. Every route serve the index.html file. Since again, React is a single page app, we only have one file to serve. So this is what we do. And by doing this, we allow navigation inside of our React app. Because again, remember, in a traditional web app, we would not do this because every route we would request a separate HTML file. And React, of course, does not work like that. So by doing this, we allow for navigation with the React router. This is how we can navigate inside of our app. Since we're not requesting a separate HTML file for every route, then we simply serve this one route, which allows us to navigate within our app without having a separate HTML file for each route. So this is essentially what this function is doing. And now we want to make app.js the root file. So let's move it out of the main directory and place it in our root directory. And now, because we did this, we have to change our routes path to ./main/routes. And we can also get rid of this command here. We don't need this. And since we combined our www file and our app.js, we don't need this require statement here either. And to avoid conflicting this app with other apps, let's change our port from 5000 to 5010. And we don't need either of these commands here either. And this is it really. We have successfully set up our React app for a production deployment. And even though this is a production build, we can actually run it in localhost by running it through our Express server. So again, remember, in our previous development build, we were running both the Node server and React app separately, and they were able to communicate with each other through a proxy. We've now built our React app and we have it here in our Express server. And remember, we're serving it as a static asset, a JavaScript file. And this means we should be able to just run the Express server and have our React app work through our Node server. So let's try this. Let's delete this if statement and just set it to true so we can just run it in our local host. So let's do npm start, which starts our Node server. And let's go to localhost 5010. Because again, this is where our Node server is running. And there we go. We see our React app here in our Node server localhost. So this is how we do it. This is how we run our React app through our Express server and have it run as one app. And you can see in our console, we are being served the static assets, meaning when we request a route, we're getting served our React app in the browser, which allows us to see it here. And this is it. Our React app is working with our Node server. So in this section, we'll deploy our production build of our app to our AWS web server. So the first thing we have to do is upload all of our files to a GitHub repo. And you can also use Gitbucket as well. I'll just use GitHub here for our demonstration. Now let's log into our EC2 instance. And the very first thing we'll have to do is install Git. So we'll do sudo yum install git. And of course, I already have it installed, so it's telling me that I already have the latest version. So your screen might look different from this if you haven't installed git yet. After this, we have to do git clone to actually clone our React Prod 9 project into this Linux server. And yes, if we check, there it is. There is our React Prod 9 here hosted. Well, not yet hosted, but here as a directory in our EC2 instance. So we have it here. Awesome. Let's cd into it. And here is all our files that we set up. We have app.js and our React build folder. So before we can do anything else, we actually have to now install npm and node here in our Linux server, because remember, this is not our home computer that has Node already installed. This is a completely separate computer, if you will, and we don't have Node and npm installed here. So we'll do this now. So here's the command to download nvm. This is Node version manager. This is essentially what we use to install npm and Node, and I definitely recommend doing this. This is a much easier way to install Node and npm, to just have a Node version manager. So of course, I'll also leave this command in the article so you can just copy and paste it, and you don't have to really memorize this here. So don't worry about the specific command, just know that it downloads and installs nvm. So if we run nvm version, we see that it doesn't work right now because, as it's telling us, we have to close and reopen our terminal to start using it. So let's do it now. And now if we run nvmv, we do see that this command is working now. So good. So again, remember, nvm is not Node or npm. Nvm is Node version manager. It is what we use to install npm and Node. So this is what we'll do now. We'll run the command nvm install and then the version of Node and npm that we want. So let's first actually see what versions we have available to us. And we do this with the command nvm ls remote. So list the remote versions that we can install. So I'll just pick 10.15.2 because that is the stable version at the time of this recording. And we'll go ahead and install. And if we check node v, so node, again, this is the actual node we also have on our home computer. So if you check the node version, we do see that it did install. Perfect. And along with that, we do have npm installed as well. And we can see this with npm v. So let's go ahead and test out npm. Because remember, when we uploaded our code to our repo, we did not include the Node modules. And this is standard practice. We don't upload the modules along with our repo and then git clone them into our Linux server. We install our Node modules here in our Linux server through the package.json file. So let's do it here. Let's run npm install like we do on our home computer. So if we run npm install, we do get an error. It's saying error e-access permission denied. So we don't have permission for accessing our /react prod 9. So how do we fix this? So to have write and read access on this directory, we do sudo chmod 777 and then name of the directory. And this gives us permission to run the npm install command. So if we run npm install now, we see, yes, it is working. It installed all the Node modules we need. Perfect. So great. This is it for setting up our project on the Linux server. We'll continue building out our deployment in the next section. In the last section, we git cloned our app to our Linux server. In this section, we'll attempt to run our app from our server. So here I've already SSH'd into our Linux instance. So let's cd into our React Prod 9, which is our built React project. And let's just hit npm start. And it seems our app is working. It's saying Node is serving our app.js file, which is our app. So let's try to access it from our public IP address. So it doesn't seem to be working here. Let's investigate why. So let's go back to our terminal and let's open up our main app.js file. And as you can see here, we have our port to 5010. So let's see if this will make a difference. Let's see if it's the port we're not getting right. And of course, before we are able to access the port, we have to add it to our security group. So let's do this here. And we do need to restart our app again. And there it is. There is our app. So I just wanted to show you that even though we are running it on a public IP address, we can still specify the port. So you're not limited to just using the default ports to run your app. You can, just like your local host, use different ports. So this is what I wanted to show you with this demonstration. But we do want to run our app on the traditional HTTP ports, which is port 80. And this is, again, the default internet HTTP port that every single website uses. You don't specify the port when you visit a website because it's the default port 80, which 99% of websites run on. So how do we do this? Let's go back to our terminal. Let's take the naive approach and just change the port to port 80 and see what happens. And unfortunately, it's not that easy. We do get a permission denied port 80. We can't just run our app like this on a HTTP port. How we're going to actually run our app is through Nginx, which we're going to set up in the next section. But before we do this, let's solve another problem. Right now, we have our app running, but to do anything else, we have to stop our app, do what we want to do, and then run it again. And this is, of course, not ideal because if we want to, for example, log out of our terminal, we're going to have to stop our app. So how do we keep our app running in the background without having us to manually keep our app running? And the answer is we're going to do this through PM2, which is a npm library that allows us to automatically start and keep running our app without us having to manually do it. And PM2 also restarts our app if and when our app crashes. So it's a very useful library. It's used in the vast majority of production builds. And I'll show you how to use it here. So first, let's change our port back to 5010. So let's now install PM2. So we'll do npm install -g PM2. And -g essentially specifies that PM2 will be installed globally. And this is important. So installing globally is important because, again, how else would PM2 do its job? If it was installed just in our local project, if the local project stopped, PM2 would have to stop. So in order for PM2 to do its job properly, it has to be installed globally. So even though our local project stops, it can still restart it because it's outside of our local project. And again, I know the commands are a little bit hard. If you didn't watch the previous sections, I said I will leave all the commands in a text file with a brief explanation of each, which will make it a little bit easier for you to see all the commands I wrote, even though I know it's a little bit hard to see it on the terminal here. So if there's ever a command you're unsure about, just see the article I'll link in this module. And after installing it, how we use PM2 is we do PM2 start in app.js. We do not use npm start anymore. We hand that responsibility off to PM2. And once we do this and go back to our browser, we see our app is running again. And again, it's running in the background. We're not manually having to start and restart our node server. And let's see another command. Let's see PM2 list. This gives us a list of all the apps that are running by PM2 in case we have more than one app. To stop a running app, we use the command PM2 stop app0. App0 means the name of the app, which is app. 0 is the ID of the app. And you can see this with the PM2 list command. Under our list, you can see app name, we have app, and then ID is 0. So that's how we stop an app. And if we go to our browser, we can see that it is no longer working. So our app did stop. And similarly, we can restart our app with the command PM2 restart app0. And you can see in the browser, our app is running again. And then to delete our app from the list of apps, we do PM2 delete and then app0. And this removes our app permanently, so we cannot even restart it. And the last command I want to show you is PM2 start app.js -imax. And what this command does is it runs our app in the maximum amount of computer cores. So remember, our server is a computer, and like any computer, has a CPU with multiple cores. And this is what our command does. It is a cluster manager that runs our app separately on each core of our CPU. So this is what Imax is saying, the maximum number of cores. Use the maximum number of cores our server has available. And since Node is single-threaded, meaning it runs on one core at a time, this maximizes our performance and it maximizes our efficiency as well for our server. And this is essentially how you would run PM2 with clusters. So this is it for our PM2 demonstration. We'll go over Nginx in the next section. So in this section, we'll continue our production deployment and set up Nginx. Nginx is, remember, our reverse proxy. It's not our web server. Our web server is Node. Our Nginx reverse proxy is essentially going to sit in front of our Node server and help us with load balancing and other security functionality. So the first thing we'll do is install Nginx. And we do this with the sudo Amazon Linux extras install Nginx 1.12. Nginx is already included in our Linux AMI, so we don't need to download it from a source. We can just install it here from our Amazon AMI. And I know these commands are a little hard to see, and as mentioned, I'll leave every single command in an article that you can just easily copy and paste. So please just bear with me if it's a little bit hard to see on the terminal. So after installing Nginx, we can cd into our Nginx directory. So it's going to be cd/etc/nginx. And if we do ls, we see all of our Nginx files here. Feel free to look around and play around with these files, but the main one we're going to be concerned with is the nginx.conf file. And this is a file we need to set up to make our Nginx work with our React Express project. So nginx.conf is just a configuration file that sets up our Nginx project. And we can edit this file with the nano text editor. So let's go ahead and run this command and begin editing our nginx.conf file. So the first thing we can do is get rid of the root directive in the server configuration. And the root is just saying the root of our project. So right now we have it to usr/share/nginx.html. This is the default page you see with Nginx that you set up. So this is obviously not what we want. We want Nginx to work with our React Express project. So we can go ahead and delete this root directive right here. And then for the server name, we can just say server1 for now. Now we can go to the location / and then add a few commands here. So the first one, we're going to make the root our React Express project, which is going to be /react_prod/build. So again, remember, this is our React project. So this is saying for every /route, the home route, we go to the root React directory. After that, we do index, and then this is going to be our index.html file. And then try file $URI/index.html. This is saying try our index.html, and for every subsequent route, also go back to our index.html, because again, our React is a single page application. We're not going to be requesting a separate HTML file for a route change. So this is why we do this. We basically just keep redirecting to our React project. And this is what allows us, a user, to navigate within our React app. Since every route is basically just redirecting to the index.html file, and since our entire React app is one HTML file, our app will just keep serving that same file, which is how we allow users to use React Router and navigate within our app, within a single HTML file. And this is how it's done. But now you may say, well, we have a React app that we need to navigate within, but we also have our /API calls. So how do we take care of that? Because we're not going to use our API calls with the React Router, right? So we do this with this setup right here. I'm going to show you. So we actually declare another location directive. This time it has a route /API/ and then blank. So this is saying if the location is /API and then /whatever, our API call, we run this code in this directive. And this is boilerplate code. This is essentially how we set up our API calls with our React app. So again, this is just boilerplate code. We're doing a proxy request to our Express app from our React app based on the routes. And the only thing we have to edit here is the proxy pass directive. We do HTTP and then our IP address that we have for our EC2 instance. And you also have to pass in the port we're using as well. So this is essentially going to take our public IP address with the non-standard port, which is 5010, which is not the standard port everyone else uses for HTTP and accessing websites. So what this is going to do is going to pass it on to the default port 80 for HTTP, which will allow users to access the website as normal. And we can go ahead and save. So we can now test our app to see if it works by using nginx-t. And this doesn't work. So remember to always use the sudo command as well. That's how we get permission. And you can see right there, it says the configuration file /etc/nginx/nginx.conf syntax is okay, test is successful. So it did work, awesome. And after editing our nginx.conf file, remember to always restart nginx. And we do this with the sudo systemctl restart nginx. And you have to do this, otherwise your changes are not going to be reflected in your app. And then I'll also show you the command for accessing the error logs. And this makes debugging really easy. And the command is just sudo nano /var/log/nginx and then /error.log. And we don't have anything here because we haven't made any errors with our nginx, but if you do have errors, they'll be listed here. And this will allow you to easily debug your nginx code. So this is it. We can now test our app. Let's go to our public IP address. And as you can see, we are at the public IP address using the standard port. We're not on port 5010. We're on the regular HTTP port, and our app is working as usual. Awesome. So this is a good start. We'll continue building on this in the next section. So in this section, we'll go ahead and put the final touch on our app and set up our database with our Express app. So how we do this first is we're going to edit our db.js file. And remember, this is the file that contains our login info for the database. And currently we have it for our localhost database, but we're now going to switch that to using our Amazon database. So here in our db.js file, we're first going to set up the right host. So we're not on localhost anymore, we're on the Amazon endpoint. And we can just go ahead and copy and paste this here. And then we need the user and the port. And also add in a command of SSL equals true. We need this here as well to communicate from our app to our database. And go ahead and enter in the other information. I'll see you on the other side. And after this, let's go ahead and access our database from our app. And again, this is something we've seen before. So it's going to be PSQL and then -d dbname 5. Remember, this is not the database identifier in Amazon RDS. This is actually the name of the database you set before. And this may or may not be different than the identifier for Amazon RDS on the dashboard. Then we do -h, which is just the host name, and we can just copy and paste that. And -U is the username, and then -p is just the port. And then we enter in our password, and this is it. We're here in our database. And this is all we have to do to set up our database with our web server. And finally, we can now test our production deployment. So first, let's go ahead and log in, and let's just add a post here. And awesome, we see it right here immediately afterwards. Now let's add a comment. And perfect. As we should see, we're seeing our comment immediately. And if we go back to our forum and back to this post, yep, our comment is still here. Perfect. So we are retrieving it from our database. All right, and editing is working as well. And let's go and just delete this comment. And yes, so it is out of here. Let's make sure. And yep, it is deleted. Awesome. All right, let's go to our profile dashboard and let's edit this post we just made. All right, awesome. So we are seeing our edited post now under the posts. And let's now delete this post. And yes, it is gone. And awesome. And we do see status 200, meaning okay. So yeah, this is it. We have successfully set up our app. It is working perfectly and communicating with our database. Awesome. So we're actually going to clean up all of our Amazon resources in the next section. So please do watch that one. You definitely want to delete all the resources you set up if you've been following along. Not doing so, you actually will incur charges to your card if you do not do so. So don't skip the last section, watch it and clean up all the resources if you've been following along. Thanks. Okay, so in this section, we're going to go ahead and clean up our resources that we've been using because we do not want to incur charges. So let's get started. So this is not like the Amazon Beanstalk demonstration. We do have to delete everything manually. So let's first start with our EC2 instance. So we select our EC2 instance, we go on Actions, Instance State, and then we just click on Terminate. And then we just select Yes, Terminate. And then for our database, we select our database. Under Actions, we do Delete. And you're going to see that this database has deletion protection option enabled. So let's go ahead and fix this. So let's click on the database and click on Modify. If you go all the way down, you'll see the delete protection section. So just uncheck this box and then we just confirm. And then now we can delete our instance and you don't have to create a final snapshot unless you want to reuse some of the data from your project. But if not, you can just uncheck this and then type in delete me and then we can just delete. So on our dashboard under status, we should be seeing deleted. So perfect. So we don't have to worry about our database now. So now for our Elastic IP, we can click on the address and then Actions will do release addresses and then confirm release address. And then now we can delete our internet gateway. And that's it. We don't actually get charged for any other resource such as VPCs and subnets, route tables, or security groups. So you can actually just leave all of those as is and deploy other resources using those resources. So yeah, there's literally zero charges for using VPC, subnets, security groups, and route tables. So we don't have to delete them at all. And this is it. This is all we had to do. And we are finished with the course. Thank you for staying with me if you did through all these lectures. Thank you.